Hello and welcome, I'm your Cinemachine, and welcome to my free course on making a really awesome Unity 2D game using physics. Here we are going to learn a ton by making this game. The game is relatively simple in terms of game design, but still requires us to learn a lot of interesting things. We're going to learn about physics, learn about inputs and sprites. We're also going to learn how to implement all kinds of mechanics, for example, handling the collision detection, handling the landing detection. This one is going to be interesting. We're going to need to learn how to manage physics and so on. We're also going to learn how to make the terrain using SpriteShape and various other 2D tools, learn how to set up the UI, learn how to handle music and sound effects, and also learn how to make our game playable with a gamepad or touch. So yeah, building this game will be a lot of fun and we're going to learn a ton. We're going to start from a completely empty project and go step by step until the final polished game. Everything is shown on screen. There was nothing that was done off screen, so you can follow along and build the game yourself. There are project files and assets downloadable from the link in the description. Those are all completely free. This course is also very much targeted for complete beginners. I won't be teaching everything starting from absolute scratch. However, if you are more of an intermediate user, you can still learn quite a bit from this course. Like I do in all my courses, I will be teaching you the best practices. I'll be teaching you how to write good, high-quality, clean code. This is not a throwaway prototype made with bad practices. Nope. This is a properly built project. As always, I'm teaching you production quality code. The code that we're going to learn how to write here is exactly the same that I write in my own professional Steam games. So we will learn very important concepts, things like separating logic from visuals, things like how to choose good names for your variables and functions, how to separate your logic properly between multiple different scripts instead of having one massive script. I'll also be teaching you why you should not make everything public and why you should avoid strings as much as possible. So like I said, we're going to learn the proper way of building a great game. It is going to be nicely structured with high quality clean code. Now if you're new and you don't know me, here's a little bit about me. So I've been a professional indie game developer for over a decade at this point. I started programming when I was 10 years old, so that was 27 years ago. I started making games with Flash back in 2008, and then I moved on to Unity in 2013 and have used it pretty much every day since then. I have 9 successful games published on Steam covering a wide range of genres. My main skill set is very much programming. I love writing code, I love CSharp specifically, and I'm a big fan of writing good, high-quality, clean code. That's really the only way that I can make the complex games that I make. For example, my last game, Think Gardens, this was 40,000 lines of code. It's a very complex game with a ton of systems, a ton of interlocking things all connect to one another. I would not be able to write such complex games without writing good, high-quality, clean code. So that is why I focus so much on good practices, and that is why over here I won't be teaching you those same good practices. I want to give you the knowledge so you can be capable of building pretty much any game you can imagine, regardless of complexity. Then also 7 years ago, back in 2018, I started this YouTube channel to basically share my knowledge with all of you. I have since then made over 800 videos, so lots of tutorials covering all kinds of topics, and some full-length courses just like this one, making games step by step. So I already have quite a lot of experience in both making my own games and in teaching game development. Okay, so let's look at the final game we're going to build. Okay, so let's take a look at our final game, starting off over here with the main menu. Very simple, really just a functional main menu. So we can go ahead and just play. And then here we are on the first level. So right away we can see how the level is set up. So we can get a nice overview of the entire level. That way the player can make a decision. So do we go for the easy landing over here with a multiplier of 1? Or do we go for the hard one over there with a multiplier of 5? We can also see where all the coins are, all the fuel and everything. We can see everything looks really nice, really polished. And as soon as I press a key, it is going to start moving. So as soon as I press, yep, there you go, now I'm controlling my lander. It is falling down with physics and I need to control it perfectly. So I need to move left, right, and so on. Now if I want, I can go for the easy one, but nope, let's go for the hard one. So let's pick up some fuel, pick up a bunch more coins for some extra score. And over here for the landing, we need to make sure to land nice and softly. Just like that. Yep, there you go, we've got a nice successful landing. Now we can continue and go on to the next level. So here we are, and again, we can see the whole level. We can decide upon our plan over where we're going to go. So let's go ahead, start moving. And on this level, we also have a new interesting mechanic. So here we've got the cargo transport. So you basically need to hover over this area in order to pick up some cargo. And there you go, the cargo spawns, and it is being controlled using physics. So we need to be careful. If the cargo hits the terrain, we'll lose. So let's make sure to pick up all of these things, grab some fuel, and over here we can pick up some more coins. So grab all of them, and here's the drop-off area. So we need to hover over there in order to drop it off. And there you go, we've dropped it off, we got some bonus score, and now we can go back and try to achieve our landing. Our landing is down at the bottom of this hole, and we currently got low fuel, so we need to make sure to land nice and soft and quickly. Yep, there you go, just like that. Alright, so here we are on the next level. So this one is nice and different. We can already see a bunch more mechanics. And of course, we can also lose. So if I move ahead, on this level we've got some nice moving asteroids. And if one of them touches me, yep, there you go, I've got a nice crash. So on this level, let's go ahead and let's pick up a bunch of coins. So all of them really nice like this. Then over here, let's pick up a key. So we've got a nice key door system. And using this key, we can now move around, make sure to dodge those, and currently got low fuel. So let's bypass that asteroid, pick up some more fuel. And now try to deliver this key. Make sure that the crate does not hit the sides. Yep, there you go, I've got it. Now let's see if I can actually make it through. So I'm almost out of fuel, let's see if I can land. And yep, there you go, nice successful landing. Then here we are on a very complex level. We can see we've got some keys, we've got some doors, we even have some turrets. So on this one I can start moving around and I have to go through this area over here. First gotta bypass all of these, pick up a bunch of coins. Now over here, if I want easy mode, I could just go ahead and land there, but I don't want. I want to go for the hard mode. So let's go ahead, pick up the green key. And now over here, I've got to go nice and easy. Land over there, get some fuel, put up the green key, open up the green door, pick up the blue key so that I can go onto the blue door down there, pick up some more stuff, and got some more fuel. And now let's go open up this nice horizontal door. And yep, now push through it, and now we've got some nice turrets. So I've got to make sure to dodge those turrets, make sure those bullets don't hit me. And yep, there you go, I've managed to get through. And now just another nice soft landing, so gotta make sure to get it easily. So like this, and yep, there you go, another nice landing. And now here we are on the level with another mechanic, the wind zones. So over here, as I go inside, basically these zones push me into one direction, so I've got to keep forcefully getting myself and try to dodge the sides. So here I go again. Let's try going left over here, then going right over here on this one. Then this one pushes me down into the left. Let's see if I've got enough fuel. Then this one pushes me up way too much. And yep, there you go. Let's go ahead, pick up some cargo. And now with this cargo, let's move out. Make sure I can reach the other side. Pick up some coins, get some nice score right here. Get all of them. I've got low fuel, so let's pick up some more fuel. And now go pick up all of those and continue going. And down here, there's the cargo area. So let's pick up some fuel, drop off the cargo, get a bunch more score. And afterwards, now I can go here and I've got a nice, easy, soft landing just like that. Okay, great. And if there it is, we've got a game over and we have our final score. There are project files and assets downloadable for free for every single lecture in this course. And there's also a premium version for this course that will contain some real nice bonuses if you can afford them. All the video lectures, those are all completely free over here on YouTube in this video. The project files as well, those are also completely free. So you don't have to pay 1 cent to learn all the knowledge on how to make this really awesome game. But if you can't afford it, if you do have a few bucks to spare, if so, then the premium version has some really nice bonuses. First of all, obviously it has no YouTube ads, so there's nothing to interrupt your learning process. Then it also grants you access to my private Discord and private live streams. I do those every single week, and I'm there to answer whatever questions you want, or really just to chat. Then the premium version also has priority Q&A, meaning I answer questions on that version first. But then of course I won't be going through all the comments on this YouTube video and answering as many questions as I can. The premium version also has a really nice companion project. This contains frequently asked questions and quizzes for every lecture in this course. These help reinforce what you're really learning. So if you make the effort to pay attention in the course on every lecture, you should be able to answer all of these correctly. And if you do, you will ensure that you are actually really learning. If you take the time to go through all of these, then I guarantee you will gain all this knowledge. So watch the video lectures and then go on the companion project to read the summary, do all the FAQs and quizzes. Make sure you do this if you really want to learn. Alternatively, like I said, if you can't afford the premium version, that's fine. I made sure to include all of the titles for the questions and quizzes at the end of every single lecture. So the premium version has that path basically pre-prepared for you. You just have to follow it. Whereas over here on the free version, if you can't afford it, you can just use that last slide on every single lecture to basically guide yourself to go gain that extra knowledge. Then the next bonus is the CodeMonkey Companion. So this is a Unity window that keeps track of the project. So if you encounter any errors, it will help guide you in the right direction. Another nice window is Chat with AI. So this one, like the name implies, it helps you chat with an AI that was trained specifically on the content of this course. So it's a great way to get some help nearly instantly. Or alternatively, when you post in the course comment section, in there you will also get a near instant reply from this AI. So this is also really great for some quick help. But again, as always, on the comments, I'll be myself reading and writing and answering questions within the next 24 hours. Then the premium version also has some extra lectures building some really fun bonus mechanics. These aren't part of the original classic game. These are some fun things that I made up on my own just to build upon it. So first of all, there's a really nice cargo transport system. This requires the lander to stay hovering on a certain area to pick up some cargo, then move somewhere to drop it off. Based on this, I also implement another fun mechanic, the key door system. This one is built on top of the cargo system. We have keys and doors that are connected. This allows you to make some really interesting levels. Next up are the wind zones. So these apply some force to the lander automatically. It's another nice mechanic for more interesting levels. Then moving obstacles, so simple asteroids moving around that the player needs to dodge. And finally some turrets. These look at the player and shoot, so the player needs to dodge those bullets in order to survive. So yep, these bonus lectures, these are part of the premium version only, but the core of the game and all the lectures are completely free over here, right here on this YouTube video. So if you can't afford the premium version, that's awesome. You get a ton of awesome bonus and you help me be able to afford making more free courses in the future. You can pick it up right now with a link in the description. But if you can't afford it, then that's fine. You can still gain an insane amount of knowledge and learn how to build this game right here for free on this YouTube video. Like I said, you just need to apply yourself a little bit more. On the premium version, I have pre-prepared the companion project so you can really gain the knowledge. But over here on the free version, you basically need to look at the last slide and basically guide yourself. So it's a bit more effort, but you can still gain the same amount of knowledge. Here I really just ask you to go ahead and like this video. It's a tiny thing, but it really does help. Oh, and if you want to stay up to date with all the game dev news and interesting articles, then subscribe to my free weekly Game Dev Report newsletter. This is where I cover lots of interesting stories, everything from game development, marketing, tech, statistics, and so on. So check it out and sign up for free. And if you're watching this course within the first 2 weeks of release, if so, then I'm actually still running my CodeMonkey Summer bundle. This is a special bundle with a very deep discount and contains pretty much all of my courses. I'm running this for only this summer. Like I said, it includes all my courses, all my Steam games in one nice package, including this course as well. I'm all running this bundle for this summer, only for the next 2 weeks after the launch of this course. So if you're interested, check it out with the link in the description. Alright, so that's the intro out of the way. Now let's go on to the next lecture. We're going to see a step-by-step overview of everything we're going to build from start to finish. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to see a quick overview of all the lectures and everything we're going to learn in this course. So, we're going to start off completely from scratch by creating a brand new empty Unity project using Unity URP for 2D. We're going to start completely empty, and here we're also going to set up the Unity layout. Then, since this is a complete beginner course, we're going to learn the basics of Unity. So we're going to learn what are all these various windows, the hierarchy, scene view, game view, inspector, and so on. We're also going to learn what exactly is a game object transform. So we're going to start learning from the absolute basics, and next we're going to learn about post-processing. We're going to do this at the beginning of the course, just so that the game looks interesting in the videos. With just a few settings, we can make the game look quite a bit better. After that is a very important lecture, so this is where you should download the project files and continue from here. I recommend you do it this way, so you have the exact same project as me with all the exact same version numbers and everything is the same. If you follow what I say, you will avoid tons of confusion and the entire course will go nice and smooth. Then we start actually building our game. First creating the render. Importantly is how in this course I won't be teaching you the proper practices. So in this lecture I will teach you about a very important rule, how you should always separate logic from visuals. Next we're going to create our first C# script in order to read some player input. So here I will talk a little bit about C# basics, both by itself and the Unity specific things, like what exactly is a mono behavior. Then we're going to learn about physics. This game is very much physics based. So here we're going to learn about the various Unity 2D physics components. So what exactly is a rigid body and a collider? In just a few seconds we're going to have our lander fall along with gravity. After that we build a nice terrain for our game. And the way we do that is we're going to use a nice Unity 2D tool, the SpriteShape. This one lets us create some very interesting shapes, which makes it perfect for the terrain for our game. Next we'll learn about Cinemachine. This is another very useful Unity tool. It's a built-in tool to help you handle cameras. It really makes camera handling super easy. In just a few clicks we will have the camera following the player. After that we're going to learn about another very important thing in a 2D game, which is sorting order. This is how you define what sprites go in front of which. Since 2D games don't have depth, this is a very important topic. We're going to put the background behind the lander sprite. Next, we're going to implement a crucial mechanic for this specific game, the landing detection. This one involves some clever use of math and some basic Unity functions. We need to identify that the lander is landing both slowly and at a right angle. After that, we implement a proper landing pad, the proper object itself. So this is another super important lecture, because over here I will talk about an extremely important rule, how you should avoid strings whenever possible. How you should never use strings to identify objects, so don't use names, don't use tags. Here I will teach you a much better method, and we're going to use that method in order to identify the landing pad object. Then we're going to implement another nice game mechanic, the score multiplier. This will allow us to make our game pre-expandable with both easy and hard landings. After that is another super important lecture. This one is on adding the thruster visuals. This one is also extremely important because again, it is another example of the very important rule that we learned earlier in the course, how to separate logic from visuals. We're going to add these thruster visuals properly by making a script that is responsible for just the visuals, and that script is completely separate from the logic script. Again, in this course I'm very much focused on teaching you the best practices. Then we're going to add something that almost every game has, pickups. In this case we're going to pick up some fuel. Thankfully this is pretty easy to do. We're going to learn about trigger colliders and how to easily implement this. After that we have another very important lecture. In this one we'll learn a very important programming pattern, the Singleton pattern. This is a super useful, super powerful pattern that lets us easily access references for things like a game manager. This will help simplify our code by quite a bit. And here we're also going to quickly implement another pickup. Then it's finally time to add a UI. Here I will teach you how I set up my UI based on my 10 years of experience. We're going to set it up and create a UI window, of course while doing it properly. So we're going to continue following the same rule, separating the logic from the visuals. the UI code will be completely decoupled from the underlying logic classes. Then we build just another UI window, this time one that shows up as we land or crash. Once you know how to build one UI window, it is very easy to build multiple. After that, we implement some basic states for our game, which is going to involve learning how to make a state machine. We're going to make the game wait for input in order to start. Then we're also going to implement a game over and a restart. Next, we're going to add multiple levels to the game. We're going to do this in such a way that adding more and more levels to the game is very simple. We really just need to add more prefabs and that's really it. And we're also going to set it up in such a way that we can allow those levels to be quite complex if we want. Next, we implement a zoom mechanic right at the start, so the game zooms out before the player touches any input. That way the player can decide what path they want to take, easy or hard. After that, we do another extremely important thing. We refactor some code. Refactoring is an extremely important part of any game development. In this case, we're going to specifically refactor the input system. So instead of directly listening to key inputs, we're going to listen to actions. By adding this layer of abstraction, we're going to make our game easily playable with a gamepad. Next, we're going to implement touch input. So again, this one is going to be a very simple, very quick lecture because we are using the input system, because we've already added that layer of abstraction. Because of that, we really just need to add some simple on-screen controls and everything will work automatically. Then we create a simple main menu with a play and quit button, as well as refactoring the loading system and add a nice pause menu. Finally, we add some sounds and music to make our game really come alive. Then comes the section on bonus mechanics. So first we're going to implement a nice cargo transport mechanic. The player needs to hover the lander over a certain area to pick up some cargo. The cargo is being carried by a rope using physics, so it looks pretty cool, and the player needs to drop it off somewhere. After that, we're going to build upon that mechanic to make the key door system. So this one is going to be a great lecture. We're going to learn about an awesome Unity feature, scriptable objects. Using that, we can define different types of cargoes, like all the keys, and using different keys of different colors, we can connect them to doors and make them open when the player drops the right key on the right lock. In this lecture, we're also going to learn quite a bit about the Unity animator. Next, we implement another bonus mechanic, the wind zones. These are simple zones that push the player in one direction. Using this, we can make some fun, challenging mazes. Then we implement some moving obstacles. These are simple asteroids just moving around. Naturally, the player needs to dodge them. And finally, we're going to add the bonus mechanic, the turrets. These are tower defense turrets. They aim at the player and shoot some bullets, and the player needs to dodge those bullets in order to survive. Finally, we have a very important lecture, polish. Polish is what separates good games from great games, so this is a part of the process you should never ignore. Here we're going to add all kinds of tiny things and effects to make the game really stand out. So yep, throughout this course we will start completely from scratch and step by step build this really nice game. The game design is simple, which makes it perfect as a Unity 2D beginner project. But of course, like I said many times here, I will be teaching you good code practices and good project organization. So even though this is a simple project, we will be building it to professional standards. That's what I'm teaching you. So yep, let's go ahead, get started, and create a completely empty new project in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to get started making our project and set up Unity. Alright, so here let's begin creating our project. And now for this, you actually have two options. So one is you can follow along with what I'm doing in this video, or two, which is actually the better option, is you can just watch this lecture and the following ones. And then after everything is set up correctly, you can download the exact same project files that I'm using and add those to your project. I highly recommend you take that approach. That way you end up with everything exactly the same versions as me. Technically, everything that we're going to be building in this game is relatively simple and not really tied to any specific Unity version or any package version. But still, if you use a different version, you might get menus in a slightly different place. So I really highly recommend you use the exact same version as me, especially if you are a beginner, just to avoid any confusion. And if you do what I say, if you just download the project files and use that project as the starting point, then you are guaranteed to have the exact same project as me. That way everything you see in this entire course will perfectly match what you see on your screen. So again, I recommend you just watch these setup lectures, so don't follow what I'm doing step by step, just watch it, and then after these first few setup lectures, then download the project files and continue from there. Okay, so I'm going to create a brand new project. Over here on Unity Hub, let's go ahead and create a brand new project. And over here for the editor version, I'm going to be using the latest stable version. So right now, at the time of this recording, that's Unity 6.1. This is the current supported version. If you don't know how Unity versions are set up, you can watch my video on that topic. Nowadays, it's actually pretty easy to pick a stable version. So we have that version, and then next important decision is we need to pick a render pipeline. So this basically is going to define how our game is rendered and what platforms we can play our game on. For the most part, we have two render pipelines. There's the universal render pipeline. It's also sometimes called just URP. And then you've got the high definition render pipeline, or HDRP. For these two, URP, like the name implies, this one is meant to run on anything. It is meant to be universal. So you can make a game using URP, and you can run that game on PC or PlayStation. You can run it on a Switch, even a browser, a mobile phone, literally anywhere. Whereas HDRP, this one is more meant for the bleeding edge of visuals. So this one is meant for high-end PCs and consoles. And finally, technically, there's actually a third render pipeline. You've got the built-in render pipeline, so that is the old legacy pipeline. You can see it down here. You've got these templates for 3D and 2D, both those using the built-in render pipeline. But like I said, this is the old legacy pipeline. So for the most part, nowadays when making games, you should choose one of these two, either the universal render pipeline or high definition render pipeline. And when it comes to our case for making this specific game, for this our choice is actually very simple. The goal is to make a 2D game, and for 2D specific games, we've got over here universal 2D. So this is using the universal render pipeline with a specific 2D render. This is going to allow us to use 2D lights and all sorts of 2D features, so this is going to be perfect for this game. Let's go ahead and choose Universal 2D, and then select your Unity organization, then a project name. I'm going to call this Lua Lander. Then we've got the option to create that new project on Unity Cloud. Now, for this game, we're actually not going to need any cloud features, but still, if you want, you can leave this one just in case you want to expand upon the game in the future, like adding some sort of multiplayer. Or if you really don't want any Unity Cloud features, you can just go ahead and make this one a local project. That way it will not have any connection at all. But again, for our game, it doesn't really matter either way, so you can choose whatever you want, then choose a location, and yep, now let's go ahead and create the project. Alright, so here we have our completely empty project. Now let's go ahead and set it up. First, let's begin by setting up the Unity layout. It is very important that Unity is set up in a way that we like, in a way that we can actually efficiently build our game. So for me personally, I've been using Unity for over a decade, so let's go ahead and see the layout that I've developed over the many years. Technically, you can set up the editor in any way you want, but it will be easier to follow this course if you're using the same layout as me. And if you are a complete beginner, if you've never seen Unity at all, then don't worry. I'm going to explain what all of these various windows do in the next lecture. Over here, let's just set it up visually. But basically on each one of these little tabs, you can pick it up, you can grab it, and you can move it all over the place, so you can get the exact layout that you want. So first of all is for the inspector window. This one is very important. Over here, I like to place this one on the right side. That way we always have a nice view of the selected object and whatever scripts it has. Then next for the hierarchy, that is right here on the top left corner, I like to actually place this one on the lower left corner. We're going to make sure that our scene is always organized, so we don't need it to take up too much space. So just a short little square over there on the corner, just that is going to be enough. Then next to the hierarchy over here, let's keep the project files window. Yep, again, this little corner over here is more than enough to browse all of our files. And let's keep the console basically on the same tab. Usually I find that when making the game, I want to look on the project window, and then when playing the game, I just want to look at the console. So this setup over here, keeping them in the same place but different tabs, this works great. And then over here on the center, let's keep the scene view. This is how we can easily build our game, place all kinds of things. And then for seeing what the camera sees, it's on the game view. And personally, I like to keep it right next to the scene view, so just like this, yep, over here on this side. So we've got the scene view over here and game view down here. Okay, so this is the basic layout that I normally use. Again, if you are a complete beginner, then don't worry. I'm going to explain what all of these windows do in a little bit. Now let's just see a couple more options. So first one is over here on the project window. Over here on the top right corner of this window, there's these little 3 dots. Let's go ahead and click on it. And first of all, instead of the 2-column layout, personally I prefer the 1-column layout. This one showcases the project files in a nice compact list view. Personally, I prefer this one. Now, if you need to browse lots of visuals in your project, if you want, then you can swap back to the 2-column. This one makes it a little bit easier to see visuals. But for the most part, for the most time, I prefer the 1-column layout. This one is more compact. I think it's great. Also, one quick tip, just in case you don't know. Over here, you can see all the default assets. Yep, these are all the things. And then you've got another folder over here for all the packages, and you can see all the packages that are installed by default. We created this project using the 2D template, so that is why over here we've got all kinds of 2D packages. Now, the important tip is if you don't see this, that's fine. Just over here on the top right corner, you see this little eye icon. This one basically shows or hides the packages. So if I click on it, yep, there we go, those disappear. So just in case you want to browse all the packages, if you want to do that, you can take this and you can go inside each package, read it, and so on. But if you don't want to touch those packages, which for the most part you probably don't need to, if so, then you can just go ahead, press this button. That makes this a little bit more clean. Okay, so this is great. Next on the console tab, over here, let's also go onto the 3 dots for some more options. Then over here under log entry, personally I like to keep it on 1 line. This makes the console really nice and compact, which personally I prefer. That way you can see more logs without taking up more space. And if you want to read the entire log, you can just click on the line whenever it appears, and it will show the entire log on this little box down here. Then here you've got some more options if you want. For example, you can show or hide the timestamp. Sometimes this can be useful, especially if you've got tons of logs and you're not sure if those are constantly being fired. If you see the timestamp, then at least you know that the seconds are moving. Another one is over here, the monospace font. So if you like your logs for each character to have the exact same shape, if so, then go ahead and use a monospace font. But for the most part, I'm okay with this setup. Then over here, these 3 buttons are extremely important. If you are a beginner, definitely pay attention to this. Basically, the left one over here, this one refers to messages. We're going to use this one quite a lot. Then this one is going to be warnings, and finally we have errors. Now the important thing is that if you toggle or untoggle any of these, then those messages will not show up. For example, here I've printed out 3 messages. So this one is a message, this one is a warning, this one is an error. We can see the icons there. And again, like I was saying, these buttons are very important because if you click on this, basically it's going to hide it over here on this list, but the message is still being fired. Or specifically, if you hide this one, then it shows no errors over here, but you do have 1 error. So over here for these buttons, these just toggle the visibility of the messages. And for the most part, you want to see all messages, you want to see all warnings and all errors. So for the most part, always make sure these are toggled. If you have any kind of weird issues where something is going wrong and you don't see what is going on and the console seems empty, if so, first thing you should double check is this one, make sure the messages are actually showing. Then still on the console window, over here we have some more options. So on the clear, basically this one is going to clear up the console, and this little arrow over here, this one basically clears on build, play, and so on. For the most part, I like to set it like this, clear on play. That way basically the console is going to clear anytime we hit the play button. Then for the collapse, this is another very important one. This one basically collapses multiple messages into just 1 entry. Now personally, I don't like this. I want to see every single message as it comes out, even if the message is repeated. I've also seen this lead to a lot of confusion for some people. Basically they think their code is just firing 1 message, when in reality it's firing hundreds. So to avoid any confusion, I highly recommend you leave collapse untoggled. That way you can see every single individual message. Then for the error pause, this one will basically automatically pause the game whenever an error like this one occurs. So for the most part, you should definitely have this toggled. If there is an error, you want to know about it. You want to know when it happens so you can fix it. Whereas if you untoggle it, then you might get errors and the game might keep playing, which will then lead to lots of confusion when things start to behaving very strangely. Ideally, your game should not have any errors. So if they happen, then you want to know about them. So always leave this toggled, that way when an error happens, the game pauses and you can very easily see it. Okay, so that's it over here for the console. Then let's go here down the center for the game view. Here on the top left corner, we also have a bunch of options. For example, over here, this one that says free aspect, so this one is going to be the aspect ratio. Let's go ahead and select full HD, so 1920 by 1080. So this is a 16:9 aspect ratio, pretty standard. Now this really only matters when we start working with the UI, but for the most part I like to keep it on this just by default. Technically if you want you can use any of these other aspect ratios, but again like I said that is only going to impact when we work on the UI, so for the most part since I make PC Steam games, for the most part I set it on full HD, yep, just like this. Then other important options over here, VSync. Usually I like to keep this enabled. VSync basically synchronizes whatever the game is rendering over here on the game view, synchronize that one with the refresh rate of your monitor. Now this can be useful because if, for example, if we hit on play on this completely empty scene, then over here on top right corner we can click on the stats button to see some stats. And if I go ahead and disable VSync, yep, look at that, this empty scene is now running on 600 FPS. So basically my graphics card is wasting a ton of power, just wasting a bunch of rendering for no reason. There's really no point in rendering an empty scene like this on 600 FPS. It's really just going to spin up the fans on my GPU for no reason. So that is why I like to keep VSync enabled. So yep, that brings it down to 144 FPS, so that's the refresh rate of my monitor. That way everything is still playable, still great, and my GPU is not going crazy. Another very important thing is over here the scale slider. If you ever notice that your game view is looking very pixelated, go up here on the scale slider and make sure it's pushed all the way to the left. If you have some kind of visual in your game and this slider is pushed all the way up, look at that, how it's actually all very blurry. The reason is because when you modify this slider, this is literally just enlarging this image. It is not applying any anti-aliasing, anything like that. Nope, it is literally just increasing the size of the image. This option is really just so you can zoom in on various parts of your image, but the image is still the exact same size. This is not changing the resolution. So this slider over here should pretty much always be pushed all the way to the left side. If you ever see your game view looking very pixelated, always make sure this one all the way to the left side. Alright, so here's the layout that I'm going to be using throughout the course. It will be easier for you to follow the course if you're using the exact same layout as me, so ideally you should be using this. But again, like I said, all the windows are customizable, so if there's something you absolutely prefer on a different place, then go ahead. You can drag and drop and place windows wherever you want them. Then once you have a layout that you're happy with, you can go over here on the top right corner, and over here on this one you can save the layout. Just give it some kind of name and save. And if you ever have issues with the layout, you can go ahead and reload your layout. Or sometimes if some windows just refuse to open, you can go back to the default layout, then go back to your own layout, and yep, everything should work fine. Okay, so our layout is set up. That means our Unity project is ready. Finally, for the code, I'm going to be writing code inside Visual Studio Community 22. Now, technically, you can use any IDE you want. So for example, you can use VS Code if you like it, you can use Writer or really anything you want. If you want to see my complete Visual Studio setup, you can watch that lecture on my free C# course. I basically just have 2 simple extensions and everything else is standard. You can watch that lecture on the Visual Studio setup, and then watch the other one on the Visual Studio shortcuts. That one is a great lecture if you want to be a little bit more efficient. However, if you're a beginner, then I would say don't worry about that, just set it up exactly the same. But at the same time, feel free to use whatever IDE you want. You're not required to use the same one as me. Code is code, so it will all compile the same regardless of what IDE you use. Okay, so we have our project created and Unity is set up. Like I said, don't worry about following along just yet. Keep watching just these lectures. In the next lecture, we're going to learn about Unity basics. Then after that, we're going to import the visual assets. And only after that, all the setup will be done. So only after that should you download and create your project. Don't worry about doing that for now. Alright, so let's keep going on to the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn all about Unity basics. So we're going to learn what is a game object, what is a component, what exactly is the hierarchy, the inspector, and so on. Again, this is another lecture that you should just watch. In a few lectures, I will tell you when you should download the project files and follow along. Okay, so this course is meant for complete beginners, so here let's learn the absolute basics of Unity. First, let's look at the layout and all the windows that we set up in the last lecture. Let's begin over here on the lower left corner with the hierarchy window. So this one just shows us the currently open scene. So right now we're on the sample scene. That's the default name. And then over here we can see a list of all the game objects that currently exist in this same scene. Basically, think of a scene as a way of grouping various game objects together, kind of like a folder. Later on, we're going to have our main game scene, then we will have a main menu scene, a game over scene, and so on. And then, like I said, inside scenes, we have game objects. And game objects, that's just what Unity calls objects that exist in our scenes. And here, by default, we start off with 2 of them. So we've got the main camera and the global light 2D. This is the name of the game object. If we want to create a brand new game object, we can either right-click over here, or click on the plus icon on the hierarchy. And for example, let's create an empty game object. And if there you go, this is a completely empty game object. Now, the way that Unity works is based on a component model, meaning that what makes, for example, this object a main camera and what makes this one a global light, it is not based on the name over here. Again, this name is really just a string. So this one is called game object, this one's called global light, and so on. This is really just a string, it is just a name. The name itself does not define any behavior. Basically, the behavior is defined by what components are attached to that game object. If we click on any of these objects, then over here on the right side on the inspector, we can see all the components attached to this game object. And yep, on this one specifically, we can see this one has the camera component attached. Again, the components is what actually defines the behavior for this game object. By default, every single game object always has a transform component. This one is a mandatory component. You cannot have a game object without a transform. For example, down here, when we just create the brand new empty game object, note how it does have the transform. And we cannot remove this component. The transform has to exist, it is built in. The transform component defines the position, the rotation, and the scale of this object. We can modify the X, Y, and Z for any of these. And if we look in scene view, so over here, if we inspect our scene view, let's select the game object. Then let's just select the move tool. So on scene view on the upper left corner over here, let's select this tool. So that's a move tool. Basically just so we can see the handle, so we can see the object is placed over there. And if on the inspector, if we modify the position, so over here, let's put it on something different, like an X of 5. And if there you go, look how the object moves position. So you have the transform component. This is what defines the position, rotation, and scale of this object in the world. But the important thing is that what defines the behavior for the game object is based on the components attached, not on the name itself. Over here, if you want, you can rename any of these objects. So you can right click, go into rename, and name this something. And yep, again, like I said, that is really just a string name. It does not impact behavior. That one is dependent based on the components. I'm repeating this because that is a very core part of how Unity works. It is all based upon game objects and components. Any game you want to make is really just clever usage of those 2 things. You create game objects, attach different components, and you get different behavior. For example, let's inspect our main camera game object. And yep, this one does have over here the camera component. So this component is what actually renders the camera view onto the screen. And within each component, you can see all kinds of parameters. So the transform component had position, rotation, and scale, whereas the camera, this one has the projection data. Then it's got a bunch of rendering options, the camera stack, environment, and so on. So all of these are the various parameters that we can apply to our camera component. Then same thing for the other object that was created automatically, the global light 2D. Again, the only thing that makes this a global light is just a component that is attached. So this one has a light 2D set to global. So yep, that's why this one is a global light. And global light just means this one is going to apply a certain light to all of our 2D objects, which right now we still don't have any. If we do want to create objects, then like we saw, we can click on this little plus icon or right click on empty space in the hierarchy. Then we can create all kinds of different objects. We can create something completely empty, so just a completely empty game object. Or we can actually create some nice fun presets. For example, over here under 2D object, we've got sprites. And by the way, if you're following along and you don't see these options, that's because you likely did not create the project using the universal 2D template. In order for these options to exist, these specific ones for 2D objects, these 2D sprites, you need to have the 2D package installed. But if you select the exact same template that I did, the universal 2D, those should be installed by default, so you should be able to see these. And again, if you're doing as I say, if you're just going to download the project files after I finish the setup, then when you get it, everything will be installed on the packages, everything correct. Okay, so so here we can create some kind of object. For example, let's create a simple circle. And if there it is, we can see it right away. And again, what makes this a circle? It is not based on the name of the game object itself, but rather it's based on the components. This one has a sprite render component, which basically renders a sprite onto the screen. And if you don't see this over here rendering on the game view, if not, then go over here on the transform component and make sure the position on the Z, that one is set to 0. Basically, if you set this to some value like -10, if so, then the object is still there, but it's not visible. That is because it's currently being rendered behind the main camera. So if you don't see it, just go ahead, set it up on 0, and make sure that it's within the camera bounds. You can see this little outline over here. That's the camera bounds. So make sure it exists inside of this. And now that we have a 2D sprite, we can go back to our global light 2D. And over here, like we saw, on each component, you have all kinds of settings and properties. So for example, over here, we've got the color property. We can click on this to modify the color of this light. And there you go. Obviously, it modifies the color on our object itself. Okay, so those are some core components, but then of course, a big part of Unity is making your own custom components. So for that, let's go into our project window. This one contains all the project files for our project. In fact, if we actually right-click anywhere over here and we click on this, Show in Explorer, yep, this one opens up the Windows Explorer onto this folder. So this is the main project folder, and inside we have this assets folder. And inside this one, yep, we can see all kinds of assets, which perfectly matches the one that we have here. For each file, you always have the file itself. So for example, the default volume profile. So that is the one that we have over there. So we've got the asset, and then we've got a separate meta file. That one just contains some metadata about that asset. But yep, inside this folder, inside this assets folder, that's where basically your project lives. So if you want to add more assets to your game, like for example, adding new sprites, you really just drag and drop them onto this folder. For example, here I've got a simple sprite image. If I want to use this in my project, I really just have to drag and drop or paste it over here into our project files. And over here inside Unity, yep, we do see that one added. So yep, this is how you can add more assets to your project. Just drag and drop them onto that folder, and that's it. Now here I'm going to keep this clean. Let's delete this because we're going to import the actual visual assets in a little bit. Now another thing we can do here on the project window is of course we can create new assets or new scripts. So we can either right click or click on the plus icon. That one works. And let's go ahead and create a brand new monobehavior script. So monobehavior, this is really just a name for the main class that Unity uses in order to define a script as a component. Let's just create one, and now for the name, let's call it testing. And as soon as you do, now it's basically going to compile our code. So you should be able to see the compilation currently happening. And if there you go, now it's done. Then we can go ahead, double click to open this, and it's going to start Visual Studio. And yep, here we have our default script. Now I'm going to talk a little bit more on the basics of this code in a little bit. Like I mentioned in the beginning, if you want to focus on learning C# specifically, then I highly recommend you follow my C# course. That course has a free version with visual lectures on YouTube, and it also has a premium version with a bunch of really awesome bonuses like frequently asked questions, quizzes, and interactive exercises to help you learn by doing. So you've got those two options if you want to learn the C# language itself. Over here, the main thing that I want to call your attention to is this one over here, the monobehavior. This is the base class. That means this script can be used as a component. It can be attached to a game object. If we have this, then over here back into Unity, we can just select any game object, like let's say the circle, and I can just click and drag this testing, place it over there, and if there you go, I've attached this script onto this object as a component. Alright, awesome. Then of course, now by writing all kinds of code onto scripts like this, is how we're going to eventually build all the logic for our game. That's what we're going to do later on in this course. Okay, so this is really the general idea for how Unity works. Basically, you've got scenes, then within those scenes, you've got all kinds of game objects, then on each game object, you have components attached to it, and depending on which components you use, you get different behavior. So the camera component, this one renders an image onto the screen. The sprite render component, this one defines a sprite to be rendered. The light 2D component, this one defines a 2D light. And then each component also has all kinds of data that defines their behavior. It's by combining components, even including some custom components, that we are going to build all the logic for our game. Oh, and by the way, game objects can also have hierarchies. So you can take a game object and make it a child of another one. So over here I'm going to select the circle, press Ctrl D to duplicate it. Let's, on the scene view, just move it over there to the right. And now I'm going to drag this one on top of that one. And if there you go, now this one is a child of that object. Here we've got the little fold out arrow, so we can show and hide all the children of this game object. Another important thing is over here the transform position. So for example, let's put this one on 0, 0, 0, just like this. Then on the child object, let's put this on 2, 0, 0. And if it's like this, so this one is on 0, 0, 0, this one on 2, 0, 0. But now if I go onto the parent, let's put it on 1, 0, 0. And if there you go, that one is on 1, 0, 0. But if I select the other circle, you have a look at that, the transform still says 2, 0, 0, even though in reality, globally, it is actually on 3, 0, 0. So basically the transform data that you see over here, this one is the local transform data. This is the local position of this object. It is not the global position. For this second circle, this one is on local position 2, 0, 0, but global position is actually 3, 0, 0, just because the parent is always offset. So keep that in mind. Keep in mind the data that you see over here on the transform component. This one is the local transform data. Always keep that in mind, especially as you make objects that are children of other objects. Okay, so the next unit would be over here, the scene view. So here, the most important thing is learning how to navigate in this world. Now, thankfully, this is a 2D game, so this makes it super easy. We can just use the scroll wheel up or down to zoom in or out. And we can hold down the right mouse button, and we can basically pan around the camera. So yep, in 2D, that is super simple. By the way, over here on scene view, we can see a little button over there that says 2D. If we click, we can toggle it between 2D or 3D mode. If we are in 3D, then we have more control over what we can do over here on scene view. So right click and holding instead rotates the scene view camera. If I use WASD, I can move around the camera inside the scene view. And again, all that I'm doing is just modifying the scene view. The game view does not change. That one is still rendering just what the main camera sees, nothing else. So if in 3D mode, we have a bunch more options for movement, but this is a 2D game. So like I said, no need to worry about that. Let's click that button to set this in 2D. And now we can right click and pan around, and yep, we can place the camera anywhere. Okay, great. Now another super useful thing is focusing on an object. So for example, let's say that I move the camera way too far and I've completely lost it. I have no idea where my objects are. I'm completely lost. Now I can just select an object in the hierarchy, like let's say the circle. And now I can press on F. And if there I go, that one basically focuses the object over here on scene view, so we can always find it. So if you ever get lost, remember that. Select something over here on the hierarchy, press F, and there you go, it will focus on that object. Also, like I said, very important is what defines what we see here on game view is basically what the main camera sees. It is not related to wherever you position the scene view camera. This one does not matter. What matters for the final game is what is rendered on the game view. Okay, so those are really all just our main windows. So we've got scene view, game view, the inspector, project, the console, and the hierarchy. Those are pretty much all the main windows. Let's just look here what happens on the console itself. So first of all, like I said, very, very important is over here, make sure these three buttons are toggled. Otherwise, you might have messages but not see them. So we have these. And now, for example, let's see how do we make an actual message over here on the console that is going to be extremely useful as we build our game. So we need to know about that. So first, let's open up the C# script that we created previously. So we can go on the project window and just double click on our file. And up here it is, open in Visual Studio. And now the simplest way to write to the console is to write, let's say, for example, over here on start, let's write debug.log and some kind of message. Let's say testing. Now again, if you don't know anything about programming, I highly recommend you watch my C# course. For example, over here, it's very important that you write the code within the start code block and not outside of it. If you write testing outside of it, like over here, yep, you get an error because this is not valid code. You need to write it inside a function. In this case specifically, let's write it inside the start function. And just like this, like I said, it will be printing out the message testing onto our console. So first, let's go ahead and save our file. And yep, it's saved. So over here, our code is now compiling. Okay, great. But if you look in our console, nope, nothing happens. We have no message. That is because in order for the code to run, we need two things. First of all, we need the script to be attached to a game object that is valid. So over here, actually on the circle game object, let's delete the second circle and keep just one. And on this one over here, yep, I did attach the testing component, so that's good. If you didn't have it, then just go ahead, drag and drop, and you can add it. Okay, so let's attach that one. And secondly, we need to actually play our game. So up top here we have the nice play button. Let's go ahead, press it. And yep, now the game is running, meaning our code is actually running. And yep, down here on the console, we do see our nice message. All right, awesome. By the way, over here in game view, we also have a bunch of options. For example, one important one is over here, this one that says play focused. You can change to play maximized. If you do, then when you hit on play, basically it's going to maximize this window. So if you want to do some more thorough testing, some more play testing for quite a while, perhaps this is useful. But a lot of times while developing the game, you actually want to be able to see the console. So over here on the game tab, let's right click, click on maximize to basically put it back to normal. And yep, now we can see the console. And if we want, we can go back and down, right click, maximize. Yep, there it is. Another thing, if you want to see the console whilst in this mode, first of all, you can see it down here. You can see just the last message. but that only shows the last message, so sometimes that's not very useful. But you can click over here, and yep, there you go, that one basically spawns a second floating console. Okay, great! So that's really all the Unity basics. As you can see, it's all relatively simple to work around in this interface. The hierarchy shows you the open scenes and the game objects on those scenes. The inspector shows the various components on the currently selected game object. Then the scene view shows the world in our open scene. The game view shows what the camera is seeing. The project window shows all of our project files. And finally, the console window. This one shows all the logs, warnings, and errors that get fired by all kinds of scripts in our game. Okay, let's just clean up this scene before we go further. So let's get rid of this something empty game object, get rid of the circle. Then on the project files, let's also get rid of the testing script, just delete it, just like that. Okay, so here we learned the basics of Unity. Now we have enough knowledge to start building something. But before we start building our game, let's import some nice visual assets that we're going to need. So let's import those in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to import the assets we're going to use in making this game and set up some basic post-processing. Again, this is another lecture you should just watch. In the next lecture, you can download the complete project files and then continue from there. Okay, so let's import the visual assets we're going to use in this course. There's a download link in this lecture. It's a .unity package file. So you can just download it, then click and drag and drop it over here inside the project window. And up here we have a bunch of nice visuals and sounds, so everything we're going to need to make this game. Let's go ahead and make sure that all of them are selected, and let's import. Okay, yep, great, so we should be able to see everything here. So a textures folder, sounds folder, some prefabs, font, and so on. So yep, everything is here. These assets should already be all set up correctly. So if you select any of them over here on the inspector, you can see the texture import settings. I'm going to cover these in a little bit, but for now, these should already be set up correctly. Now let's just set up some visual stuff so we can first set up post-processing. So inside the textures folder, over here we've got the Lender Sprite. So let's go ahead and use it. So let's just drag and drop over here into our hierarchy. And if there you go, that creates a brand new game object, already has a sprite render, and over here has the sprite assigned. So up here it is the visual, and position, let's put it on 0, 0, 0, just so it's on the center. By the way, alternatively, you can also drop it over here on scene view. So if I click and I go over here and I drop it, yep, this works. However, it does not work over here on game view. You cannot drop it here. So you can either drop it on the hierarchy like I did, or drop it over here on scene view. Either one of those methods work. Also make sure that over here the scene view is set up in 2D mode. So if you see the button over there, 2D, yep, this game is 2D, so let's make sure it's always on 2D. And if you don't see the sprite in front of the camera, then it's the same thing that I mentioned in a previous lecture. Over here on the Z, make sure it's on 0, because if it is on a minus position, it might actually be behind the camera not being rendered. So let's make sure it is on 0, 0, 0. Alright, great, so here it is right down the center. Now let's also drag the background sprite. So let's go ahead, drag that one over there. Then let's also drag a coin sprite and drag a fuel sprite. By the way, with this, you might see some sprites that are being hidden. Later on, I'm going to talk about sorting sprites and how exactly do you do that. Right now here, since all we're doing is really just testing out the visuals, over here just select the background sprite, and in the inspector, over here under ordinate layer, let's put it on -10. Yep, that way it shows up behind all the other sprites. Again, like I said, in a later lecture I'm going to talk about in detail about sorting sprites, about these various options. But right now, just put it like that, should be great. Then over here, if we use this tool, the rect tool, with this one we see the 4 corners, and let's just stretch out this one. Again, right now we're just doing this to set up the post-processing. In a little bit we're going to destroy all of these items. So yep, just like this, we've got a basic scene, and now we can play around with some post-processing. Now, technically I should say this isn't a requirement. You don't need post-processing to make this game, or almost any game, but post-processing is always a great thing to add. It makes your game look much better and can modify the look by quite a bit. Normally, personally, in my own games, I only tend to implement post-processing later on in the project, but in order to make this video course a bit more appealing, I'm doing it right here, right at the start. So for post-processing, let's just go here into the hierarchy, let's right-click, let's create, go over here under volume, and let's construct a brand new global volume. Yep, there it is. This one contains a volume component, and let's just reset the transform, put it on 0, 0, 0 to keep things nice and clean. Okay, so here this one has the volume component. This is what handles post-processing. This is how we can apply all kinds of effects. And importantly, right now we want this one to be a global volume. Global meaning that it's going to apply to literally everything in our game. So over here on mode, make sure it's set to global. If you set it to local, then you can basically define some areas where this post-processing applies and some areas where it doesn't. But again, for this one we want to apply to literally everything, so let's keep it on global. For the weight, in order to make sure that it works, make sure weight is set to 1. Then priority doesn't really matter because we just have 1, so yep, just like this. And now finally here we've got the volume profile. Right now we don't have any, so let's click on this button to create a brand new volume profile. And yep, this one created. The volume profile is an actual asset over here that exists in our project files. If you click over here, you should be able to see it highlighted over here on the project files. So yep, there it is, the global volume profile, alright. And over here on this profile, this is where we can add whatever post-processing effects we want. So let's click on Add Override, and over here under Post-Processing, yep, here you can see all kinds of effects. Like I said, this is really just a visual thing, so technically you can make it look whatever you want. It won't impact any of the logic that we're going to build in this game. Over here, for the ones that I like to add, the main one is going to be Bloom. This one basically adds some glow to your sprites. In this case, since this is a space game, I want everything to have a slight glow. So let's go ahead and enable the threshold. So basically, after a brightness above this level, that's when bloom gets applied. If you want to only glow some very specific things, usually you would set this to 1, and then on the color for the thing you want to glow, you would make that with an intensity above 1. But like I said, this is a space game, so I want everything to have a slight glow. So over here for threshold, let's put it on something like 0.7. That way everything is going to have a slight glow. Then for the intensity, let's enable it, and let's put it on something like 4. However, we don't see anything change. Or actually, over here on game view, we don't see anything change. But over here on the scene view, we do see some changes. We can see that one is indeed glowing quite a bit. And if you don't see that, then over here on scene view, there's a button. So over here, this one that has a little star. If you enable or disable that one basically enables or disables the special effects. So either click on this button, or over here, just enable the post-processing. And yep, if it is enabled, then you can see it over here on scene view. But game view, this one still doesn't show anything. That is because we need to enable post-processing on the camera itself in order to see the post-processing. So let's select our main camera, and then over here under the camera component, down here under rendering, we do see this one, post-processing. So let's go ahead and enable this, and if there you go, now we do see it working on the main camera. Okay, so that's great. However, if you still don't see it, there is one more setting. We need to go to the 2D renderer. So for that, let's open up here the settings folder, and inside we've got the renderer 2D. So this was automatically created when we created this project using the universal 2D template. And on this one over here, we can see inside of this, we've got the post-processing, and this one should be enabled by default. If it is disabled, then enable it, and now it should work. So enable this one, then on the main camera, make sure post-processing is enabled. On the global volume, make sure this game object is enabled, make sure it's set to global, and the settings like this. And yep, now we do see the post-processing, we do see our bloom working. Okay, so far so good. Now let's add some more effects. So another one that I like to add is the vignette, this one. This one basically makes the corners of the screen a little bit dark, so if we enable the intensity and we make it really intense, yep, there you go, basically darkens all the corners of the screen. I like this one, but I like it to be a little bit subtle, so something like 0.45, something like this. So it basically just darkens the corners just a little bit. You can enable or disable it to see the difference, so it's very subtle, but I think it looks quite nice. Again, you can play around the intensity, you can add more effects if you want, there's all kinds of things here. You can add some color curves, some color adjustment if you want, for example, play around the contrast, so you can really change this by quite a lot. Since these are really just visuals, because that you can add whatever visual you want if you want to make your game a little bit more custom. These visuals don't really impact the logic of the game itself. And after you set up a bunch of effects, you can go on the main camera, and over here you can disable or enable the post-processing, and you can see how it makes quite a bit of a difference. So that post-processing looks a bit dull, and with it looks quite a bit more interesting. Okay, yep, so this is the basic look that we want. With this, everything is nice and set up. Let's just go ahead and clean up the scene. So let's get rid of all of these testing sprites. So the lander, the background, the coin, the fuel. Just delete all of those, so just leave the global volume. Let's save the scene, and yep, just like this. Okay, so we have a nice empty canvas upon which we can finally start to make our game. Hello and welcome, I'm your CodeMonkey. In this lecture, the goal is very simple. Just download the project files and start the project from there. This way you have the exact same setup as me, with the exact same version numbers, the exact same settings, and everything is exactly the same. This helps avoid a lot of confusion that I see in many comments on my courses. People installing different versions of various packages, using different Unity versions, using the built-in render pipeline instead of URP, or just different lighting settings. So to avoid all of that, really just use the exact same project as me. So let's download the exact same project files that I have here. On the page for this lecture, scroll down and download the file. That is going to be a zip file. So go ahead, download it, then unpack it into some folder. So yep, here I've got this folder, and within this folder, yep, here is the entire project. So it's got the assets, packages, and so on, so everything exactly the same. Now, after you unpack it into some folder, then open up Unity Hub and click on Add, and let's add a project from the disk. And then over here, find the folder that you just unzipped to. Just do that, click on Open, and if there it is, here I do see the new project being added. And over here on the right side under Editor Version, if you don't have this specific Unity version, then you will be able to see a button to download it. Again, I recommend you use the exact same version as me just to avoid any confusion. After you go through this entire course and learn all of this, afterwards for your own projects you can then use whatever Unity version you want, and basically all the knowledge will still apply to that version as well. So download the Unity version, that's it, you should have this project, and then just click to open it. And now the first time that you open it will take a while as it basically downloads all the packages onto your local machine. But afterwards, you should have this exact same scene. So here I've got the sample scene, and it's got the post-processing set up. Then inside the project files, I've got the sounds, textures, and so on. So yeah, by following these instructions, you should have the exact same project that I have. Okay, great. So our project is completely set up. It's time to finally start building our game. But before that, let's learn about the very important companion project. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to install the companion project and go through it. Okay, so this course comes with a really nice companion project. Check out the download area on this lecture to download the package. This is one of the bonuses of the premium version of the course. It is not available on the free YouTube version. But if you're watching the free YouTube video, then I'll tell you something else you can do instead in a little bit. So download the package, here it is, and go ahead and import it onto your project. So just go ahead and drag and drop it. You can either drag and drop it and install it directly onto the project where you are working on, where you are actively building this game, or it can be into a completely separate project. Either one works. Personally, over here, I've got a completely empty Unity project, and I'm going to import it into this one. So here's the package, make sure everything is selected, and let's import. And yep, everything's done, so here we can see all the files. And the way this companion project works is basically it includes a bunch of nice sample windows to help you truly learn the contents of each lecture. To start, go up top onto the file menu, and over here you've got the CodeMonkey menu, and inside we can open up all the various windows. Let's open up the companion main window, and yep, out pops out this window. You can take this window and dock it anywhere, so I like to dock it over there. Here we can see the main window, just a nice message. And importantly, it's over here the counter for all the FAQs and all the quizzes. Ideally, by the time you finish this course, all of these should be 100% done. So then let's go ahead and inspect the lecture list. And up here we can see all the lectures involved in the making of this game in this course. Then on each lecture, this button, you can click on it. And over here, first of all, you can see a nice summary of the lecture. And then you've got these two very important buttons, FAQ and quiz. And if you click on it, yep, out pops out a new window. So this one is the frequently asked questions window. So this one, for example, let's dock it over here on the right side. And over here, you can see all the questions related to this specific lecture. So for example, let's see one of these. So why are we using Unity 6.1 instead of an older version like the 2020 LTS? And the answer to that frequently asked question, the answer is 6.1 is the latest stable support version with better support for URP and the latest features. It ensures everything works smoothly and is future-proof for modern development. So yep, that's the question, that's the answer. Then you can click on next in order to go into the next one, or go into back and basically go through all of these. So yep, these are the frequently asked questions, so very simple, you just got a simple question and an answer. And then back on the main window, over here we've got the quiz button, and when we click on it, yep, here we do see the quiz window. So let's drag and drop it and place it over here on the right side. And this one basically contains multiple choice questions. Again, all related to this specific lecture that we have selected. For example, which render pipeline is used for this 2D game? And over here the question has these various possible options. If you pay attention to everything covered in the lecture, you should be able to answer all of these quizzes 100% correctly. You can verify it over here, so in this case the correct answer is URP with the 2D render. So yep, it's a nice green, that means it's the correct answer. But if you get it wrong, like over here for example you said AGRP, yep, you can see in red, so that one is wrong and this is the right answer. So this is the correct answer, and then here just a short explanation on why that is the correct answer. Then once again you can click on next, go on to the next question, or go back and go through all of them. You can see the nice little tick icon telling you which ones you've already gone through. And over there on the main window, we can also see, so on the FAQ, we've answered 3 out of 10, and the quiz 1 out of 7. And if you go back on the lecture list, yep, over here you do see the numbers, so the progress of both the frequently asked questions and the quizzes. So over here, 4 out of 17. And again, the whole purpose is that by the end of this course, you have gone through all of these and got 100% on all of these. So basically, after watching each lecture in the course, what you should do is go here, open up the companion project, open up the correct lecture that you are currently following, then go through all the FAQs, read all of these, go through all the quizzes, read all of those, try to get the right answer. If you need to, you can also read a quick lecture summary of each lecture, so just a nice refresher of everything covered in the lecture. And if you do all those, you will definitely gain all the knowledge in each lecture. Also, there are 2 more separate windows that can really help, included in the companion project. So over here on the CodeMonkey submenu, you've got the chat with AI window, and over here, very simple, you just got a simple input text. So here you can write something, like for example, why do we use URP instead of AGRP for making this 2D game? You can ask that question, send it, and yeah, basically this one is going to ask an AI that again was trained on the contents of the course, so the AI should be very good at answering questions specific to the contents of this course. You ask the question, then it waits a while, and yep, here is the answer. So we use URP instead of AGRP for making a 2D game like Lunar Lander, because URP is more suited for general use case and can run on a wide range of platforms. It's optimized for 2D games with features like 2D lighting and a bunch more. So yep, if you have any specific questions, you can go ahead and ask this. The obvious benefit is that you get a near instant reply. But of course, always remember you can always just post a question on the comments of each lecture, and I myself will go through, I will read those questions and answer them. But of course, I can't be online 24/7, so I might take up to 24 hours to answer, whereas over here, you've got a nice instant reply. And the other window is the companion window. So this one is basically just a window that is constantly checking your code for errors. And anytime you've got some kind of error that shows up in the console, this one will try to help you solve that error. So for example, if you have a null reference exception, it will give you a link for my video where I covered how I solve every null reference exception. So this companion window can be quite useful for helping you solve all kinds of errors. Alright, so that's the companion project. Just open up the main window, here you've got all the lectures, and just remember to go through all of them, go through all the FAQs and quizzes, so that by the end you have 100% completion on all of them. Again, remember, the only goal is really that you're learning, and if you go through, if you make the effort of going through all of these, if you do that, then I guarantee you will learn quite a lot more as opposed to if you just blindly watch every single lecture. Remember how you have to put into practice what you're learning in order to make it stick. That is why I made this companion project, so I highly recommend you go through this in order to validate that you are indeed truly learning. And if you're following along in the free YouTube video, if so, you can still do this. You don't have access to the companion project, but at the end of every lecture, there's a screen containing the titles for all the quizzes and FAQs. So if you're watching the free version, you can use those to guide yourself in your learning journey. Just go on Google and try to find answers to all those questions. So if you can't afford the premium version, that's awesome. You basically have a very easy guided path that has been pre-prepared for you. All you have to do is follow the path and you will gain a ton of knowledge. But if you can't afford it, then that's fine. You really just need to put in more work yourself to find the answers to these questions. Just watch the slide at the end of every lecture and put in the work to really learn. Alright, so yep, remember to do this after every single lecture. And let's keep going on to the next one. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to create our lander, and of course, how to do it properly by separating our visuals from our logic. Okay, so let's begin making our player object, so the lander itself. And like I mentioned in the intro for this course, in this course, I'm teaching you the best practices, meaning what I'm teaching here is not how to make a quick and dirty prototype with some quick and dirty code, nope. What I'm teaching here is the proper way to do things, just like I do in my own professional indie games. So for making the lander, we could just go on the textures and just drag and drop the lander sprite. Then on this game object, we could add all kinds of physics components. However, one very simple but very useful rule that I highly recommend you follow is simply this. Always separate the logic from the visuals. This one simple rule will help prevent so many problems that you might have. So here, let's follow that rule and build our game properly, which means that instead of dragging and dropping the sprite, instead of having this component that has the sprite written component, then physics components, logic components, and so on, instead of that, let's get rid of this one. Let's create a completely empty new game object, name this our lander. So yep, here it is, it's a completely empty game object. Let's reset the transform just to keep it nice and clean. So yep, there it is, totally empty. It has no visual, no nothing. All it has is really just the transform component, nothing else. And now this game object, this will be our parent game object that contains all the logic for our lander. So the component to move the lander, to listen to input, to add physics and so on, we're going to place it over here. And now inside of this one, as a child object, so let's right click inside this game object, and let's create an empty game object. Yep, there you go, that's a child object. And on this one, let's call it a sprite. So this is the one that is actually going to have the visual. Now, one very important thing is over here on transform, make sure the position is set to 0, 0, 0, so everything is exactly like this. That is because, like I mentioned in the Unity Basics lecture, over here this tells you the local position. So if you have this offset to something, then it will be offset compared to the parent, and you don't want that. You want this one to be placed exactly on the same position as the parent. Okay, great. And now this sprite one over here, let's just add a component. Let's search for sprite renderer. So yep, there it is. This is the component that actually renders the sprite onto our screen. So over here, let's just drag our render sprite, and yep, there it is. Like this, we do have our correct setup. Like this, we have the logic and the visuals both separated. So the parent game object, this will have all of the logic components, like the custom script we're going to make, physics, letters, and so on. And then on the child object, this one will have just our visual sprite, and then we'll have different child objects for different visuals if we need to. Like I said, this is the one simple rule that I highly recommend you follow. Always separate the logic from the visuals. There are many benefits to following this rule. First, just keep things nice and organized. So instead of having like hundreds of components on one object, instead you have it separated over multiple objects. Then another huge benefit is how, since the visuals are separated from the logic, you can easily swap out different visuals. If I want, I can change this sprite and it will not affect the behavior of the lander, because again, all the logic components are going to be on the parent itself. So if I modify the child, doesn't matter. I can even add multiple sprites as child objects. I can have as many as I want. I can compose a visual using multiple game objects. And again, since I'm not touching the parent, then all the logic will not be affected. Then on the sprite, I can also offset it if I need to, I can rotate it, I can scale it, I can do all kinds of things. And again, it will not negatively impact the logic, since this is really just applying to the visuals. The lender over here, as you can see, still has rotation on 0, 0, 1, 1, and so on. Sometimes you can get some weird behavior if you have logic components that have a scale that is not set to 1. So like this, if your sprite is too big or too small, you can very easily scale up or scale down just the sprite object, whilst keeping the parent game object, the one that has all the logic components. This one always says 1, 1, 1, always says perfect. So like I said, this is one very simple rule, and one rule that I highly recommend you follow. Always try to separate the logic from the visuals. If you just follow this one simple rule, you will avoid so many problems, and it will keep your game much more organized, making it much easier to modify and change. So yep, let's follow this rule over here on the sprite. Let's just reset the transform. Yep, just like that. Okay, great. So now that we have the setup, nothing is still happening. So if I press on play, the game is playing, but again, nothing is happening. That's intentional. Basically, we need to add logic components in order to get some kind of behavior. Our game is going to be heavily based on physics. So the first thing we want is to add a rigid body component. So first of all, like I said, let's go on the parent game object. Let's add a component, and then over here we can search for rigid body. And now this is another extremely important part. Here, as you can see, we've got two of them. There's a rigid body and rigid body 2D. Unity has two completely separate physics systems. There's one for 3D and one for 2D. So if you ever see some weird behavior with physics, like for example some missing collisions, then the first thing you should check is to make sure that you are not mixing both 2D and 3D components. In this case, we have a 2D game, so all our components will be 2D. So over here, let's go ahead and select rigid body 2D and not the other one. So yep, just like this. And with this, if we just hit on play without changing any settings, if we do that, and if there you go, the lander starts falling down. Alright, awesome. So like this, we already have basic physics implemented. It's really that easy. Just add a rigid body 2D component, and all of a sudden, your object will fall along with gravity. By the way, over here, this component naturally has tons of settings. We don't need to touch any of these for now. For example, the body type, you can set it dynamic, kinematic, or static. Basically, static means it will never move. Kinematic means it won't move automatically by the physics system. Instead, you move it yourself. But in our case, we do want it to be moved by the physics system itself, so that is why we want it set to dynamic. Then for the material, this doesn't really matter right now. This if you want to add some bounciness or some friction to your object. In this case, this is going to be a flying spaceship, so we don't need that. Simulate it to make sure that we're actually doing the physics simulation. Then the mass, we don't need to worry about this too much. The linear damping and angular damping, we're going to modify this a little bit when we implement some controls in order to make sure that the lander functions exactly as we want it. Gravity scale, if you want gravity to be stronger or not as strong. Then for collision detection, we're going to handle this later on. For sleeping mode, this is a optimization technique. So again, don't worry about this for now. Same thing for interpolation. And over here, constraints, info, all of this. So yep, for now, leave all of these just on the nice defaults. Okay, so like this, we already have our spaceship falling down. If I hit on play, yep, there you go, falls down with gravity. Now, the next important thing is collisions. So let's go ahead and make some kind of floor. So on the empty hierarchy, I'm going to right-click, create a new 2D object, sprites. Let's make a simple square. And if there it is, now let's just move it around, put it down here. Then let's scale it. Let's put it something like this, kind of like an ice floor. Okay, great. And just like this, now if we hit on play, let's see what happens. So there's the lander, and yep, look at that, it just goes through the floor. Now this is actually intentional. That is because by default, by themselves, objects don't really have a physical shape by default. We need to explicitly add that, and we do that by using collider components. So over here in our lander, let's add another component. Again, on the parent game object, the one that has logic components, let's add something. And there are all kinds of collider components of all kinds of shapes. You can see we've got circle colliders, capsule colliders, box colliders, and so on. In this case, this spaceship is sort of boxy, so let's go ahead and use the box collider component. And again, make sure you don't mix 3D and 2D components. This is a 2D game, let's add the box collider 2D. Okay, so yep, so we have that component, and actually over here on scene view, we can see those little green lines. That is the actual shape of our collider. We should make sure this roughly matches the visual. So for modifying that, you can over here directly modify the size. So if I modify the Y, yep, there you go, and increase or decrease the size. So you can do that by either typing in numbers, or you can click on this little button over here that says Edit Collider, and when you click on it, yep, over here you do see these 4 little dots on the squares, and you can just drag it around in order to perfectly position the collider with whatever shape you want. Now again, since we made sure that the visual is actually a child object, it is separated from the logic components. Over here, we just need to make sure that the collider matches the rough shape of the visual. And by the way, here's a quick game design tip. Usually you want the collider for the player to be slightly smaller than the visual. That way the game will be a little bit more forgiving, which usually makes for a more fun experience. So unless you're making something like a really hardcore precision platformer, in those cases maybe you want it to perfectly match the visual, but in most cases, for the most part, you want the collider to be slightly smaller just to make the game a little bit more forgiving. Okay, great, so this is our collider on the lander, and now if we hit on play, and if we wait, and there you go, same thing, still goes through the floor. Once again, it's the same thing that I said, objects do not have a physical shape by default. So if we want the lander to collide with the floor, if so, we also need the floor to have a collider. So let's go ahead, select the floor game object, so here it is, and let's add a component. And on this one, pretty much same shape, so let's add a box collider 2D. And this one, by default, should already match the visual perfectly. We can click on this little icon and see, yep, there you go, the collider shape is already perfectly matching the visual. Now for now, this floor, this is really just a temporary visual. Later on, we're going to use a proper terrain to define our actual floor. But for now, yep, just a simple white sprite that works great. And again, the collider is now set up correctly. So now if we test, and we wait for it to fall down, and yep, there you go, it does fall down perfectly on the floor. Alright, awesome! So as you can see, adding physics is super easy. You just add a handful of colliders and suddenly everything works as intended. By the way, let me show you what happens if you mix colliders. So for example, over here on the floor, let's remove the box collider 2D and let's add a box collider the 3D version. And over here for the shape, yep, still has the exact same shape. If we head on play, and we'll look at the lander, and yep, there you go, it goes through. Again, like I said, the 2D and 3D physics systems, those are completely separate. They do not interact with one another. So if you see any weird behavior, then the first thing you should do is double check the type of component you're using. So in this case, it's a 2D game, so let's make sure to always use 2D components. And if we do this, and we see what happens, and if there you go, it works again. Okay, great. So with this, we have our lander correctly set up. We basically have physics, it falls down with gravity, it has colliders, so it can land on the floor. And of course, we made things nice and proper. We follow the one simple but very valuable rule of always separating the logic components from the visual components. So now that the lander is set up, now we just need to add some control to it. And to do that, we're going to make a nice custom script to handle it. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to create a custom script and listen to some player inputs. Alright, so we already have our nice lander object. We added a rigid body, so if I hit on play, it is going to automatically fall down gravity, yep. Then we also added colliders to both the lander and the floor, that is why it falls down and lands on the floor, so that's great. Now, the goal of the game is for the player to be able to actively control this lander object, so let's make a custom script to do just that. So let's go to our project window, and over here on this one, first of all, like I said, let's do things properly. So let's organize our files in a nice way. We already have a bunch of nice folders. Like I said, here I'm teaching exactly the same way that I build my own professional Steam games. And yep, I like to organize things by folders, just like this. So I've got a prefabs folder, scenes folder, sounds, textures, and so on. And now let's also make another folder. So create a brand new folder and call it scripts. And now inside this folder, let's right click and create a brand new monobehavior script. Let's give it a proper name like lander. Yep, just like this. So let's wait a little bit for the code to compile. Okay, it's done. Now let's double click on this file. And yep, here we have it open in Visual Studio. Okay, great. So this is the starting point. Now, like I mentioned in the beginning, if you want to learn about C# specifically, then you can watch my fully detailed course on that specific topic. But if you're a beginner, then also don't worry. Here I will also be teaching how C# works. Although if you want a deeper dive into the language itself, then I really highly recommend you go through that course, either right now or after you finish this course. Okay, so here we have our script. Basically, this is a class named lander, and importantly, it extends the monobehavior class. So this is very important. In order to be able to use this script as a component, meaning in order to be able to attach it to a game object, we need to extend monobehavior. If we don't, we can't add it to a game object, we will get an error. So let's leave it like this, so let's extend monobehavior, and then by default, it automatically implements two functions, the start and the update. The start function, this one runs just once when the game object where this script is attached to is first created, and the update function, this one runs on every single frame. So if your game is running at 60 frames per second, if so, then this update function will be called 60 times per second. We can actually easily verify this. So over here on start, let's print a message to the console. And simple way to do that is with debug.log, and let's call this log function. And over here we say something, so let's say start. And then on update, let's do the same thing. So on this one, let's say update. Okay, so yep, so just like this. Now as always, let's make sure to save the file. So yep, there you go, changes are saved. And now this is compiling, finish compiling. And now if we hit on play, and nope, nothing happens, no messages in the console. That's intentional, that's because this script needs to be attached to a game object. It doesn't just run automatically just by existing, it needs to be attached to something. So let's stop playing, and over here on our Blender object, again, in keeping with our good practices, let's add it over here to the parent object, not the child sprite. This one is just visual. Since we're adding a logic component, let's do it on the parent, the Blender object. And on this one we can add it, so we can either click on add component and find our Blender script, or alternatively, just go here and drag and drop that script on there. Okay, great, so the script is now attached to the game object if I hit on play. And if there it is, we do see the messages. So if we scroll all the way up, yep, we do see we got just one start message and then tons of updates, basically getting as many updates as the game is running. So the game is currently running at 144 frames per second, meaning this update function is being called 144 times per second. Okay, great. So like this, we have a custom script attached to our object. And another super important thing in terms of good practices and writing good clean code is how we should be very explicit in our code, which in this case, it means we should define the access modifier for these functions. Now, by default, the default Unity code does not implement them. It hides the access modifier by default. And technically, if you omit it, it does default to private, and that is exactly what we want. But still, we should always be explicit to leave no room for doubt. So over here, instead of just doing void start and void update, we should always be very explicit, make it private void start, private void update. Private basically means that this function can only be called by this class, so any other class in our game cannot call this function. That's another very important lesson that we're going to be learning throughout the entirety of this course, is how the basic rule for how to write good clean code is to minimize access as much as possible. So if this function is not meant to be called by anyone else, which in this case it isn't, if so, then this should always be marked private. By default, you should make pretty much everything private unless you have a very specific reason why you need to make it public. I have another extremely important video on this topic, and I also talk a lot about it in detail in my C# course. But in general, like I said, we should explicitly define it as private so we can very easily see the access modifier applied to this function. It is not public, it is not protected, none of that. This one is marked private, so always be very explicit. Now, if you're a beginner, you might be a bit confused as to why I'm making such a big fuss about such a seemingly small thing, but the reality is that whilst it might seem like a small thing, the details really do matter. You should want to write good, high-quality code. It might seem unnecessary right now, since we basically have no code here, but as you make more and more complex games, it becomes more and more important to write good, high-quality, clean code. So when you define functions, always explicitly write the access modifiers. In this case, for these functions, we want to keep them private, so yep, let's explicitly write private. Another thing is how you shouldn't write useless comments. So in this case, these default comments that come with the script, these are unnecessary. So yep, just like this is our proper script. Again, I have an entire lecture on comments in my C# course. Okay, so here we have our nice custom script. Now we can start to do some fun stuff. For example, let's listen to input. So here in the code, we're going to listen to input over here on the update function because we want to test for the input on every single frame, not just once on start. So we're going to do it here, and actually we're not going to need start at all, so we can actually remove it. Alright, so over here on the update, for listening to input, we actually have two options. So there are two input methods we can use. Unity has both the input manager and the input system. Now these are completely separate and they work quite differently. So if you're following along various tutorials, you might see some different code. First of all, you need to actually see which one you have active. We can see that over here in the editor. Let's go into edit, let's go into project settings, then scroll down onto the player tab, and over here let's scroll all the way down until we find, here it is, the active input handling. And if by default on new projects, this one is using the new input system package. If you have it set to this, then you can only use the new input system. Whereas if you have it set to that, you can only use the legacy input manager. And if you have it set to both, then you can use both. Now I have to say, the input manager is still quite nice. Despite being relatively old, it is still pretty easy to use. It is not very capable when you want to do complex things, but for getting started, it's actually quite nice. Although on the other hand, you've got the new input system package, so this one is quite a bit more complex, but also quite a lot more capable. So personally, in my projects, I actually tend to use the input manager in the beginning whilst building my prototypes, just because it's so easy to use. But then at a certain point, I refactor my codes to use the input system just because it is a lot more capable. Here in this course, let's go ahead and use the input system, but I will also teach you how to work with the input manager, just in case you see some other tutorials that are using the input manager, just so you don't get confused, so I will show you both methods. Okay, so here in the code on the update, because again, we want to check for inputs on every single update, not just once, let's use the arrow keys to control our Blender. So first, let's check if the up arrow key is pressed down, and the way we do that is quite simple. First, we access the keyboard class. There you go, this one right here that exists inside Unity Engine.InputSystem. So let's use this one. Make sure to add the using statement up top, so using Unity Engine.InputSystem. So we've got the keyboard class, And now inside of this one, we can access the current keyboard. This has to do with how the input system actually supports multiple active inputs, but don't worry about that for now. By default, we're just going to use the main current keyboard. And then finally, for what key we want, in this case, let's check for the up arrow key. So we have this one, this key, and then we just want to check if this key is pressed down, so we can use is pressed. And yep, now let's just put this code inside a basic if. Just like this, let's do a debug.log, let's just say up. Okay, so yep, so like this, let's test. Let's make sure to save our script. Let's wait for it to compile, and let's hit on play. And okay, so by default, we have no message in the console. Okay, makes sense. Now I'm going to press the key, and as I press, and if there you go, we've got messages, and as I let go, yep, no more messages. So press, messages, no press, and it's out. All right, awesome. By the way, if you're not seeing messages being fired, first of all, make sure the script is attached to the game object. Secondly, make sure your game is actually playing. And thirdly, make sure the window is actually active. So click right here in the middle of the game window and then press the up arrow. That way you should see the message. Whereas if you click somewhere else, like for example, if I click over here on the taskbar, then my Unity window is now not the active window. So if I now press on up, nope, doesn't work. This window needs to be active in order for it to listen to input. So if I click over here in the center of the game view, press up, and yep, now it works. So yep, here we have a very simple input test. With this basic code, we can tell when the player is pressing the up arrow key. So using this, naturally we can do all kinds of logic. By the way, here, like I said, let me just show you the exact same code, but using the input manager, just in case you see it in some tutorial. So instead of this, you would write if, go inside the input class, and call getKey. This one returns true when the user is holding down this key. And then key code, in this case, for the up arrow, like this. So yep, just like this. So here we have two identical pieces of code. This one is using the legacy input manager, and this one is using the input system. In terms of behavior, they both do the exact same thing. So if you're following along some tutorials, you might be able to see some input code just like this. So just know that it's doing basically the same thing as this. Okay, great. So here, let's use the input system like this. And with this, we have our code testing for the up arrow input. Now we can also test for the left and right arrows. So that's very simple. Let's just test for both those. So the left arrow key, and then we've got the right arrow key, and then here we've got a right, and here we've got a left. So yep, just like this, let's test. So here, if I press the up arrow key, yep, it works. Press left, yep, it works. Press right, and yep, it also works. All right, awesome. So we have all of our inputs being tested. Now all we need to do is just apply some nice physics control. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to control physics through player inputs in order to move the ship and rotate it. Okay, so we've already implemented the simple key inputs. I press the up arrow key, yep, it's detected, press left, press right, yep, all of those were perfectly fine. Now let's use these in order to actually control our lander. What we want is really just to add a force. So when I press on up, I want to add a force pointing it upwards so that the lander goes up. Then we're going to handle some rotation, apply some torque force, either on left or right, so we can easily move the lander in any position. Now the way we're going to do that, the way we're going to add some forces, is by working directly with the rigid body. So on the lander object, this one has a rigid body 2D, and this is the component where we're going to be applying those forces. Now the rigid body 2D, this one is attached to the same game object where our lander script is also attached, and we're going to need a reference to the rigid body inside of our script. And since both are attached to the same object, we can very easily get it. Over here in our code, let's grab the reference for the rigid body. And now there are several ways to do this, several ways to grab references. Like I said, since both components are attached to the same game object, we actually have an easy way of doing it. We can just call getComponent, and within the angled brackets, over here we can put the component type. So in this case, rigid body 2D. By the way, if you don't know what do these angled brackets mean, these are called generics. If you want to learn more about this topic, I have a lecture on generics in my CSharp course. So yep, this one over here, this will basically give us the rigid body 2D component. However, calling getComponent like this on the update is something you should pretty much never do. If we do it like this, that means we are constantly looking and grabbing the reference on every single update. That's pretty wasteful. The component does not change, so we really only need to grab it and store it just once. So instead of doing it over here, let's implement a nice simple awake function. So private void awake. So this one is very similar to the start function. It runs just once. The awake runs first, and then the start runs. Now, as a general rule, I tend to prefer awake to grab local references, so references on this one game object, and I only use the start function for external references, so references that are not on this object. That is another very simple rule that if you follow it, it will make things much easier. You will encounter many fewer bugs. So for initializing the current object, use awake. For accessing external references, use start. In this case, the rigid body is on the same object, so it's in local reference. So we're going to get it over here on awake. Instead of doing get component over here, let's do it on our awake. And of course, we need to store this reference. So let's define a field. And for the type, let's use rigid body 2D. Again, very important, make sure you use the 2D and not the 3D one. Remember how those two always exist. So in this case, we want the 2D component. And let's call this the lender rigid body 2D. Okay, like this. And over here, when we get it, let's assign it. Okay, great. Except again, not really great. Like I said, let's write high quality, good, clean code. Meaning over here, let's be very explicit with the access modifier for this field. In this case, we don't want any other class in our entire code base to modify this field. So we want this one to be marked as private. Like I said before, private means that this field can only be accessed by this class and nothing else. That's exactly what you want for almost every single field in your game. You might see some tutorials that make all fields public, but you should never ever do that. That's a horrible practice that will lead to so many errors, so many mistakes. I have an entire lecture on this topic that you really need to watch. This is very, very important. When you make a field public, you enable both read and write access to that field from any other class in your entire codebase. That's a very bad thing because it can lead to this field changing without you knowing why. So fields should pretty much almost always be marked as private. If so, that means this field can only be read and modified by this class and nothing else. So your game could be made up of 1,000 classes and it really would not matter. None of those could read or modify this field because this one is marked as private. That's exactly what we want. We want to minimize access as much as possible. That's a key concept, minimize access. And since this field is only ever meant to be used by this one class, then it should be private just to enforce that rule. Okay, so we've marked the field, we've defined it, marked it as private, and we got the reference over here on awake. Now we can finally do some work with it. And over here on the update, we can do some work. However, not quite. So far, we've been writing this code over here on update, and yep, this works fine. The update function, this one runs on every single update. So it's where you usually want to place logic for a game that is meant to be constantly happening. However, physics actually works slightly differently. When working with physics, you want to be working on something different. You want to be working on the fixed update. This is quite different. This is a special update that runs on a fixed interval regardless of frame rate. You can actually find the timer if you go onto Edit, Project Settings, and then on the left side go down into the Time tab, and over here you can see the Fixed Time step. By default it is set to 0.02. What that means is that the fixed update will run every 0.02 seconds, which means that the fixed update will run 50 times per second. So this is how often the physics actually updates. Even if your game is running at a lower or faster rendering frame rate, the physics runs at a fixed time step. So usually when working with physics, if you're writing some code that directly interacts with the physics system, like for example adding some force, which is what we're going to do, if so then you should implement that logic on fixed update and not on update. So instead of using update, let's copy this, paste it over here on fixed update, just like this. And now here we can add a force. But before we do, let me just make another quick note. On some tutorials, you might hear some people say that you shouldn't listen to inputs on the fixed update. The reason for that is because, again, the fixed update does not run on every single update. So if you listen to just key down on the fixed update, then you might miss it because the fixed update is not guaranteed to run on the same time as the update. So you should not listen to key down on a fixed update. However, over here we're not listening to key down, we're listening to is pressed, and this one returns true anytime that the button is actually pressed down. This one is fine to use in fixed update because again, it's not true just for one frame, instead it stays true for as long as we keep holding down the button. So in this case, it's perfectly fine to use this to listen to inputs over here directly on fixed update. I just wanted to clear that up just in case you see in some other tutorials talking about how you should not use input on fixed update. That is simply if you're testing for button click, button down, and not holding the button down. If it's a hold, it's fine. If it's a click, then it should be on update. Okay, so over here, like I said, let's apply some force. So to do that, let's go on the lender rigid body 2D, and let's call the function add force. And over here, we want to move the lender up. However, it is not actually the global up, that is not correct. So if over here we add, let's do a new vector 2, 0, 1. This is the global up vector, and this will actually not be correct. Let's see why. Let's save this. And over here, before we test, let's actually do something. So over here on the lender, let's disable the gravity, put it on 0, just so we can see this movement. Okay, so the game is playing, and if I press on up, and if there we go, it is moving up, so it does seem like it is correct. However, if I now rotate the lender, so if I apply a rotation over there on the z-axis, and now I press on up, and if there you go, look at that, it is still moving up, whereas it should be moving in roughly that direction. So this is the issue. It is going towards the global up, whereas what we want is for it to go up alongside the rotation of the lander. So if I use the handles, Yep, as I apply up, it should apply a force alongside that green arrow. It should not be going just straight up. And thankfully, we can very easily get literally this exact same green vector. This is going to be the up vector related to this lender itself, which is going to be dependent on the rotation. So as I rotate, yep, that vector is always pointing up exactly as we want it. By the way, over here, just another thing, just in case you don't see this. So over here on scene view, you actually have two very important settings. They are up here on the top left corner. You've got this one that says pivot or center. This one has to do with the position of the tool handles. If you put it on pivot, then it's on the pivot of the actual object. Whereas if you put it on center, it will be on the center of whatever object and child objects it has. Now in this case, since the child object is on 0, 0, 0, then the center stays pretty much on the same position as the pivot. But if we have a different offset, if so, then look at that. The pivot is over there, but the center is placed over there. So for the most part, usually you don't want this. If you keep this on center, it will look very confusing. You think the object is in there, but in reality it's over there. So usually you want to leave this one on pivot, and yep, that one is now correct. Then the other very important one is that one that says local or global. So over here with the lender selected, if it's set on local, then yep, we can see those handles, yep, they do perfectly match based on the rotation of the object. But if I swap it out to global, yep, there you go, look at that. Now it is showing just the global rotation. It is not taking the object's rotation into account. It just shows the up and right global vectors. In most cases, you also don't really want this. In most cases, you want the handle to be in local space. You want it to be related to any rotation and transformations applied to this object. So for the most part, you want to keep this one on local, that one on pivot, and yep, like this, the handles are in a much more accurate position. Okay, so like this, like I said, for moving the lander, we want to use this upwards vector, the green vector. And over here in the code, the way we do that is very, very simple. Just instead of adding force, instead of this fixed vector, instead, let's use transform.up. And yep, this one is going to be that upwards vector, which again is based on the rotation of the object. So if we just save this and test, so if I press on up, and okay, it's moving straight up. Okay, now if I apply a rotation, and I press on up again, and if there you go, now it is going that direction. Now I go in the other side, I press on up, and yep, there you go, now it is going slightly in that direction. Okay, great. So yep, everything is working perfectly. By the way, here let me give you just another quick tip. Technically it's something that is not necessary over here since we are using fixed update, but if we were using just a regular update, it would be very important. So let me mention it just so you know. If we were to use this exact same code on the regular update, that would not be correct because it would be applying different amounts of force depending on the frame rate of the actual computer where it's running. So someone running the game at 30 FPS would actually get a different behavior than someone running on 60 FPS. Now that's not good. You don't want two different people on two different PCs to have different force applied. You really want the lander to behave exactly the same regardless of frame rate. So in order to make any kind of movement code frame rate independent, for that we need to incorporate time.delta time into that equation. Now time.delta time, this is basically the number of seconds since the last frame. So for example, if the game is running at 10 frames per second, then this field over here, this will return 0.1. But if the game is running at 100 frames per second, if so, then this will be 0.01. Meaning that this value basically equates to time regardless of your frame rate. So if over here we multiply this by the upwards vector, if so, then like this, the upwards vector is going to be with a magnitude of 1. So for example, 0, 1. If we do it like this, then this will apply that force, 0, 1. You will move up 1 unit per second regardless of frame rate. So this is very important. Always make sure your math inside an update always incorporates time.delta time. You need to do that if it's some logic that happens constantly. Otherwise you end up with logic that works differently on different frame rates, which you really don't want. You want everyone to have the exact same forces. You want the game to behave the same for everyone. So always include time.delta time in your calculations. Now again, like I said, the reason why I said it is not necessary over here is because again, we're running on fixed update. And regardless of frame rate, this one is going to run on a fixed time step. So whether the game is running at 10 FPS or 100 FPS, the fixed update, this one will still run 50 times per second. So that is why, technically on fixed update, you don't need time.delta time. But still, as a general rule, I would encourage you to use it just to make sure you don't have those weird issues. So over here, even though technically this is not required, let's still apply the same thing. And if you want to test your game on multiple frame rates to make sure that everything is working, you can use application.targetFramerate and set it to something like 10 FPS. So now like this, we can see the game's running at 10 FPS. Also make sure VSync is disabled. So yep, if I press on up, and if there you go, it is moving up. Now it's moving way too small just because we are multiplying by time.delta time. But yep, it is moving up. And if I remove the target frame rate so that it's back to unlimited, if I go and I press on up, and if there you go, the same force is being applied. So the game is running and the lander is moving at the same speed regardless of being at 10 FPS or 144 FPS. Again, that is really what you want. You don't want your game logic to be dependent on frame rate. Okay, so the upwards movement is working great. It's just very slow, but we're going to deal with that in a little bit. First, let's on the rotation. Now, the rotation, that one's actually going to be quite similar. We're also going to do some work on the rigid body itself, except instead of add force, instead of this, we want some rotation, so let's use add torque. Torque is a rotational force, so let's do it. And this one really just takes a float value for the torque. So for moving left, let's add, let's say 5. We're going to play around these numbers in a little bit. Times time dot delta time, again, don't forget it. And for moving right, let's put -5. Okay, so yep, like this, let's save, let's test. So here we are, and I press the left button, and if there you go, rotates left, press right button, and if there you go, it is rotating right. And if I press up, again, the force is still very low, but yep, it is very slowly moving up. All right, awesome. So our logic is already working, we already have quite a bit of control over our lander. Now all we need to do is really just use some proper values. So first on the lander itself, over here on the gravity scale, let's put it a little bit, let's put it on 0.7. Then for the linear damping, this one is basically going to dampen the speed as the ship moves. We don't want it to have basically 0 friction. We want it to dampen a little bit just to make it a bit more fun. So let's put 1. And same thing for the angular damping. We don't want it to keep rotating for infinity, so let's put it something like 5. Okay, great, so these settings like this. Then another thing, which is let's make it nice and smooth. So over here on the interpolate setting, let's set it to interpolate. So interpolate, this has to do with, like I said, the fixed update. How that one updates 50 times per second. But if you're running on a PC where your game is running at, let's say, 144 times per second, meaning the frame rate, if so, then it might look a little bit stuttery if you leave this one on none with no interpolation, because it's really only going to update 50 times per second as opposed to 144. So in order to make it look smooth, we choose this one as interpolate, meaning it will interpolate the values in between the last fixed update and the next one. So that way, even if our frame rate is much higher than the fixed update rate, even in that scenario, it will still look nice and smooth. Okay, so now here, let's just apply some proper forces. So for the up vector, let's apply something like 700F. However, here we have another very, very important lesson on writing good, high quality, clean code. We never ever want to use numbers just like this. This 700, this +5, -5, and so on. This is terrible, this is bad, we should not be writing this code. This is what are called magic numbers. They're basically numbers that exist in the code that means something, but it is not immediately obvious what it is. That is not good. You should never ever have some magic numbers. Your code should be as understandable as possible. It should be easily understandable. You should not have some obfuscated meaning by using some numbers that impact the code in some magical way. You should always be very explicit as to what those numbers actually represent. So here, instead of just using some magic numbers directly, instead of that, let's just find some local variables with some proper names. So on this one, this is the force that we want to apply. So let's define a simple local variable, just call it force, defined as 700F. And now we replace this with force, and now it is much more clear what we're doing. We're applying a certain force towards the up vector and towards time.delta time. So this way, this line of code is much more understandable, as opposed to having a 700 over here that we would have no idea what exactly it means. And same thing over here on the turn, let's define a float for the turn speed. This one, let's put it on plus 100F, and let's use turn speed. And over here, another float for the turn speed. This one's minus 100F. And let's use the turn speed like this. So yep, that's it. Now it's much more clear as to what these numbers are meant to represent. They've got proper variables with proper names. So we can just read the code and it literally reads very understandable. So always remember this one simple rule. Never ever use magic numbers. Always make them local variables with some very clear descriptive names. Okay, so like this, let's save and let's test. So here we are, and yep, since we enable gravity, it starts falling down, okay. And now if I press on up, and yep, there you go, it starts moving up. And I can press and let go, it falls down in gravity, that's great. And move left, and yep, that works, rotates, right, also rotates. And yep, there you go, so just like this, we already have a nice little lander that we can control. I can go up, right, left, down, and yep, the whole thing already feels quite nice to play with. Alright, awesome! So yep, just like this, we already have something pretty fun, pretty satisfying to play with. Again, if you want, you can modify all these values. These are not set in stone, so if you want, you can add more or less linear damping, the angular damping. You can make the gravity a bit more intense. You can play around these values, add more force, more turn speed, and so on. These are all very much customizable, so this is where some game design skills come into action. But in this case, I think these values look pretty nice, so the ship moves up, falls down in a nice, satisfying manner. I can move left, right, and everything feels weighty, but still very nice. Okay, so we have the lander, we can control it. That's awesome, that's great. Now let's just remove this boring floor and replace it with something a bit more interesting. Let's add a proper terrain. So let's do that in the next lecture. Hello Hello and welcome, I'm your Cinemachine. In this lecture we're going to learn how to build a nice 2D terrain. We're going to use a tool called SpriteShape to enable us to build any terrain shape we want. Okay, so let's build a proper terrain instead of just using this simple white box. So let's go ahead and remove this one, so remove the square. And let's also zoom out a bit just so we have a little bit more room. So let's go on the main camera. And what defines basically the zoom is over here the size of the camera. This camera is a 2D camera, so it is set up as an orthographic camera. And 5 over here, this orthographic size, this is basically half the vertical size in units. So if we have 5, that means we have a y of 0 over here in the middle. Then we've got plus 5 up here and minus 5 down here. We can actually verify, so we can create an empty game object. And let's just position it, and if we put it up there, we can see, yep, the y is 5. And down there, yep, it is minus 5. So let's zoom it out a little bit. So instead of orthographic size of 5, let's put it on 10. And if there you go, a bit more space that we can play with. Now, like I said, we're going to use a tool called SpriteShape. This is a really great 2D tool that allows you to build some really weird shapes. So in this case, it is absolutely perfect for a terrain. In the hierarchy, let's right click. We're going to create a new 2D object. Let's create a new sprite shape. And since it's a terrain, let's go ahead and make a closed shape. Okay, yep, so there it is. It spawns right there right away. By the way, one quick tip is over here on scene view, we can actually disable post-processing just to be able to see it a little bit easier. Just because in white, this is going to glow a little bit too much. Although this will also stop glowing once we add a texture, so it doesn't matter too much either way. And also another important thing, if you're having issues seeing it over here on camera view, make sure the Z is set to 0. Like this, it should be fine. So anyways, we have this nice weird shape. And this is actually made up of multiple points. Here in the inspector, we can see the SpriteShape controller. And on this one, we see this little button to edit the spline, and if I click on it, yep, there you go, now I can see all the various points that make up this shape. And if I click to select any of them, yep, then I do see all the various handles. So we can move this around, and we can basically create any shape we want. So yep, with this, by modifying these points, by adding more points, we can basically create any shape, any terrain that we want. We also have some bonus controls that appear when we select something. So over here on the scene view, we can see first of all the tangent mode. So this handles basically how the corners, how the points connect to one another. So it can be pretty much straight, just a perfect angle. We can have the handles on the side that we can define to make it bigger or not. And we can define that one, which basically breaks one or the other one, whereas this one keeps both them always opposing one another. So in essence, these points are really just splines, so this whole thing is just a spline. By the way, I have a tutorial on splines, in case you want to learn the math behind it. Now in this case, since this is meant to be some kind of moon-like terrain, I think making it a little bit more jagged makes more sense. So let's just select all these corners and make them all perfectly straight. Then of course we can change the visual, so it's not very nice if it's just a solid white blob. So let's go onto our project window, and over here let's right click an empty space. Let's go ahead to create a new 2D, let's create a new SpriteShape profile. And yep, so now we have this asset, and basically this one over here, this one has all kinds of settings for how the SpriteShape will look. One important one is over here, the fill texture. Let's go ahead and drag the texture that we have, so let's open up the textures folder. And up here, yep, we've got the rock background. Let's just drag it over there onto the fill texture. And if there you go, exactly like that. Now let's just use it, so let's select the closed sprite shape, and let's actually rename this to our terrain. And over there we've got the profile, so let's just drag the profile that we had just created. And if there you go, we can already see the nice visual. So yep, we've got the rocks there, except it still has the solid white outline, so let's select the sprite shape profile. And over here on this one, like I said, you can see it has tons of options. For example, we can define individual sprites for each of the various corners. We can define sprites for various angles and so on. So this is how you can make, for example, some platforms that have some kind of grass on top but not on the sides. You can easily do that kind of stuff here with this tool. This is a super useful tool, especially for terrains. But in our case, we really just want the fill texture and no border whatsoever. So in our case, let's just select the sprite shape here and just remove it. And if there you go, now we have no outline. So yep, this is our shape, and of course the whole thing adapts. So if I select this one, and if we edit it, if we add more points, and we drag it along, and yep, there you go, the entire texture, all of it perfectly matches whatever shape we want. So yep, this is perfect. By the way, if you're using a custom texture, you can play around with the scale. So here on the SpriteShape controller, you've got the pixels per unit. If you modify this one, you can basically make it a lot more or a lot bit smaller. In this case, let's go with something like 300, and yep, that looks pretty good. Okay, so we have our terrain. Now let's just make a nice shape. So let's actually push this out over there. So we've got something on the bottom there. Then we got something that slightly increases, goes over there, and then off to this side. And then on the right side, let's add another sort of a mountain. We're going to eventually have another landing spot roughly around there. And then the mountain goes down, kind of like this. So yep, there it is. We've got our nice basic shape of our terrain. Let's just put that one over there, kind of like this. Yep, okay, that looks nice. And now if we hit on play, okay, there's the lander falling down, and yep, there you go. Same issue as always, basically just goes through the terrain. Once again, it's because objects do not have a physical shape by default, we need to manually add it. In this case, we want the shape to perfectly match the visual here, to perfectly match this exact shape. So we don't want to use, for example, a box collider or a circle collider. We don't want to use any of those, because it would be really tricky to compose those in order to make this entire terrain. Instead, Unity actually has a much better option. For irregular shapes, what we want to add is, let's add a component, a collider, and over here we can find this one, yep, the polygon collider. As soon as we add, we wait a little bit, and yep, there you go, it does create the shape exactly just like the terrain. So here we can see these nice little green lines. So that's basically the mesh that this component is automatically generating. We can click on Edit Collider to see, yep, it does have the absolute perfect mesh. And if we modify this shape, so for example, if I add another point there, move it over there, just have to wait a little bit, and there you go, the mesh does update correctly. So now if we hit on play, there goes the lander falling down and hits, and if there you go, it stays there. Alright, awesome. So yep, here we use a really nice tool to make our terrain. We can make it in any shape that we want. This will be perfect for doing all kinds of interesting level designs. With this, we can also make some nice big levels. But so far, we can't really play on a big level just because the camera is fixed. So let's solve that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about Cinemachine. So this is a Unity tool that helps you handle cameras of all sorts very easily. We're going to use it to easily make the camera follow our player as it moves. Okay, so far here we have our lander working, and we also made a pretty nice level, but the camera is fixed, so if we go too far, we can't see where we are. So let's fix that. In order to handle some camera stuff, we're going to use Cinemachine. This is a great Unity tool. First, we need to install it. So let's open up the window, let's open up the package manager. And now here, let's go down to the Unity registry and find the Cinemachine package. Yep, there it is, let's install. Alright, it's installed. So now let's use it. And thankfully it's actually super simple to use, especially for our very basic use case. We really just want the camera to automatically follow the player. So over here on the hierarchy, let's right click, let's go ahead and create a Cinemachine, and let's create just an empty Cinemachine camera. And if there it is, so as soon as we create it, you might see that the game view changes. That is because Cinemachine is now driving the main camera. The way Cinemachine works is actually in a really interesting way. So if we look on the main camera, over here on this one, if we scroll down, we can see, yep, this one added an extra component. We've got a Cinemachine brain. This is what is actually controlling the camera. And then for the settings of the camera itself over here, if we are using Cinemachine, then we can no longer touch the camera settings here. So if I try to modify the size to something, nope, doesn't work. It just goes back. If I try to modify the position, nope, doesn't work. I can't modify any of this. That is because, again, the camera is being driven by Cinemachine. So if we want to modify the camera settings, we need to modify it on this other object that was created, the Cinemachine camera. For example, over here we can see the lens, we can see the orthographic size. So if we change this one, yep, now it does indeed change. So let's put the orthographic size back to what it was. So let's put it on 10. And for the position, let's put it on 0, 0, and then -10. Again, this is important. Keep the camera on -10. If we put the camera on 0, then it's basically on the same position as everything else, so we can't see anything. So let's put it on -10. And yep, now we can go back to our original goal. So we really just want the camera to follow the player. That's it. And thankfully, that is super easy to do. So over here on the Cinemachine camera components, here we've got the procedural components, we've got the position control. And on this one, we can add, let's say, a brand new position composer. And if that one adds a second component, so this is really how Cinemachine works. It is also, just like Unity, it is very much based on a component system. So the Cinemachine camera, this one is the base component, and then you can add more components to add more behavior to that Cinemachine camera. So in this case, adding this component will make the camera follow something. And also here we do see this warning. So a tracking target is required in the Cinemachine camera. The tracking target is this field up here. So basically we need to assign this to something. And the goal is to follow the lander, so let's go ahead, drag the lander object just like that. And yep, that's really it. So like this, our camera is already following our lander. So if I go ahead and I manually move the lander, so if I move it around, yep, there you go, the camera does follow it perfectly. And same thing if I hit on play, and if there you go, now it is moving, so I can fly around anywhere, and yep, the camera moves perfectly. Alright, awesome. So that's really how simple it is to make a camera follow an object. It is super simple thanks to using Cinemachine, so this is a really awesome Unity tool. Now if we want, we can play around with a bunch of these settings. For example, I don't really want the camera to follow all the time. I want to have a little bit of a dead zone down the middle. Basically, I want it to stay still for a little bit whilst the lander is right in the middle of the screen. So down here on the Cinemachine composer, over here we can enable a dead zone. We can set it to some size, like 20% of the screen. And if this sounds about right, we can go here on the game view guides and we can enable those. And if we can't see what is happening, so basically the dead zone, if it is disabled, basically it's going to follow the lander absolutely perfectly. But if it is enabled, then if the lander is within this position over here, then it's basically not going to follow it. So that makes it a little bit more stable down the middle. Personally, I think this is better, especially since the game is all about landing and doing some very accurate landing, because that kind of helps if the camera stays a little bit still instead of just bouncing up and down way too much. So like this, let's disable the game view guides and test. So here we are, and yep, if I stay down the middle, then the camera doesn't move, but as soon as I go past that, yep, there you go, keeps following as normal. Okay, great. So yep, if you want, you can play around with some of these settings. If you want, you can make the orthographic size a little bit bigger. If you want over here on damping, you can make it more or less. You can enable or disable look ahead. So there's really all kinds of options that you have over here. You can play around all these settings, but I think just like this, it's all working perfectly fine. So yep, we have our camera working nicely. Now we can explore basically the entire world we built, and the camera follows along. So that's awesome. Except the background is still boring. It's just a boring, solid blue background. So let's add a nice texture to it. And in doing so, we're actually going to learn about the 2D sorting order. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn all about 2D sorting order. So this is how we can define what sprites go on top or behind what other sprites. Alright, so here we have our ship and our terrain, so that's great. However, the background is really boring, just this default blue. Here in the project files, I have another texture. We've got a nice background. This one has some nice stars, so let's use this. Let's just go ahead, drag it onto the hierarchy, name this the background. And now over here on the sprite renderer, over here we have some interesting options for the draw mode. By default, we have simple. So like this, if we use the rect tool over here in order to scale this one, yep, basically just increase the size of the image just like that. This is not nice. We want the texture to basically repeat itself. We don't want it to be all stretched out. This does not look good. So nope, let's not use this. Instead, let's make sure the scale is set to 1, 1, 1, okay? And then over here on draw mode, instead of simple, let's put it on tiled. And yep, now we can again use the rect tool, and now if we move it, yep, there you go, instead of being all stretched, now it's really just repeating itself. And by the way, if you don't see that, if you see some stretching, if so, over here on the scale, make sure it's set to 1, 1, 1. Okay, so yep, so we really just want this background to occupy pretty much as much of the play area as we can. So let's put this on something pretty big. So over here on the width and height, let's put it on like 200 by 200, something like this. And if like this, we've got a very massive player area we can play with. Also, by the way, one quick tip, which is don't make this way too big. Like if you make this 1000 by 1000, if so, you might get some weird artifacts. Look at that, now it looks very strange. And if you look on the console, you will see this error. It is telling you that this size is too big, requires a certain amount of vertices and a certain amount of indexes. Basically, this has to do with the mesh generation and how meshes actually have a limit to how many vertices they can have. So over here, you can't make this insanely big, but we also don't need it. I mean, 1000, this is an insane amount of space. I mean, that's the size of the lender. We don't need this much space. So over here, let's just put it on 200 by 200. And yep, that one does not throw the error and everything looks nice. Okay, great. So with this, we have background occupying a large area. With this, the player will never go out of bounds. That's great. In this case, for me specifically, everything actually worked fine. So we've got the background behind the lander, behind the terrain. So in my case, everything seems to be fine, but in your case, you might have some sprites above other sprites. Perhaps for you, the background showed up on top of the lander or on top of the terrain. So here's where you need to learn about something very important, which is basically how do you deal with sorting order on a 2D game. So how do you define which sprite should be rendered on top of which? If we were making a 3D game, if so, then the sorting order would essentially be based on distance to the camera. So if we were using a 3D camera, we would define the sorting order based over here on the Z. So things closer to the camera would render on top of things further away from the camera. But here we're not using a perspective camera, we're using an orthographic camera, and for the Z, every single one of these sprites is on Z of 0. So thankfully in Unity, how we handle sprites in 2D is actually pretty simple. We really just have two options. So over here on the sprite render, we can find these two, the sorting layer and the order in layer. So basically for the layers, we can create different layers and define what layers rendered on top of which. And then for the sorting order, this one is just a number. This one is for sorting objects within the same layer. We can add basically as many layers as we want, so we can click on this and let's add another sorting layer. And yep, it shows up this window. Over here we've got the sorting layers and we can add a bunch of them. So for example, let's add one. Let's name this the background. And over here on this list, this is a very interesting list. Here we can move around, we can drag it up or down. And the way this works is how things are rendered from top to bottom. So like this, the default layer will render and then the background layer renders. So actually like this, the background will be on top and not below. So we really want the opposite. So let's click and drag and put the background above that one on the list, meaning the background is going to draw first, and then default objects, those are going to be drawn on top of the background. So now we can go to our background over here on the sprite render. Let's set this one, the sorting layer, on the background. And yep, now like this, everything should be working correctly. The background should be behind both these sprites. Then like I said, we can also modify the sorting order. That's for sorting within the same layer. So over here for the lander, if I look inside the sprite for that one, yep, let's leave this one on the default sorting layer. And terrain, let's also leave that one on the default sorting layer. Both are on the same layer, and right now both are on the same order in layer. Meaning on my PC it might render one on top of the other, and on your PC it might render differently. Usually you want to be explicit about what order you want. If over here I move the lander and I put it right there, we can see, okay, so in my case the lander is rendering behind the terrain. I actually don't want this. I think it looks better if the lander shows up on top of the terrain. So over here on the lander sprite, let's just go ahead, order in layer, put it on +10. And there I go. So now both of these are on the same sorting layer, but that one is on a sorting order of +10, whereas that one is on a sorting order of 0. So this way the lander will always be on top of the terrain, and both the lander and the terrain will both be on top of the background. Let's just put it over there like this. So yep, you can see just how easy it is to order things in 2D. You just play around with sorting layers and sorting order and everything looks great. So with this, we have our nice background working, so we can fly around this world. So that's fun, everything is rendered correctly. Now the next thing we need is to handle both the landing and crash detection. We need to figure out if the lander went down smoothly or not. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn how to detect if a landing was soft or hard. We're going to use a bit of math in order to figure that out. Okay, so far we have our lander that we can control using physics, and we also have the world that we built, so we built nice terrain, and the camera also follows the lander, so we can go all the way around. So yep, that's all great, but right now if we touch the floor, and nope, nothing really happens, we fall down, we get back up, yep, everything works just the same. The goal for this game is to have some nice soft landings. So we do need to identify if, when we touch on the floor, if this was a proper landing or a crash. So let's do that. First, let's open up here the lander script. And here, the first thing we're going to need to do is basically test when a collision happens. Now, thankfully, Unity has some great built-in functions to test for just that. Down here, after the fixed update, let's write private void, then on call. And up here, we do see all kinds of collision functions. We see on collision enter, on collision exit, stay, and so on. Now again, note one very important thing. Like I've mentioned, Unity has two completely separate physics systems, so don't ever forget that. So over here we have both 2D and 3D versions of the same thing. So this is really important. This is a very common mistake that I see a lot of people have. They implement the wrong function, then don't know why it's happening. In our case, this is a 2D game. We are using 2D physics, so let's make sure to use the 2D functions. And in this particular case, for testing if we landed successfully, we basically want to test when a collision happens, and that is right here, the onCollision enter 2D. So like it says here, this one is called when this collider or rigid body has begun touching another collider or rigid body. So if this one triggers just once as soon as the collision starts, then the exit is basically when the collision is stopped. So basically if we land then move away, this one is triggered. And say basically this one is constantly being called on every single update for as long as that collision stays active. Now in our case, like I said, just for testing for landing, we really just want the enter, so we really just want to know when a collision first happens. So let's use this one, the onCollision enter 2D, and over here let's just do a log. So let's log onCollision enter 2D. Let's save this and test. So over here, if we fall down, and yep, there you go, as soon as we touch the terrain, yep, we do have our message. Okay, great. So now that we have this function, now we can test to see if the landing was successful or it was a crash. And for this, we're basically going to have two elements in our equation. So number one is going to be the speed, so how fast do we actually fall down? If we land way too fast, it's going to be a crash. So the goal is for the player to basically control as the spaceship goes down and land softly. If it comes down way too fast, then yep, like this should be a crash. And the second important thing is going to be the angle. So if we land at an angle kind of like this, so pretty much parallel to the ground, this is correct, this is a correct angle. But if you land something like this, then yep, this one should be a crash. So in order to have a proper landing, it needs to be both moving slowly and on a relatively upwards direction in order to consider it a successful landing. So let's implement all those conditions. So the speed one is going to be the easiest, so let's start there. Over here on this function, this one, as you can see, takes a parameter of type collision2D. Let's actually rename this, name this collision2D. Personally, I like to keep the names to match the types. That's just personal preference, you don't have to. So anyways, we've got our collision2D, and this type over here, this one contains a bunch of data related to our collision. So we can inspect and see. We've got the collider, so that's the collider that we collided with. We can see how many contacts were made in this collision. We can get the game object, get the various contacts, get the other collider, the other rigid body, so we can get a ton of stuff. And importantly for our use case is we have this one, the relative velocity. So this is basically how fast both objects were going when this collision happened. In this case, since the terrain does not move at all, then this is really basically just how fast the ship itself was moving. So we can grab this one, and this one is going to be a vector 2. This contains both the x velocity and y velocity. We want to take both those into account, because we don't want the landing to be soft if we are moving way too fast on the x-axis. So we can basically convert a vector into a simple float by really just grabbing the magnitude of this vector. This is going to be the size of the vector itself. So this will tell us how fast we were going in both the x-axis and the y-axis. And with this we can verify, did we land slowly or not. Let's just do a log just to see what this one says. So let's do it like this. Let's save. And over here, okay, let's try to land down softly. So like this, I'm controlling it, go down. And yep, there you go. Okay, so we've got a magnitude of 1.8. All right. And now let's try to have a really rough crash. So I'm just going to let it fall down way too fast. And yep, we've got 5.9. So yep, we have a low value and a hard value. So let's really just come up with something that seems like it's good enough. So like this. So I would say under 3. I would say that's a soft enough landing. So like this, that was relatively soft. And this one like this was a little bit too much. So yep, let's say under 3F, that one represents soft enough. So here to define a float, once again, as always, never use magic numbers. So let's define a proper local variable with a proper name. So let's say soft landing velocity magnitude, and we're going to set it to 4F. And then we just check if the collision 2D.relative velocity.magnitude, if it is over the soft landing velocity magnitude. If so, then landed too hard. If you land too hard, let's just print out a message. So let's say literally landed too hard, and let's just return just so the function returns right here. And if not, let's say debug.log, let's say successful landing. Okay, yep, like this, let's test. So here we are, let's fall all the way down and touch slowly. And if there you go, successful landing. Now let's try to crash land. And if there you go, land too hard. All right, awesome. So that handles the speed of the landing. Now let's also handle the angle. This one is also thankfully pretty easy to do thanks to a nice math function. We're going to use what is called the dot product. So this is a thing in mathematics. Basically, it gives you the value for how similar two vectors are. If the vectors are both pointing in the same direction, we get one value. If there's an angle in between them, we get another value. And if they are, let's say, 180 degrees, then we get another value. Let's do some quick prints just to see what exactly does it return. So let's do it here on the wake, just for testing. We can use vector2 dot. And yep, this one returns the dot product between two vectors. So we got the left vector and the right vector. So for example, let's print both using the exact same. So new vector2 pointing straight up, so like this, and also new vector2 pointing straight up. So two vectors exactly the same. Let's do a debug.log to see what this says. Then let's also print one with a 45-degree angle. So this one over here, 0, 1, this is just a pure vertical vector. And for this one, let's go one kind of like this. So let's go 0.5f, 0.5f. So this is basically going to be a 45-degree angle. Then let's see what it returns if we have a 90-degree angle. So we're comparing a upwards vector to a right vector. And finally, let's print one that is 180 degrees away. So 0, -1, so we've got an up vector and a down vector. So yep, let's see what all of these print, just so we can better understand what exactly the dot product is. And okay, so there we can see that. So the one that has two matching vectors, that one is 1. Again, both of them are pointing in the same direction, so dot product is 1. Then the second one is a 45-degree angle, and we can see at a 45-degree angle, it returns 0.5. Then third one is this one, which is a vector pointing up and a vector pointing right. So it's basically 90 degrees. And if we have 90 degrees, then dot product is going to be 0. And finally, we have the 180 degrees, so a vector pointing up and a vector pointing down. So 180 degrees on that one returns -1. So yeah, by using this, we can easily test and see if the landing is on a good angle or not. We basically just need to compare the lander's upwards vector with the global vector. And if the global vector points up and the lander vector is pointing, let's say, to the right, so we've got a 90 degree, that is obviously not a correct landing, so that is going to be wrong. So over here in the code, let's get rid of our testing, and then down here, let's test for that. So we're going to get the float for the dot vector, and let's do vector2 dot. And we're going to get, like I said, between the global up, so vector2 dot up, and this transform dot up. So let's do this, and let's do a log, just see what this says. So the dot vector, let's see. Okay, so now let's land perfectly upwards and see what it says. And if there you go, 0.99, which makes sense, because again, both vectors are pointing straight up. And I'm going to try to land on a bit more of a rough angle, kind of like this. And there you go, quite a bit more rough, and that one is 0.91. So basically, if it's above, let's say 0.90, 0.92, something like that is soft. Otherwise, it's going to be a hard, rough angle landing. So over here for this, let's define a float for the min dot vector. So that's the minimum amount. And let's define it as 0.90. And then if the dot vector, if this one is under the min dot vector, then landed on a too steep angle. And let's do a log on this as well. So debug.log on this, and then return, do an early return, just like that. Okay, so yep, so this is really our logic. So let's go ahead, save, and let's test. Okay, now let's start off by doing a soft landing, perfectly upwards like that. And if there you go, successful landing. Now let's try to land way too rough, way too fast, and there you go, land too hard. Okay, makes sense. Now let's land kind of soft in terms of speed, but rough in terms of angle, like this. And yep, landed on a way too steep angle. So yep, we do need to land roughly like this. And if there you go, we have a successful landing. All right, awesome. So yep, we have successfully added some really nice landing detection. We really just have two things missing. So number one is we should really only be able to land on a landing pad, not just on any terrain. And number two, we need to calculate some score. So let's do that in the next lecture. Alright, so quick intermission here. How are you getting along with this course? Are you finding it pretty straightforward? I tried to make the course have a nice smooth learning curve. Whether you're a beginner or an intermediate user, I really hope you're learning a lot. This has been a pretty fun game to make. I really enjoyed making this course, so I hope you're enjoying it as well. I hope you're also taking the time to go through all the frequently asked questions and all the quizzes in the companion project. Make sure you go through all of those after every single lecture in order to make sure you are actually gaining the knowledge. If you just blindly copy-paste code, if you just blindly watch lectures, you won't really learn much. You've got to actually apply, you've got to test out your knowledge to make sure it actually solidifies inside your brain. And of course, if you get stuck at any point, remember how you can always download the project files for any lecture in the course. You can download those and either compare them directly with your own project files, or really just use those as a base and continue from there. Alternatively, of course, if you have any kind of specific question, or if you're just stuck on something really important, or if you just need a deeper explanation on something, if so, feel free to post in the comments and I'll do my best to help. Alright, so let's keep going. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create a landing pad and calculate a nice score using all the elements in our landing equation. Okay, so we have our lander, we can move around in any direction, and we can try to land, and we can identify if that landing was successful or was a crash. But we really shouldn't be able to land on just any rough terrain, so let's implement a proper landing pad. Let's begin by making our object, and again, let's keep things nice and organized, so let's separate the logic from the visuals. So first of all, on the hierarchy, let's create an empty game object, call it the landing pad. Let's reset the transform, put it on 0, 0, 0, okay. Then inside this one, let's right click on top of that one, create a new 2D sprite. Let's use any of these, doesn't really matter. Let's call this the sprite. And then for the sprite itself, let's use, yep, over here, the landing pad. Okay, great, so just like this. Let's put it roughly on top of the terrain there, so let's push it down there kind of like this. And I also want this one to show up on top of the terrain, so for the sprite, let's put it on +5, kind of like that. So with 5, that means it's going to be in front of the terrain, but behind the lander. Okay, great. Also, there's one very important thing with how this sprite is set up. So on the sprite renderer, over here on the draw mode, it's set as simple. And if it is normal and we stretch the sprite, let's say we want a bigger landing sprite, so kind of like this. If so, then it becomes very weird. It's all very stretchy. We don't want this. This looks very odd. So instead, let's revert back, put the scale back to 111, and set over here, instead of simple, let's go with sliced. Simple like this, let's put the scale back in 111, and now if we stretch, and if there you go, look at that. Basically now the edges don't get deformed, so the edges, those are always perfectly straight. The only thing that gets stretched is right down the middle, which is actually perfect. Now the reason why this is happening is what is known as 9 slices, meaning this sprite itself, this one is split into 9 different slices. So that's due to how I set up this sprite. We can see it over here on the project files. Let's select over there the landing pad. And yep, here we do see the import settings. And let's open up the sprite editor over here. And okay, so here it is. And you can see these nice little green lines. These are the 9 slices. By the way, these usually start from the sides. So you can see the little dots. For example, I did not touch the vertical ones, but you can click and drag, and yep, drag that one. But in this case, we just want to stretch horizontally, so let's leave it like this. And again, the whole point is basically these sides over here, these stay fixed, and only the center, only that one gets stretched. Now importantly is, if you do this, if you move, make sure you move the green box and not the blue box. The blue box will actually basically cut out the sprite. So if we do it like this, then this part of the sprite won't be visible. So in this case, we want the blue box to be on the outside in order to see the entire sprite. And we want the green one, we want this one to be roughly down the middle. That way the middle part gets stretched and the outside does not get stretched. And the reason why it's called 9 slices is just because this whole thing splits the sprite into 9 pieces. If I drag both the top and bottom, we can see. Yep, there you go, so we've got 9 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this way it's called 9 slices. It's a really great way of letting you have some dynamic shapes to your sprites where some parts get scaled and some parts do not. So in this case, this is absolutely perfect. So in this case, we can stretch out the middle in order to make some big or small landing pads, and the corners, those will still stay exactly the same. Okay, so yep, so like this, we don't need to save changes because everything was already pretty good. And yep, over here, so we have a pretty big landing pad. Let's use some proper size for this. So over here for the scale, let's put it the size of 9 and 3.2f and put it on position of 0, 0, 0. Okay, great. By the way, here's another tip. If you want to make the corner part, if you want to make that one bigger or smaller, then over here on the landing pad, you've got this setting, the pixels per unit. This is basically how many pixels in this texture equals 1 unit in the game. So if you want bigger or smaller corners, you can play with this. So if I put it on 300 and over here hit on apply, and if there you go, now the corners are much more thin. So yep, you can play around that if you're using your own custom sprites, but over here I'm going to use 150, just like this. Okay, that's great. So this is the landing pad, although it's still a little bit too big. So here we can actually see the benefit of separating the logics from the visual. We can leave the main parent, the landing pad, leave this one just as it is, so with the scale of 1, 1, 1. That's great, that way it won't mess up anything. And now we can freely scale over here just the child sprite. For example, let's put it on 0.6, 0.6, 0.6. And yep, right now I do think that's a great size. This is going to be considered our easy landing pad. Then we're going to have some smaller ones to be quite a bit more difficult. Okay, so that's great. We have our landing pad. Now in order to land on it, obviously we need a collider. So let's go on the parent. Let's add a box collider. And again, as always, make sure you use the 2D. Now let's edit the rough shape. And again, let's make it a bit forgiving. So let's make it a little bit smaller than the actual physical shape. So perhaps something like this should be good. Okay, so this is great. And now if we hit on play, we can see our lander starts falling down, and if there you go, it does land. Okay, so far so good. Now when we have the collision, of course, we just need to identify, did we land on this object, on the landing pad, or did we land on top of the terrain? And this is actually a very, very important question. So how exactly do you identify objects? If we hit it, then we know that we hit something, but we don't necessarily know what we hit. Technically over here inside the collision, we can access the collision, we can access the rigid body, we can access the game object that was involved in that collision. But how exactly do I identify, is this game object, is this the landing pad, or a terrain? Now there are multiple ways to identify objects, and there's actually 2 ways that a lot of people do, and those are 2 ways you should never ever do. Those are to identify based on either the name or the tag. So here, for example, we can name the landing pad exactly like this, landing pad. And then over here in the code, we can get the game object, get the name, and test if this one perfectly matches landing pad like this. So we put an if like this, and test for this. Now, technically this will work, but this is a terrible, terrible approach that you should never, ever, ever use. What we have here is a string comparison. And strings should only ever be used just for text. They should never, ever be used to identify types or specific objects. Strings are really just for text and nothing else. The reason for that is because strings are very brittle. So this code right here will work. So we can do a debug.log to say something, landing pad. So if we test like this, we fall down, and yep, it hit the landing pad. However, now let's say I accidentally made this a capitalized, now we test. And now as it falls down, and nope, it no longer identifies the landing pad because strings are case sensitive. Or there's even a sneaky issue that has happened to me before. So let's say like this, landing pad exactly the same. But if we test, and it falls down, and nope, it does not identify the landing pad. So that seems strange. The code over here says landing pad written exactly like that. And over here, the game object seems to be named exactly like that. Except in reality, it is not. If we check the game object name, over there, yep, look at that, we have an invisible space. And the name with space is completely different from the name without space. So it looks the same, it looks very similar, but in reality, it's 2 completely different things. This is how strings are very, very brittle. This is why strings make for very terrible identifiers. It is so easy to make a mistake, you can make so many mistakes. Just one character being off is enough to break everything. And over here, if you mistype something, if you write something like this, you get no errors. So you don't know that something is going to be wrong until you actually test, and then everything breaks. Finding and fixing bugs like this related to strings, those are extremely difficult. It's really hard to track down. So like I'm saying, you should never ever use strings for identifiers. That's a terrible thing that has many possible problems, so do not do it. And that is the same reason why I tell you not to use the Unity's tag system. If you go through a bunch of tutorials, you might see some people using this tag system. But again, this one is terrible for the exact same reason, because tags, those are really just strings. So all the problems that we just saw, those apply to tags as well. So because of that, you should never use strings. You should never use either the name or a tag in order to identify objects. And the reason why I'm being so clear about this, why I'm repeating this so much, is because a lot of tutorials, especially a lot of beginner tutorials, actually use tags and strings to identify objects. And I'm telling you right now, if you want to avoid going insane in the future, if you want to write good, high-quality, clean code, then never ever use strings to identify things. So since that option is terrible, what else can we do? What is the better option? And the answer is actually quite simple. We can use a class, basically use a script to identify objects. So let's see how we do this. So first of all, we need a script. So let's go into our scripts folder and construct a brand new model behavior script. Call this the landing pad. Yep, just like this. Let's wait for it to compile. and we're going to attach it to our object just like that. Okay, let's open the script. And now here, we don't actually need any code, so we can literally just make it a completely empty script, literally nothing inside of it. We just have a class with a specific name that extends mono behavior. That's it. And over here on the landing code, instead of checking for the name, which again, uses strings, this is terrible. Instead we can basically just check if this game object has that component. And if so, then we know it's of that type. So over here we can do try get component of type landing pad. So out landing pad. And yep, just like this. By the way, if you don't know this syntax, the out parameter, I have a lecture on it in my C# course. This is a really great parameter to get outputs, but it's also a more advanced thing, so you don't necessarily need to know about it at this point if you are a beginner. Here, just know you need to add the out keyword in order for try get component to work. Okay, so basically this function over here, this one will return true if this object has this component, the component of this type. So this really is the correct way to identify types of objects. This way it does not use strings at all. Over here, if I mistype this, if I write landing pad like this, nope, there's an error. So we have a compiler error, so we know exactly at compile time that something is wrong. So we have to write it properly in order for the code to compile. And it also does not matter what name we give the game object. It doesn't matter if it has a tag assigned or not. As long as it has this component attached, then it will be identified as being this type. So yep, with this we can identify the landing pad. Or actually specifically over here we want to identify if we are not landing on a landing pad. So let's check if it does not have that. If it does not, then we have basically crashed on the terrain. Either terrain or something else. So basically we only want to land on the landing pad. So we can do it like this in yep. So okay, let's save and do a quick test and make sure the object actually has the landing pad script. Okay, so let's test. And first let's try landing just on the landing pad. And if there you go, it worked, correct. And now let's try landing really softly, but over here on the terrain. So as I go nice and slow, and if there you go, crashed on the terrain. All right, awesome. So we are correctly identifying where exactly do we land. So now here we already have all of our checks. So first we check, are we landing on the landing pad or not? If not, then we have crashed. Then we check the velocity. Are we landing way too fast? If so, then land too hard. Let's crash. And finally, testing the angle. Are we landing on too steep of an angle? If so, crash. If not, then down here we have a successful landing. So really all that's left is just calculating some score. And when it comes to this, it's very much up to you as a game designer to come up with some math. Anything can work. Score is really just a number. So it's up to you to have some fun with some math. So here let's see some calculation that I made. Let's define a float for a landing angle score. And we're going to take the dot vector that we used. And remember how this one basically the closest it is to 1, the more straight we are. So let's do -1f, meaning that if we land on, let's say 0.95, which is pretty upright, this will give us -0.05. And if we land at say 0.99, then we've got -0.01. So let's first of all make this number a positive value. So mathf.abs in order to make the absolute. And we're basically going to define a maximum score. So float max score amount landing angle. Let's define it as 100. So we start off from this mass, and then we count down by how far along we are from a perfect angle landing. And then just multiply that by something. Let's define a score dot vector multiplier, something like 10f. So multiply it by that, and then by the max score amount landing angle. So basically we start off with this amount. We start off with a score of 100. And then if we have a perfect landing, we reduce basically 0 to 100, so we get the max score. But if not, if we get, let's say, 0.95, so we are 5% off. If so, then this will return 0.05, then 0.05 times 10f times the 100. It's basically going to cut down a little bit of our score. Then let's define a float for the landing speed score. So let's define the maximum landing speed. So the max landing speed is going to be the soft landing velocity magnitude. This is the maximum minus the current one. So let's define a float for the relative velocity magnitude. And basically going to use this. So let's just refactor this code kind of like this. And then down here we count down by that one. Just so we can see again how far along are we from the perfect soft landing. So we count down and then just multiply it by some kind of score multiplier. So max score amount for the landing speed, let's say 100, and then just multiply it by that one. Okay, great. Let's do this. Let's do a debug.log in order to see what these values look like. So the landing angle, let's print that one, and the landing speed, let's print that one. And actually over here I mistyped. So let's use the Visual Studio shortcut, Control-RR, just to rename this quickly and put the S on capitalized. And if there you go, it modified both of them. Okay, great. So let's test and see what these numbers give us. Okay, here we are. Let's do a very soft landing, perfectly upright. And okay, look at that. So the landing angle score gave us 100 and the landing speed score gave us 190. Okay, now let's try to go fast landing, but still enough to be a successful landing. So fast, but a little bit. Okay, that was actually slower. That was actually softer. So let's do a little bit like this. And okay, that was quite a bit fast, quite a bit more of a rough landing, and we got just 75. Okay, makes sense. Now let's try and land on a rough angle, and if there you go, instead of 100, we got 84. So basically, the more upright we are, the more we get between, let's say, 100 and 200 score. And if it's a rough landing, we get something between like 84 and 92. Again, like I said, score is really just numbers, so it's up to you. If you want to do different math from this, then go ahead, fine. As long as you take into account the actual values that we used, as long as you do that, then you can easily come up with whatever score calculation you want. All right, awesome. So here we have created the landing pad, and we also calculated some nice score. So we can go, we can land, get a great score depending on how often we land. So that's great, it's all working awesome. Next thing we want is to have multiple landing pads of different sizes that each of them have different score multipliers. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to add a nice score multiplier to each landing pad of different sizes. Okay, so right now the landing pad works, I can land on it, and yep, it works. The score calculation is also working, we're calculating it. Now let's just make multiple landing pads, each with different sizes and different score multipliers. So for that, let's first define the multiplier on the landing pad itself. So over here on the landing pad script, let's define a simple field. But again, as always, let's make it private to keep our code nice and clean. Define an int for some kind of score multiplier, just like this. However, we also want to expose this field in the editor. So we need to do it just like I mentioned in the dedicated video on this topic. Definitely go watch that video if you haven't seen it yet. This is a very, very important topic. So over here, let's keep it private to keep it safe. And then in order to show it in the editor, let's just add the serialized field attribute. So this way, this field is safe from any other class. But here in the editor, if we select it, if there you go, the field is exposed over here. Okay, great. So on this one, since this one is going to be the very big landing pad, let's give it 1x, nice score multiplier, okay? And now let's make another one that is smaller. So for making another one, basically we have two options. We can just simply duplicate this, move it somewhere and make it smaller. That's one option. But usually if you have an object of one type and you want to duplicate it, then before you duplicate just a normal empty game object, instead of doing that, you should really just be working with prefabs. And in this case, since we're going to be placing multiple landing pads of multiple different sizes, then it makes more sense to both have this one as a prefab, and secondly, make different prefab variants for each of the various sizes. Like the name implies, a prefab variant is a variant of some base prefab. So first of all, let's make this one into a prefab. We already have the prefab folder, let's just drag it on there. Yeah, there you go, that's a landing pad, great. And by the way, in case you don't know, a prefab is basically a prefabricated object. To turn this into a prefab, we just drag it over there onto the prefab folder, and over there we can see that it is in blue. Blue means prefab, whereas all these other ones in black, they mean those are just normal game objects. A prefab is just something, like I said, you can prefabricate it, you can instantiate it. We can easily place multiple of these all over the world, so I can drag another one, put it there, I can drag another one, put it there, and if there you go, place multiple. And of course, another important thing about prefabs is how if you make a change inside the prefab itself, it will apply to all those instances of that prefab. So if I go inside this landing pad, so just double click on it, yeah, there you go, now working inside the prefab. Let's, for example, go on the sprite, just for testing, just see, let's put it in red. And now as we exit, let's save the changes. And if there you go, now all of them are in red. So yep, this is why if you want to make an object and you want to duplicate it multiple times, instead of just duplicating an empty object, instead of that, make it a prefab, so that if you want to make changes to every single instance of that object, you can just go inside the prefab, modify it, and it will apply those changes to every single object. Okay, so let's revert back, save it just like this. So with this, we have our prefab. Let's just delete these two. And now, like I said, we can create prefab variants. So over here on the project files, let's right click on the landing pad itself. Let's go into create. And over here, we have a prefab variant. So if there it is, let's name this one the landing pad x5. So this one's going to be a 5x multiplier. Let's drag it onto our scene. And now let's go inside the prefab. So we can either double click over here or select this one in the scene. And over there in the inspector, we do see an open button. And if there you go, now we are working inside the prefab. But again, importantly, right now we are working inside the variant prefab. We're not inside the original prefab. So any changes we make to this one will be applied to this one, to the variant itself, and not the actual original prefab. For this one, like I said, we want to make it quite a bit smaller. So for the scale, instead of 0.6, let's put it like 0.4 on all of them, 0.4 on all of them. And then for the width and height, make it also prefab. Let's say 4.5 and 2, something like this. So yep, that is definitely tiny. That is going to be a tough landing. And then on the landing pad itself, of course, let's also modify the box slider. We don't want it to be that big, so let's make it quite a bit smaller, like this, like this. Okay, this is it. And now here in the script, let's just put a 5x score multiplier. Okay, great, so here we have our nice variant. We can exit back into scene, let's save the prefab, and there it is. We have our nice prefab variant, just place it right there on the terrain. So up here we have a nice big landing pad. This one's very big, it's very easy, meaning this one's going to give us just a little bit of score, whereas that one is quite a bit more tough, so that one is going to give us quite a bit more score. Now let's actually apply this multiplier over here. So here in the Lander code, we already did this math in order to calculate both types of score. Now using this, we can just get the final score, and then we can multiply it by the multiplier. So let's calculate an int for the score, and first of all grab the landing angle score plus the landing speed score, and then multiply it by the multiplier. So let's put this inside parentheses, and now for the multiplier, here let's get it. But of course, we were smart, we did the right thing, and we made this one as a private field, meaning over here we cannot directly access it, so we actually already have a reference to the landing pad, there it is. So we can access that one, dot, and if we try to access the score multiplier exactly like this, if we do this, yep, we have an error. It is inaccessible due to its protection level. This is intentional. This is exactly what we wanted. We don't want other classes to have direct access to this field. We do want it to be private. We do want to be limited as much as possible. That is because we don't want to expose read and write access to every other class. In this case, we just want other classes, like the Lander class, to be able to read this field, but it should not be able to write it. So over here, let's keep it like this, private, so we cannot directly access it. And I will really just make a function to expose this field. So a public, we're going to return an int, call it get score multiplier, and over here just return this score multiplier. Yep, that's it, super simple. So now over here in the Lander script, instead of this, get the score multiplier like that. And yep, now this works, and since I'm defining an int for the final score, let's just do mathf.round to int to round the final value and make it an int. Alright, awesome, so yep, just like this works, we can access that function, and that function will give us what this field says. But again, the field still stays nice and safe, so this one is still safe from writing. No other class in the entire game's codebase can modify it, but any class can read it through this function. This is exactly the kind of level of access that we want. Again, really remember the golden rule. Just try to minimize access as much as possible. So in this case, minimize writing and only expose reading when absolutely necessary. Okay, so now we have the score. Let's just do a debug.log on the final score. Just print out the score like this. Okay, let's test. Okay, so here we are. Let's try landing on this one over here and let's check the console. Okay, we got a score of 246. All right, that makes sense. Now let's try to land on that much tougher one. So let's go there and try to land perfectly like this. And if there you go, we've got a successful landing. And yep, this one has a 5x score multiplier. So instead of 250 score, we got 1,500. All right, awesome. So yep, over here, everything is working nicely. Let's just add one tiny thing. Let's add a visual indicator for the multiplier. We want the player to be able to tell the difficulty. This is actually going to be pretty simple to do. Let's just go inside the prefab. But importantly, let's go inside the base prefab because we want to apply these changes to all variants, not just one specific landing pad. So let's go inside of this one. And over here, let's just create a new text object. So right click, going to create into 3D object, make a new text object. And the reason why it's 3D is just because it's in the 3D, but this is really just normal 2D text. So 3D object, text. And since this is the first time that we're using TextMesh Pro, this window pops up. So let's go ahead and import the TextMesh Pro Essentials. This is pretty fast, so let's just do it. Okay, great. So now we can already see all of our text. And here we just want to showcase the score multiplier. So in this case, just x1. And let's put it centered. So actually over here for the width and height, put it on 0, 0. Then down on this, let's put it in bold just so it's a little bit more thick. Then for the alignment, put it centered, put it down the middle. And importantly over here on wrapping, let's make it no wrap. And if there you go like this, let's just scale it down a little bit. So on the font, let's decrease it something like this. So maybe something like 6 and put it in there. Make sure it's on an X of 0. Okay, great. And let's also add a background, just make it a little bit easier to read. So let's add a 2D object, a sprite. Let's add a circle. And on this circle, let's make it black. Let's put it over there. And let's make sure to put it behind the text. So for this one, let's keep it on default layer on -10. And then the text, this one can say on the default 0, which by the way, this one is over here under extra settings. Yep, we've got the sorting layer, ordering layers, so you can also order over here the text elements. Okay, so this is great. So let's exit, go out, save, and if there you go, we do see our multipliers. Now, of course, we have to update with the correct text, and for that, we actually have two options. So one easy option is to basically define it over here in the editor. So we can go inside the landing pad, the 5x, and over here literally just modify the text. Just go inside this one and put it x5, and yep, that would work just fine. Or we can actually do it through code. In this case, since it's actually static, it's never going to move. It's never going to change. So over here, putting x5 directly on the prefab, that would work fine. But in most cases, you actually have some sort of dynamic element that you want to update. So even though in this case it's not strictly necessary, let's do it the dynamic way, just so you'll learn about that. And also this is another great time to once again learn about some more good practices, learn about how we can keep separating logic from visuals. So let's keep this one the same thing, x1. Okay, we're going to leave it over here in the editor, so both of them say x1. All right. Now let's keep doing what I said. Let's keep separating the logic from the visual. So let's make another script, a new mode of behavior. Call it the landing pad visual. Yep, there it is, just like this. And now, despite the fact that this is a visual script, despite the fact, let's actually select the prefab itself, so the main prefab, again, not the variant, and let's attach it over here onto the parent object. Now again, like I said, we're separating logic from visuals, but here we are adding the script onto this one just because all the visuals are all child objects. So we are still separating the logic from the visuals, so all the visuals are over here as child objects. We're just adding this one over here. This one is basically the visual manager kind of script, so it makes sense to go on the pattern. But again, we are still going to keep things nice and separated. If we want, we could remove the script, delete all of the child objects, and the game would still work fine. Okay, so we have the script, let's open it. And over here, let's really just reference the text. Let's update it. So in order to update, first we need the reference. So once again, let's make a serialized field, private, of type TextMeshPro. Now importantly, it's this one, TextMeshPro, not TextMeshPro UGUI. This is a different one, don't make this mistake. So basically this one up here, this one is for World Text Mesh, which is what we're using. Whereas this one over here is for UI text. Since we are using World Text, let's make sure to use this one. Yep. And as soon as you do, add the using statement, so using TMPro. Okay, we have this for the score multiplier text mesh. Okay, we have this, let's save. And over here in the editor, first of all, let's make sure we are working inside the prefab, the base prefab. So let's go inside this one. And there you go, we have the field. So let's drag the reference to our child object. Okay, great. Now over here in the code, we really just need to get the landing pad in order to get the multiplier. And since both scripts are attached to the exact same object, it's really simple. Let's implement a private void awake. And the reason for implementing the awake is because this is a local reference. It is not an external reference. So that is why we use awake to initialize it. We're going to do get component of type landing pad. So we get the landing pad like this. And then just go onto the score multiplier text mesh, modify the text, put a little X, and then landing pad, let's get the score multiplier. Okay, yep, so just like this, let's save. And over here, let's exit, make sure to save our prefab, and let's test. And if there you go, right away it works. So this one says 1, whereas that one over there is much more difficult and says 5. All right, awesome. And again, this is another great exercise of keeping the logic and visual separated. The landing pad script, this one over here, this one still just handles the logic. This one has no concept of text field or anything like that. We could technically have copy-pasted this code and placed it directly in here, but doing so would be bad because again, we should separate the logic from the visuals. So we didn't do that. We did not place this code directly over here in order to keep things nice and clean. That way, this script over here, this one just handles the logic, and this other script, this one just handles the visual. It's usually much better to have multiple smaller scripts that each do one tiny specific thing, as opposed to having tons of massive scripts that do a ton of stuff. So yep, here we have our both landing pads. So we've got a small one and a big one that is quite a bit more challenging. I can go ahead, I can land on any of them, and yep, everything works quite nicely. Okay, great. So now let's keep working on this same concept, separating the logic from visuals. The next thing we're going to do is implement some nice thruster visuals. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to add some nice thruster visuals. Importantly is how, once again, we're going to do this properly, not the quick and dirty way. Okay, so we have our lander ship, that's nice. We can move it up, we can move down, left, right. Yep, everything works great. So yep, that's awesome. But visually it looks pretty bad. It really just moves, there's no visual feedback. Over here in the project files, we have some nice thruster particle systems. So let's add it to the lander to make it look a little bit more interesting. Let's go inside the lander game object. And on this one, let's drag and drop the thruster particle system. Make sure to drop it on the parent so it's a child. Yep, there it is. Now let's put it over there on the left side. So let's move it roughly over there. So let's say on minus 0.5, minus 1. Or maybe lift it up a little bit. So minus 0.9 like that. Okay, great. So this one is the left one. Let's duplicate one. Put this one on the x of 0 and one on the right. So on x of plus 0.5. Okay, yep, so we've got our 3 particle systems. So that's great. Let's just give them names. So that's the left thruster. That's the middle one. Like this, and this one is the right like that. Okay, great. And now if we hit on play just to see, and if there it is, a nice particle system on all of our thrusters. Okay, so that's great, except of course we don't want them to be playing non-stop. We only want them to play when we're actually using the inputs. So let's make sure to control these particle systems through code. And again, let's do it properly. Since thrusters are just a visual element, it does not impact any logic. So let's make a separate script to handle just that. Over here in our scripts, let's create a brand new one, a new model behavior script. Call this the lander visuals. Okay, let's wait for it to compile. And then we're going to do the same thing that we did on landing pad. So let's go on the parent game object, and on this one add the lander visuals. There it is. And now let's open. Okay, so here first of all, let's add references to our 3 particle systems. So make a serialized field, private. Then for the type, it's going to be of type particle system. For the left, thruster particle system. Then we've got another one for the middle and another one for the right. Okay, let's save. And here in the editor, let's drag those references. So we've got the left one right there, then the middle one right there, and the right one right there. Okay, great. So now for controlling this through code, we basically just want to either emit the particles or stop emitting. And the way we control that in the particle system is actually a little bit quirky. So let's test it just over here on a quick start, just to test, just to see how it works. Basically, we need to get the particle system. So let's say the left one. Then we need to get the emission module. So that's this one over here. And then we set this one to enable. It holds either true or false. Except this one, like I said, it's a little bit quirky. That's because this one over here only has a get, does not have a set, so we can't modify it. So we need to store this in a field of type particle system dot emission module. So that's the emission module for this one dot emission, and then we can do emission module dot enable equals false. Okay. So yep, this is how it works. This is how you either enable or disable a particle system. So if we test like this, we should be able to see the left one disabled. Let's see. And if there it is, we've got the middle and right, but the left one is disabled. Okay, great. So this is really what we want to use. Now the goal is to use this based on the inputs. So we have another very interesting question, which is how exactly do we do that? How do we have the lander script? How do we have this one basically tell the visual script to enable or disable the thrusters, while also, and this is the important part, while keeping the logic and visuals separated? So the goal is for the visuals over here, for this one to be completely decoupled from the logic script. This is actually a very important word in writing good clean code, decoupling, meaning we want the logic script to know absolutely nothing about the visual script. We want the game to work exactly the same, even if we were to delete all the visual parts from it. So that's the goal, meaning that over here on the lander, on this one, we should not have this one tell the visual script directly to enable the thrusters. We should not do that. That would basically defeat the point of keeping them separated, since we would be connecting them over here through code. So instead, the way that we're going to keep the logic script decoupled, but allow the visual script to know when things happen, the way we do that is through events. Events are absolutely awesome. It's one of my favorite C# features. I have a lecture all about events in my C# course. If you haven't seen it, then definitely go ahead and watch this. Seriously, events are definitely one of my favorite, one of the most useful C# features. So over here on the lander logic script, let's define an event. And the way we do it is, first of all, we make it public so that other classes can access the event. That's the intentional. So let's make public. Then we use the event keyword, and then the event type. And over here, technically, we can use any delegate type. Anything would work. Again, I also have a lecture on delegates in my C# course. So here, technically, we can use any delegate type. But normally, I like to stick with the C# standard, meaning over here, let's use just the normal event handler. So there it is, this one, which exists inside using system. And this delegate over here, the signature for it is it returns void, it takes in an object, and takes in an event args. So like I said, here for events, you can use any delegate you want. So you could, for example, use the more simple action. That would also work. But really just the C# standard for events to use event handler. And the object sender and the event args, that actually becomes quite useful in certain scenarios. So let's go ahead and use this one. Now for the name of the event, so this is going to be when something happens. So on this one, let's say on up force. So we're going to have this one when we have an upwards force, then when we have a right force and a left force. Okay, yep, so here we have defined our events. And now let's just fire those events. So on the up force, we're going to fire it over here when the up arrow key is pressed. So over here, we want to invoke that event. And the way we invoke events, the proper way is actually like this. So we have the event name on up force, then we use a little question mark. This is the null conditional operator. Basically, it only continues executing this line of code if what's on the left side, so the event, if that one is not null. I also have a lecture on the null conditional operator over here in my C# course. So we use that one, and then we call .invoke, and then really just invoke the event. So for the object, usually you want to send this, so that is the current object that is firing off this event. In this case, we don't have any arguments with this event, so let's just pass in the constant event args.empty. So that's it. This is the proper way to fire an event. Let's fire this one, then same thing for the other one. So we've got the left force kind of like this, and over here we've got the right force like this. Okay, yep, so we've got our 3 events. We've defined them, we've invoked them. So now over here on the lander visual, now here we can listen to it. we're going to need to access the lender, and since the lender is a local reference because it's attached on the same game object, let's do a private void awake. And then awake, let's do get component of type lender. Let's go ahead and cache this. So lender equals this, and then we have the lender equals our get component lender. Okay, and then let's go on the lender and attach a listener to the on up force. So just do plus equal. So this is how we attach a listener to this event. Then we can use tab in order to automatically generate that function. There it is, write this. So lender on up force like that, and just automatically creates this function. Again, if you're feeling confused right now, I highly recommend you go watch my events lecture in my C# course. Events sound quite complex at first, but once you understand how it works, it actually becomes pretty straightforward and becomes a really awesome tool in your toolbox. So over here, we're attaching this listener function onto this event, meaning that when this event is invoked, it is going to call this function and run this line of code. And over here, when we have the upwards force, let's enable all of our particle systems. So let's actually make a helper function to do this, and we no longer need the start just for testing. So let's do another one, set enable the thruster particle system, takes in a particle system for the particle system, and then a boolean if we want to enable it or not. Then we go inside this particle system, grab the emission, and set that one to enable. Okay, yep, so like this. So on this one, let's enable both the up particle system, so that's the left, then the middle, and the right. So we're going to enable all of these, so all of these set to true, so that one, and that one. And by default, let's also start with them disabled. So over here, let's set basically all of these, set them all to false on start, and then we set them to true. Like this, and this. Okay, so yep, so this is the up force. Let's just do the other ones. So we've got the on left force. Let's make a function for that one. And the on right force. Let's also make another function for that one. And then let's see all the things that we do on all of these. So if we are going right, then we want to enable the left one in order to make the spaceship go right. Then these other are staying false. And if we want to go left, then we just enable the right one, and both of these become false. Okay, yep, just like this, except we have just one issue. So over here we are enabling these thrusters, but we're never actually disabling it. So if we press on up, then it's going to enable these, makes sense. But if we then let go of the button, then these are going to stay enabled. We don't want that. So over here on the lender, let's actually make one more event. Let's call it on before force. So before we fire any forces. And over here on the fixed update, before that, let's just invoke this event args.empty. Yep, so we have this event. And then over here, let's just listen to that one. So the on before force, attach a listener to that one. And on this one, really just set them all into false. So basically at the beginning of every single frame, so over here, all the thrusters become false. And then depending on which keys we are pressing, it's going to become true. Okay, great, so like this should be working. Let's go ahead, save everything, wait for it to compile, and let's test. Here we are, and yep, start off disable. As soon as I press, it becomes enabled, gross like that. Okay, there you go, all three are enabled. Now if I go right, there you go, just place that one. Now if I go left, yep, there you go, just place that one. All right, awesome. Okay, so the only thing is if we are both moving right and upwards, we should be able to also fire the middle one. So up here on the lender visuals, actually on the right force on this one, just set it to true, and this one also just set that one to true. So like this, we should be able to combine multiple of these. So here we are, going up, going right, and if there you go. So like this, I think it looks a little bit better as opposed to just having one, even though we're firing quite a lot of force. All right, awesome. So the visual is indeed working quite nicely. Everything here is working nice and perfect. And again, importantly, we kept our project nice and clean. So the logic system over here, this one is completely decoupled from the visuals. This script over here does not know, does not care whether some visuals exist or not. All this script cares about is just firing some events. That is it. It does not know and does not care if anyone is listening to these events. So technically over here, the visual script, we could completely delete the script and everything would still work fine. Because again, the lender does not care who is listening to these events. This script just fires events, that's it. So this once again is the very important concept of separating your logic from the visuals. Decoupling your scripts from one another is always a very good thing that you should pretty much try to do all the time. Now here, technically the lender visuals, this one is technically coupled to the lender. So if we were to remove the lender, then naturally this script would break. But that's fine. You can't keep everything decoupled all the time. So it makes sense that the visuals require the underlying logic to work. And it also makes sense that the underlying logic does not require visuals to work. Always keep that in mind. Always separate the logic from the visuals and make sure the logic is not dependent on the visuals. So here we are. We can fly around everywhere and we have some nice thrusters and our game is starting to look quite nice. All right, awesome. So yep, like I said, with this, the game is already starting to take shape. Next, let's add another interesting mechanic. Let's add a nice fuel amount. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to add a fuel mechanic. We want a fuel that has a limited amount. If it runs out, we should fall down, and we can also pick up some more. Alright, so far we have our lander that we can fly around quite nicely, and right now we can fly around for pretty much infinity. I can really just keep going, but to make our game a little bit more challenging, let's add a nice limit. Now this will actually be pretty easy, and handling the pickup will also be quite interesting. So let's begin by going here on the lander script. And on this one, let's just add a simple field to keep track of our fuel amount. So let's make it private, keep things nice and clean. Let's define it as a float and call it the fuel amount. Okay, so we have this, and let's start off with actually something, let's say like 10 units. The units are pretty much arbitrary, it all depends on how much we're going to count it down by. So then let's do that. So over here on our update, whenever we use our thrusters, so either going up, left, or right, over here let's just consume some fuel. So let's just bring down the fuel amount by some kind of amount. And as always, let's not use magic numbers, so define a float for the consumption amount, or rather the fuel consumption amount. And let's define something like 1F. Again, like I said, we can play around with all these values and drop it down by that one. However, again, always remember, since we are consuming this on an update, even though technically right now we are on fixed update, but as usual, if you're working on update, you should make sure to include time.on-time in order to make the logic frame rate independent. Otherwise, we would have different fuel consumptions for different players playing on different frame rates. So over here, count down by that, multiplied by time.on-time. Which, since this one is set to 1F, that means we're going to consume 1 unit of fuel per second, so per second that we're using. And over here, we default it to 10, so we can basically use the thrusters non-stop for 10 seconds, and then we run out of fuel. So yep, we do this, and let's do this on all the others as well. But of course, let's not just copy paste a whole bunch of code. So let's make a simple helper function. Private void, just consume fuel. And we could receive the amount over here as a parameter, but since we're going to consume always the same amount, let's really just use this. Just copy that and just run like this. And then up here, really just consume fuel if we're going up, if we're going left, or if we're going right. Now, technically, if you wanted, you could add the parameter for defining the fuel amount to consume. Then over here, you would use that one. That way, you could add, for example, consume more fuel when going up as opposed to going left or right. But still, I think like this, it's pretty simple, it's good enough. This way, the fuel is pretty nice and constant. Although here, we also have an interesting game design question. So basically, like this, the way that we have set it up here. This way, basically, the fuel amount will be consumed double if you are both moving up and left or right. So it will consume once here, and then also another one here or here. So perhaps this is the design that you want. Like I said, game design questions never really have right or wrong answers. Anything can work. So if you want, you can use this. Or perhaps we can really just consume fuel if any of these inputs are enabled. So for example, here we can check and basically check for all of these button presses. So we check if the up arrow key is pressed, or the left arrow key, or the right arrow key. And if any of these are pressed, if so, then we are pressing any input. So we can consume fuel and then remove it from these. And yep, like now we don't have that double pressing, that double consumption that we had previously. If we are moving just up or up and left or right, either one of those, we just consume 1 unit of fuel. Okay, so yep, so with this is all we need to count down the fuel amount. Now all that's left is actually using the fuel amount field, using this one in our logic, which is going to be quite simple. So over here, before we check for inputs, let's just check, do we have any fuel at all? So check if the fuel amount, check if it's under 0, so if we have 0 fuel. If so, then we have no fuel, and here we can just do an early return. So if we have no fuel, then we return here and we don't do any of this logic. Alright, yep, so just like this, that should do it. Over here, let's just do a log just to print it out, the fuel amount. Yep, let's do it like this and let's test. Okay, here we are, and yep, we do start off with 10 units of fuel, so yep, that makes sense. And if I start moving up, and there it goes, starts coming down, and if I hold down, yep, it is going down pretty much 1 per second. So yep, I can use quite a bit, and if I go left or right, yep, I'm also consuming quite a bit of fuel. And if we go down to 0, so just a little bit more, and 0, and there you go. Now I cannot use the inputs. Nope, nothing works, and the ship really just crashes down. All right, awesome. That's exactly what we want. By the way, obviously, in the final game, we're not going to have the fuel over here in the console. We're going to have a proper UI. We're going to build that in a fuel lecture, so don't worry about that. Here, we just want to see that the logic is working, and right now, yep, it is indeed working. Now let's implement the other side of this mechanic, picking up more fuel. Adding pickups is always a fun thing. It's actually pretty easy to do. So first, let's make the object. In the hierarchy, let's create, as always, keep things nice and organized. So an empty game object, call it the fuel pickup, like this. Yep, let's reset the transform, see where it is. And yep, there it is, right there around that center. Now inside, let's make a sprite. So let's create a new to the object, the sprite, any sprite, name this the sprite. And then in the project, in our textures, here we have, there you go, the fuel icon. So yep, let's use this one. This way we have an object with our nice visual, so that's great. But let's think about what exactly is a pickup. It really is something where the player will touch and it will be consumed or something. So in order to be touched, it needs to have a collider. So let's add a collider. And for the shape, we can either use a box collider or a circle collider. Any one of those would work fine. Let's go with circle just to be a little bit different. So like this, we've got a circle collider. However, if we just do this, if we test, so there's a fuel, I'm going to try to pick it up. And as soon as I go, and yep, there you go. Look at that. I basically crash onto the fuel. That's because the fuel is pretty much a solid object. So that is not what we want. For pickups, we don't want their colliders to be solid. So this is where this setting over here comes in, the is trigger. Basically, if we make this collider a trigger, then it is no longer a solid object. So like this, if we test, and if I go towards the fuel, and if I go to it, yep, there you go, it still has a collider, but since it's marked as a trigger, it no longer counts as a solid object. So I can just easily go through it. So yep, that's exactly what we want. Now over here on our later script, on this one, we really just need to identify that we hit that collider. So let's go ahead and implement another function. So we previously implemented on collision enter 2D. So this is when two solid objects collide, so that's great. However, now we have a trigger. So let's implement the other function. So let's go here, private void, and on, and let's write trigger. And if there you go, we've got all kinds of trigger functions. So we've got enter, exit, say, and again, the same thing. We've got both 3D and 2D versions. Now in this case, we want to trigger it just once when we touch the fuel pickup. So let's go ahead with this one on trigger enter 2D. Again, don't mistake the 2D and 3D versions. So this one will run once, just once when we enter a trigger collider. And now again, here we want to do very much the same thing that we did previously. So over here for identifying did we crash on the terrain or hit the landing pad. Down here, we actually want to do the same thing. And first of all, let's rename this. I have no idea why Unity by default calls this collision when it's actually of type collider 2D. I'm not sure, but let's rename this to collider 2D. So over here for identifying the type, if the collider 2D, let's grab the game object, try to get a component, and then a component of some type. Again, we very much want to use this method. We want to use the proper method and not the string method. So let's create a proper type to identify that object. So in order for the code to compile, let's just comment out this line and save it. Then over here in Unity, let's go ahead on the scripts and create a new model behavior script. Call it the fuel pickup. Yep, like this. Wait for it to compile, and on the fuel pickup itself, let's attach the script. And then back here on the lander, we can try to get a component of type fuel pickup, or actually the syntax like this, out fuel pickup, just like this. And if it is a fuel pickup, then let's add some fuel. So go on the fuel amount and plus equals by some kind of fuel amount added. So float add fuel amount, let's say 10F. So let's add it by that much. And we really just add it like that. And if just like this should be working, if we touch it, the fuel should go up by 10. So let's save it and test. Okay, here we are. And let's actually look over there on the console. Okay, we've got a bunch of fuel. We're almost running out. Now let's go there, touch that one. And if there you go, now I've got 15 fuel. And yep, so that seems to work quite nicely. Okay, great. The only thing missing is obviously consuming the pickup. Right now I can go over, touch it again. There you go. Now I've got 20. Then I can touch it again. Now I've got 27. And yep, there you go. Obviously we don't want this. We want to actually consume the pickup. So let's do that. And for that, technically you could do it over here. So you could call destroy and destroy over here this collider2d.game object. Technically you could do this. However, personally, I don't like this approach. Again, very much a clean code principle. Objects should ideally handle themselves. So the responsibility for destroying this pickup should not be over here as part of the lander. The pickup itself should know how to destroy itself, just in case it needs to do something other than just destroying the game object. So let's go inside the fuel pickup script. And on this one, first of all, we can get rid of the defaults. And over here, let's just make a simple function, make it public so we can call it from the other side. Void destroy self. That's just the name that I like to give. And then over here, we just destroy this game object. Yep, just like this. And now back on this one, we can go on the fuel pickup and just call destroy self like that. Okay, yep, so just like this, let's save. And finally, since everything should be working, we can now make this into a prefab so we can easily place a bunch of them. So let's make it a prefab and let's duplicate it, put one there and one there. And okay, so now let's test. Okay, so here we are and I'm using a bunch of fuel. Now as I touch that one, and if there you go, the fuel amount did increase. And if there you go, it increased by quite a bit. Let's actually try spending all the fuel. Try to see if I can get it down to 0. Okay, the fuel is almost out. I'm going to run out of fuel on top, and I'm out of fuel, and now I've got fuel, and I can move again. All right, awesome. So yep, here we have implemented a nice fuel mechanic, as well as also a really nice pickup mechanic. So that's great. And since we have pickups, let's actually build another pickup for some bonus score. Let's add some coins. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to create some coins that add some score when picked up. We're also going to learn how to keep track of our score, and doing this will require us making a separate script to keep track of some general game data, which means we're also going to learn about the very useful Singleton pattern. Okay, so we already implemented a nice fuel pickup in the previous lecture. Now let's make another pickup, a nice coin to give some score. So first let's build it, and let's build it just like the fuel pickup. So let's create an empty game object for the coin pickup. Then inside let's create another sprite, call this the sprite, and in the project files over here there's a nice coin sprite just like that. Okay, so that's great. Now for the functionality over here, let's add a circle highlighter, make it a trigger, make sure the shape is roughly like that, great. Then let's identify it, so let's make a coin pickup script, so a new MonoBehavior script for the coin pickup, like this. Let's wait for it to compile before we add it. So over here, let's add the script, then open it. Over here, let's implement the same destroy self function. So public void destroy self, where we are going to destroy this game object. Okay, yep, like this. And on the Blender script, over here on this one, let's go down. Same on trigger enter. Let's copy paste this code, except now look for the coin pickup. So we have this one like this. We call destroy, and it's over here that we're going to add some score. But before, let's just test to make sure this is working, so let's save our scripts. Okay, so here we are. Let's pick up some fuel, and it works. Let's pick up some coins, and yep, also works. Okay, great. So here you can see how we just implement a really nice separate pickup in just a few seconds. So if you set up things correctly and you use some nice logic, you can very easily expand upon this in many ways. So we have the pickup, but now here's the very important question is how exactly do we handle score? Or more specifically, where are we going to store that data? Now in this game, since we actually have just a single player object, just in Blender, technically we could store the score right here directly on the Blender script. That could work and might not necessarily be a terrible idea. But let's say we also want to eventually add more things like a timer and so on. If we add more and more things over here on the Blender script, it becomes quite a bit more tricky. So let's make it proper. Let's make a proper script to handle that sort of general game data. So back in Unity, let's create a brand new script. Call this just the general game manager. So game manager, just a general name. You don't have to name it this, but game manager is a name that I like for general game purposes. So let's go ahead, create a new one, call it the game manager, just an empty game object, reset transform, attach a script, and open. Okay, so now here, very simply, let's store our nice score field. And again, let's keep writing some nice, good, clean code. So let's keep it private, so our code is nice and safe. Let's define an int for some kind of score, and then some kind of function that we can expose to add some score. So public void add score, then an int for the add score amount, and really just score plus equals the add score amount. Okay, great. So all we have to do is call this function. However, here we have a very, very important question. Like I mentioned, when writing good clean code, you want to keep your classes as decoupled as possible. You want to minimize access and connections as much as possible. But of course, you can't minimize everything. At some point, some scripts need to talk to other scripts. So here in this case, the game manager has a score, but the Blender itself, the Blender script, so this is the one over here that tests for hitting the pickups. So over here, we basically have two options. We can have the Blender over here tell the game manager to increase the score, or we can have the game manager listen to some kind of event from the Blender when it picks up a coin and then adds the score itself. Both those options are valid, and in this particular case, I would say there's really no right or wrong answer. In this particular case, for this particular game, either one of those options works fine. The game manager is a pretty central script, so it makes sense that other scripts would be tightly coupled with it. And at the same time, the Blender is also crucial to this game, so having the Blender tightly coupled to the game manager, that one also can make sense. So the general clean code guideline is you should always avoid unnecessary coupling, but necessary coupling is perfectly fine. So we can either have the Blender tell the game manager to add some score, or we can have the Blender fire some event, and the game manager listens to that event from the Blender. Both those work. So here, let's actually take the events approach. Let's define events on Blender, and then the game manager just listens to them. So over here, let's define that. So let's make just another event. This one, let's say on coin pickup, so like this. And then down here, when we have the pickup, let's just invoke this event. So the usual, this event args.empty. Yep, that's it. And over here on the game manager, now we can listen to that event. However, again, here we have another very important, very big question, which is how the game manager, this one needs a reference to the Blender in order to attach the listener. First, let's do it the simple way, and then we're going to see the more interesting way. So the simple way is let's just add, as usual, a serialized field, make it private of type Blender for the Blender reference. So we have this one, let's save it. And here in the editor, we've got the game manager, and we can just drag the reference to the Blender. So just drag that one, great. And now here we can attach a listener to that event. And since the Blender is an external reference, for that, instead of awake, let's listen on start. So on start, go on the Blender, on coin pickup, attach a listener to this one. And when it happens, add some kind of score with some kind of amount like that. And then just for testing, let's just do a debug.log on the score. So let's actually do it over here on the add score. Okay, yep, so technically this should work, so let's test. And before we test, just because we have way too many logs over here on the Blender, Let's get rid of this log over here for the field amount. Let's remove that. Okay, let's test. Okay, here we are. Let's try to pick up that coin. And there we go, the coin is gone and we got 500 score. Okay, great. So yep, so this over here, this logic is all working perfectly. But now this is also the perfect time to learn about something super important and very useful. That is the Singleton pattern. This is a fascinating pattern. I also have a dedicated lecture on it in my C# course. This is one of the most useful design patterns. You absolutely need to know about this. The Singleton pattern is really just an easy way to access a global reference. So this one is perfect when you have exactly one of something. Which in this case, we just have a single lender object, so it's perfect here. The Singleton pattern will enable us to access the lender reference from the game manager without having to have this field over here, without having to manually drag any references. So the way we implement that is let's go over here on the lender script, okay? And up here, let's define a field, or actually it's going to be a property. If you don't know the difference between fields and properties, I have a lecture on it in my C# course. Basically, properties are kind of like fields that have get and set functions. That's generally what they are. So over here, let's define a property. And first, we want to make it public, since we do want to access this reference from everywhere. And then here's a very, very important part for the Singleton pattern. Let's make it static. Static means this belongs to the class itself and not any instance of that class. So the property that we're going to define here belongs to the lender class itself, not an individual instance. I also have a lecture on static in my C# course. And then for the type, this is going to be of type lender. And then for the name, usually the convention is to name it instance, also with a capital I. These are the naming rules for properties. I also have a lecture on naming rules in my C# course. So yep, we've got an instance, this is a property, and because it's a property, that means we can do something fun. We can open and close the curly braces for the property, and over here we can define a get, just like this, meaning like this, without any accessor. This one is going to be public, so it's going to be this one, meaning any class is going to be able to get this instance, but then we can do something clever. We can make a private set just like this, meaning that only this class can set this property, but any class in our entire code base can get it. That is exactly as we intended, that is exactly what we want. We only want this class to set and anything else to be able to get. So yep, that's it. That's exactly the level of access that we want. And over here, let's go on awake. And on awake, let's set the instance equals this. So yep, that's really it. This is the Singleton pattern. It might look intimidating if you've never seen it before, but it really is quite simple. Like I said, I have dedicated lectures on pretty much all of this, on static, the Singleton pattern, and so on. So if you're a little bit confused, I recommend you go watch those lectures in my C# course and then come back here. Once you understand how the Singleton pattern works, then you will see how simple it is, and how it's simple and very powerful. So with this, we basically have a static reference that we can access from anywhere. For example, over here on the game manager, we no longer need this field for this lender. So instead, how we access that reference, we access the lender, and we type in the actual class name, lender, and then we can access our static instance, just like that. And then yep, here we have access to the instance, so we can just go on coin to pickup and listen to it. So yep, just like this. So we no longer need the field, we don't need to drag any references, we really just access the reference just like this, and everything works fine. So yep, let's go ahead, save everything, and let's test. So here we are, let's go pick up some score, and yep, there we go, 500 score, so everything worked nicely. Alright, awesome! So yep, we implemented the nice Singleton pattern, and we added some score. All that's left is also here, really, let's just add a score for a successful landing. So on the lander itself, let's make another event on landed, like this. And on this one, we actually also want to do something a little bit different. Like I said, the standard event handler, on this delegate type, you've got two parameters, so you've got an object and an event args. For simple events, like all of these, we really don't need any event args, we don't need any extra data. But if we do want to send some extra data with our event, if so, that's where custom event args come in. So over here for the onlanded, let's say we want to pass in the score for the landing, so the score that we calculate down here, we want to pass that in alongside the event. So for that, let's use some custom event args, and to make those actually very simple, let's just make a new class, and usually I like to define it right next to the event itself. So public class, usually the name is the name of the event, so onlanded, and then just add event args like this. And we're going to extend event args. Yep, so this is our class. And now inside this, here we can add whatever data we want. In this case, really just want to pass in the score, so just say public int for the score. So yep, we have this nice class for some extra data that we want. And over here, we can use that. So we can use event handler instead of using this default class. Instead of this, we can use the one that takes in generics, and generic is going to be our custom event args. Now this over here is a generic, and if you don't know about the generics, if not, then again, I also have a lecture on it in my C# course. Okay, so we have this event with our custom event args. Now really, let's just invoke it. So let's go down here to where we have a successful landing. Yep, there you go, we calculate the score, great. So let's go, let's call the invoke pretty much as usual. Then for the first parameter, that one is still going to be the object sender, so let's pass in this. And then we've got the custom event args. So let's do new of type onLand event args. So let's make this object, and then really just pass in the score equals this score. So the score on our onLand event args is going to be whatever score we calculate here. Okay, so yep, so that should do it. we should have this event being fired when we have a successful landing. So now we can go over here on the game manager, go again, lander instance. Let's go on the onLand event. Let's listen to this event, the lander on landed. And listen over here, let's call add score. And we can access the custom event args that we made. So that's this parameter over here, the E, and E.score, just added just like this. Okay, so yep, so that should do it. Let's save everything, let's test. Okay, so here we are, let's first pick up the coin. And if there you go, we've got an extra 500 score. And now if I go and I land down, and if there you go, successful landing, we got a score of 315, which was added onto the original 500, so we've got 815. All right, awesome. So yep, here we implemented a nice game manager to keep track of our score, and we also learned all about the Singleton pattern, so this was definitely a very good, very comprehensive lecture. Now, so far, we're seeing our data just over here on the console. It's about time we do a proper UI, so let's build that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to build a proper UI for our game. We're finally going to have the data shown in our actual UI itself as opposed to in the console. Okay, so we already have quite a lot of things working in our game. We've got the lander, we've got the pickups, we've got the landing, the speed, the fuel, all kinds of stuff. So that's all great, it's almost like a proper game already. But so far we have no UI, so let's build that. Let's begin by making a canvas. The canvas is basically how you set up the UI. So on the hierarchy, let's right click, construct, go into UI, make a brand new canvas. And yep, this one creates two objects, the canvas and the event system, so that's great. This is intentional. Basically the event system over here, this is what will capture clicks on all the various canvas elements. And over here, it should already be set up by default, so we don't need to touch this. Now, if you do have issues with not being able to click on UI elements and so on, if so, make sure the event system has not been deleted. If you delete this game object, then it won't capture clicks or interactions on the canvas. Also, the other important thing is what input system you're using. Are you using the input system or the legacy input manager? Depending on that, you need to use different modules over here. So if you do have those kinds of issues, make sure you've got the correct module over here. In this project, we're using the input system, so we've got the input system UI input module. Okay, makes sense. Like I said, by default, everything should work fine. So let's go ahead and set up our canvas correctly. This is actually very important. So first of all, for render mode, we do want to leave it on overlay. This means that the canvas is going to be rendered on top of the main camera. That's exactly what we want. The other option is basically if you want to render it with a specific camera, and world space if you want to render it on the world. But in this case, for the main UI, we want to have screen space overlay. Then for all these options, you can leave them all as defaults. The important one is over here on the scaler. Basically, this component will help scale our elements up or down depending on resolution. This is how Unity games can work on basically any resolution, any aspect ratio. So you can build your game once on PC in 1080p, but it will also work with someone working on some kind of 5:4 aspect ratio. The way Unity works with all those different ones is thanks to this component, the canvas scaler. Now here there are many valid ways to set this up. Let's go with the way that I personally prefer. So over here on the scale mode, you can keep it constant, which means objects will not actually get scaled. So if you have an image that is 100 pixels wide, it will be 100 pixels wide regardless of your resolution. Meaning on a 4K monitor, 100 pixels is going to be tiny, but on someone playing on 1080p, it will be quite bigger. So usually this leads to a lot of issues, so I don't like this mode. I want the UI to be able to scale, and I want to do that over here based on screen size. So over here we can input a reference resolution. So I like to put 1080p since I mostly make desktop games. So I'm going to put 1920 by 1080. If, for example, you were to mostly make vertical phone games, you would put the opposite, so 1080 by 1920 and so on. But in my case, just like this. And then let's keep it with this one, so match with either width or the height. And personally, I like to fully match it with the height. So over here, put it on 1. So yep, this is the setup that I like. What this means is that the canvas itself, this one will basically only scale if the height resolution changes. Let's see exactly what that means. So inside the canvas, let's right click, create a new UI image, just for testing, just so we can see. So we have this image over here, and let's duplicate this image. And over here in the editor, let's press on F in order to focus on the object and zoom out. And for this second image, let's put it roughly over there, somewhere over here on the right side, and importantly over here on the anchors. Instead of being anchored down the center, which is the center of the screen, let's anchor it over there on the top right corner. Don't worry if you're a little bit confused, I won't explain what all of this means. The anchors are basically how this position is relative. So this one is anchored down the middle, so that means that it will always stay within this position, so in this case within position 0, 0 relative to the center of the screen, whereas this other one, this one will keep this position, minus 338, minus 345, relative to this corner of the screen. Meaning if this corner of the screen changes, then this object will also move. So on the game view, over here we can set all kinds of different aspect ratios and resolutions. By default, it's on this, it's on 1080p. And if I were to change this, let's say to 4K, and if there you go, nothing changed, just because that one has the exact same aspect ratio. It's because of that, and because we chose scale with screen size. So if we're working on 4K or either 1080p, notice how the size does not change. It still occupies the same size within the screen. This is why I like that option of scale with the height. Whereas with constant pixels, it would modify the size, whereas like this, nope, nothing changes. So you can make your game and make your game playable over here in 1080p, and if someone is playing on 4K, everything works exactly the same. The one difference is if the aspect ratio is different. So if it is 16:9, nope, nothing ever changes. But if it is different, like let's say 16:10, give it a go and look how that object changed. If we go to something more extreme, like 5:4, which by the way, you can click on this little plus icon, and then add another label, and you can choose either fixed resolution or fixed aspect ratio. So I made this one 5:4. That's basically how I created this one over here. And if I put it, if I go 5:4, this is more of a square sort of thing. So we can see how the objects change between this one and Full HD. You can see how the one down the center, that one always stays on the center. Whereas this one over here, since like I said, we anchored it on the top right corner, that means the position is relative to that corner. So if that corner moves from there to there, then obviously this object also moves. Essentially, the benefit of this setup right here, so scale with screen size and match with the height, is that if the height of the screen changes, so if I move this around like this, notice how the object gets scaled up or down in order to keep pretty much the exact same size regardless of the screen resolution. And then if I change the aspect ratio to something quite a bit more squarish, if so, then the object basically moves position left to right. So if this is why this is my preferred setup, it's because of this. Like this, I know the objects won't ever change size, they will always stay constant. They will really just move left or right, depending on the resolution, depending on the aspect ratio. So this is how I usually build my games. I basically just make sure they are fully playable on a 5:4 resolution. And if so, if it works like this, then I know it will work on any resolution. So yep, this is how I normally set up my canvas. Over here on the game view, let's bring it back to Full HD, 1080p, and we can now get rid of these testing images. There it is. So yep, we have our canvas, and now we can begin making our nice UI. So inside the canvas, let's create an empty game object, call this the stats UI. We're going to have some sort of stats. And now for the anchor itself, so on the rect transform, let's click on it, and let's anchor it over there on the upper left corner, so like that. And okay, so there it is, and we can actually see that little icon, so that means that this is anchored onto the top left corner. Let's put it roughly over there on top left corner, and now we actually want to scale it, so this little square area, this, as we can see, currently has a width and height of 100 by 100. Now let's modify the scale a little bit. We can either modify it over here directly by moving the numbers, or actually we can use over here the rect tool. Now it's important it's the rect tool and not the scale tool. These are different. If we modify the scale tool, then yep, look at that, we are modifying over here the scale on the transform. We don't want that. We want that one to remain just on 111. Instead, we want to modify this width and height. So that is why we want to use this tool, the rect tool. And now this one, we can move this around, and yep, we've got a nice square shape. Okay, so that's great. Now inside this one, so inside the sets UI, let's right click, create a new UI image, name this the background. And on this one, let's make it black. And over here on the anchor, here let's choose an interesting one. Let's use this one over here to stretch. So we click on this, and yep, we can see now those little corner icons, those are all in those corners, but it still has the same shape. So over here, we need to make sure to set all of these on 0, so left becomes 0, so there's no offset. And if we put 0 on all of these, if so, then yep, now this image basically takes up the shape of the parent image. So if over here on the sets UI, if I modify this as this image, then yep, the parent, the child object. Then you have the child object, the one with the background, that one also basically changes its size. Okay, so this is great. Now let's actually show our stats. And for the stats, we're going to have a bunch of them. We're going to have first the score, then some kind of time, some kind of speed X, speed Y, and some kind of fuel amount. Let's use some simple text just to show this. So inside the stats UI, create a new, go into UI, and create a brand new text mesh pro. Call this the label text mesh. And here let's just write all the labels. So we've got the score, then we've got the time, then the speed X, the speed Y, and finally the fuel amount. Okay, we have this. Let's make sure to choose our nice custom font. So the one that I included in project files, there it is, that one. Let's make it in bold to look a little bit nice. Let's put it quite a bit bigger. Let's say like 50. Then up here for the width and height, let's put it both on 0, 0. And down here, let's keep it on the left side, keep it on the top. But for text wrapping, let's put it no wrap. So yep, there it is, just like this. And now let's also anchor it over here on the top left corner and then move it roughly on that place. Okay, great. So now let's make another text object. So we can actually just duplicate this one. So Control D to duplicate, move it to the right side. And for this one, let's anchor, align it on the right side like that. And here, let's just put some placeholder numbers. So like 0, 1, 2, 3, and so on. Okay, yep, great. So like this. So we've got the score, the time, the speed, and the fuel. Now, of course, we're going to need to modify these fields through code. So let's first of all just modify over here the stats UI, put it over there. Okay, we've got a nice little square shape. Now let's make the script to run this. So in our project files, let's go ahead and create a brand new script. So a new model behavior script for the stats UI. Let's wait for it to compile and let's attach it just like this and let's open it. Okay, so now here, let's get rid of this. And first thing that we need is a reference to our text object. So as always, let's make a nice serialized field, private text mesh pro U GUI. This is really important. We are now working in the UI, so we want to make sure to use this one, the text mesh pro U GUI, not the other one. This one is for world text objects, whereas this one over here is for UI objects. We are working on the UI, so let's define this one. And it's going to be for the stats text mesh. Okay, yep, so just like this. Then over here in the editor, let's first of all rename this. So this other object, this one is the stats text mesh, like that. And on the stats UI, let's just drag the reference just like this. And again, if over here you can't drag it, make sure you double check the type that you use. If you created a UI text object, so text mesh pro UGUI, if you created this one and you made a field of that type, if so, you should be able to drag it. Okay, so back in the code here, we need to get basically the score, the time, the fuel, and the various speed values. So let's get all of those. So first of all, the score, that one is stored over here on the game manager. Let's make a function to get the score. So public int get score, and we're going to just return the score like this. But of course, in order to access it, we're going to need to access the game manager script. So again, same thing. We could add a serialized field and drag the game manager reference. Or again, since we just have a game manager, let's just implement the simple singleton pattern. So public static of type game manager, call it instance with a public get and a private set. And then over here on a private void awake, we just set the instance equals this. So yep, we've got a nice singleton pattern. And over here, we can basically just set it. So let's make private void update stats text mesh. Let's make a function. We go in the game manager on the instance, we get the score, and we're basically going to attach it to that text. So it's stats text mesh dot text equals, and we begin by adding the score like this. Then we're going to add a new line. And now we need to add the next thing, which is going to be the time. So for the time over here on the game manager, let's also define that one. So private float for the time. So you have this and basically just increase it on update. So private void update time plus equals time dot delta time. Okay, great. And then a function to return it. So public float get time. We've got this one, just return time like this. Yep. And then over here, game manager instance get the time. We get that one as well. Okay. Then new line and something else. Now we need the speed X and Y, so that is going to be over here on the Lender script. Let's go down and let's expose that. And thankfully that's actually very simple. So public float get speed X. And over here, we can go inside the Lender rigid body 2D. And on this one, we can grab the linear velocity dot X. There you go, just this one. So let's just return this directly. And then same thing for the get speed on the Y. We have this one, return that one. And back on the UI script, Lender, we already have the static instance, super useful. Get the speed X, then another new line, and then Lender instance get the speed Y like that. Okay, and last thing we need is just the fuel. So again, that one is also over here. So let's do a public float, get fuel, in order to return the fuel for this Lender, and just return the fuel amount like that. And then over here, just plus another new line, plus Lender instance get fuel like that. Okay, great. So this should be doing. Let's just make sure to call this function. And since things like, for example, time are constantly going to be changing, let's do it on private void update. And on update, just update the stats text mesh like this. Okay, great. Let's save all of our files and let's test. And yep, right away, we do see it working. So we've got the time counting up, we've got the speed X, speed Y, and we've got the fuel, and we can pick up some more fuel. And yep, the whole thing works. Okay, so that's really great. Let's just make this a little bit more pretty. We've got a whole ton of decimal points. So let's round out some of those numbers. So first for the time over here, for this one, depending on the size of the levels, you can make this print in either minutes and seconds, or really just seconds. So that really depends on the size of your levels. And here, we're going to make our levels relatively small, so just seconds will probably be enough. Meaning over here, when we have the get time, let's just do mathf.round, and let's just round out the time. And yep, that should do it. Great. By the way, if you want minutes and then seconds, then you can do some simple math. So you can start with the time, then divide by 60 and floor it. That way you get the minutes, and then the remainder is going to be the seconds. But in this game, especially since it's an arcade game, and because the levels are all pretty small, then just seconds works fine. Then for the speed, for this one, let's also round it out. But if we just do this, the same thing, if we just round out, it's going to be some pretty tiny values. It's mostly just going to show 0 or 1. If we look over there, yep, look at that. The speed Y is really just between 0 and 1. Doesn't move too much. So if we just round it, we're really just going to get 0 or 1. So over here, to get some more interesting values, let's multiply it by something like 10f, just to increase it, and then we can do mathf.round. Okay, like this. And if there you go, so now it makes more sense. So now the speed is on -10, -20, and so on. Okay, so that looks good. Nice. And now one thing is, in the original Lunar Lander game, that one actually had some arrows pointing to where exactly the velocity is. So let's add those just for fun. Here in the editor, in our stats UI, let's just create a new UI image like this and call this speed left arrow. And in project files, there's a nice arrow sprite like that. Let's just make it a little bit smaller, maybe 50 by 50, something like that, and just move it roughly over there. Okay, so we're going to have this. Now this one, like I said, is the left arrow, so let's rotate it. So over there, the rotation on the Z, let's put it on 180. There you go. So this is the arrow left. Let's duplicate this one. This one is going to be the speed right arrow. So let's put the right arrow like this and rotate it by 0 degrees. And again, it should be on top of one another. We're going to handle that in a little bit. Then let's duplicate both these, duplicate it, move them down. And then we're going to have, so the speed up arrow. So we have this one and this one for the visual. Let's just see. And it's actually like this. So it's 90 degrees. So let's position it back there, put it on 90 degrees. And then we've got the speed down arrow. And for this one, let's rotate it on minus 90 like that. Okay, great. So we have the arrows. Now let's really just enable or disable them through code. Very simple. So over here on the stats UI, let's add some references. So let's add another serialized field of type game object. For the speed up arrow game object, then we're going to have all the other ones. So speed up, then we've got speed down, then we've got speed left, and we've got speed right. Okay, up like this, let's save it. And over here, let's just make sure to not make a mistake. So the speed up arrow, make sure you drag the right references. If you see something wrong, make sure you come here and double check that all the references, all the arrows are correct. Okay, like this. And over here for updating those, let's just do some very simple ifs. So for the speed up arrow, for this one, we can call it set active in order to either enable or disable that game object. And over here, we can get lender instance. Let's get the speed, in this case, the speed Y. So the up arrow is going to be visible if the speed Y is bigger or equal to 0. So if it is positive, then we show that one. And then for the speed down arrow, for this one, if it is under 0. And then same thing for the other ones. So we've got the left and the right one, except it's the get speed X like that. And actually the right one is if it is positive and the left one is if it is negative. Something like this. And since we have the arrows, we really don't need over here to have some negative numbers in text. So let's just do mathf.abs in order to get the absolute of this value, just like this. So you can close it like that, and yep, it works. Basically just because it would be confusing if we had an arrow pointing down and negative speed. That would imply it's moving up, not down. So if like this, we have no negative signs, we have just the arrows. This should work fine, so let's save it and let's test. And yep, right away it does seem to work. So if I'm moving up, there you go, the up arrow, and if I fall down, down arrow. And if I go to the right, right arrow, and if I go left, I got the nice left arrow. All right, awesome. So if that works, finally, let's just handle over here the fuel. And for this one, we could also just print the number as a percentage. That would work, but let's make something a little bit more interesting. Let's use a nice sliding bar. This is actually surprisingly easy to make in Unity. First, let's just make an image. So on the stats UI, create a new UI image. There it is. And over here on the image component, Unity actually has some really helpful image settings, but they are hidden by default. So over here on the image component, we cannot see those. It only shows up if we assign a sprite. So over here on the included textures, I've got this nice little white sprite. It is literally just a 1x1 white pixel. That's it, nothing else. So over here, if I select the image and I drag the white sprite, and if there I go, now I do see these new options. One of them is over here on the image type. I can set it between simple and change it to filled. And then for the fill method, let's go with horizontal. Let's go from left to right. And over here, I've got the fill amount. So if you look over there on the image, if the fill amount goes down, yep, there you go. It does fill up pretty much like a nice either health bar, fuel bar, pretty much anything. So yep, we can use this to show our fuel. Over here for the color, let's use a nice yellow to denote some kind of fuel. And then let's give it a shape, a nice rectangular shape. Put it roughly over there on the fuel, kind of like that. Yep, like that, we've got a nice fuel amount. So we're going to play around this fuel in order to make the fuel either filled up or gone down. And of course, we're not going to have the text over there. So on the static mesh over here, we can get rid of that placeholder. And visual like this, we can't really see just how big the bar is. We can't see how much is missing. So personally, whenever I have some kind of bar, I always like to have a background. So let's first give this a proper name. So this is going to be the fuel bar, and then duplicate it for the fuel bar background. And for this one, let's tint it in some kind of gray like that. And this one is going to be simple. It's going to be filled. But of course, this is the background. It's meant to show up before the other one. Now in the normal sprite renders, like we saw, the order in layer, that is what defines how we put some sprites in front of others. But over here on the UI, sorting is handled in a different way. It's basically handled automatically from top to bottom based on the position in the hierarchy. And the way it renders is, like I said, top to bottom. So in this case, the stats UI is going to first render the background, then render this label, then render this, and so on. So if you want something on top, then it should be at the bottom of the hierarchy. In this case, we want fuel bar to be above the background. So over here on the hierarchy, let's put the background before the fuel bar. That way it renders the background and then renders the fuel bar. So there you go. Now I think that looks quite nice. Let's just modify the field amount over here, the field amount, modify this one through code. So over here on the stats UI, let's add another field, and this one is going to be of type image, and it's this one over here, image, that exists inside using Unity engine.ui. So let's make sure to add that using statement, and this is going to be the fuel image. So yep, like this. And now over here on the update, we can access that one, and we can set this one, the fill amount, and we can get it to something. However, importantly is how this fill amount setting is normalized, meaning it goes from 0 to 1. 1 is the full bar, 0 is completely empty. Whereas our fuel that we have over here, this one is an actual value. So in this case, we define it as starting off at 10, then going down. It does not max out at 1. So we need to do some simple math in order to normalize this. And normalizing really just means dividing the current amount by the maximum amount, and we get basically the normalized value, or really the percentage of it. So that means we need to keep track of what is the fuel amount max. So let's do that. So fuel amount max, set it to like 10F. And then over here on awake, let's set the fuel amount equals the fuel amount max. So yep, like this. And then down here, we can make that function. So public float get fuel amount normalized, and really just return the fuel amount divided by the fuel amount max. Okay, yep, so like this. However, we also have another important question, which is basically over here when we add some fuel. Here we have basically two options. We can either add basically the fuel amount up to the max amount and no more, or we can add it and then basically, if needed, also update the new amount max. Both those options can work. Again, that's very much a game design question. In this case, let's keep it capped to this amount. So up here for the add fuel amount, let's add it by that one, and then just check if the fuel amount, if this one is bigger than the fuel amount max. If so, then we'll just set it to the max. So fuel amount equals the fuel amount max. So basically like this, it will only go up to the max and not over. Okay, so that's great, that's simple. Now over here on the UI script for the fuel amount, go on the lender, the instance, get the fuel amount normalized, and yep, that should do it. And finally over here, we don't want to print the text, so we just do this. Okay, like this, everything should finally be working. So let's save everything and let's test. Here in the editor, just make sure to drag the fuel bar image. There it is. Let's see. And if there you go, everything starts off working nicely. And if I can see the fuel is being consumed. I can see the score updating it. And the fuel is going. And now if I pick up some more fuel, and if there you go, it goes up to that. But again, importantly, does not go up above 10. So if there it is, I can keep doing it. And I can keep seeing the fuel bar constantly being empty. So let's try to spend all my fuel like this. Let's spend it. And there you go, it's empty. I can't move. And now as I touch the fuel, now I can move. Everything's right. All right, awesome. So yep, here we added a nice UI for our game. We have some nice stats showing our score, time, speed, and fuel. And again, we built it all following good, clean code guidelines. We kept code coupling to a minimum. The UI script is not coupled to any code at all. We could completely remove this UI element entirely and the game would still work. That's a great thing. It makes our game's code base much more simple and understandable. So now that we have this stats UI, it's time to build another window. Let's make one for when we have either a successful landing or a crash. So let's build that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to build another UI window, this time for our landing stats. We're going to show the window when we either land or crash, and display some stats like how much score or how fast was the landing. Okay, so we already implemented the nice UI window in the previous lecture. Now let's make another one. So over here, let's go inside our canvas. Let's create a new empty game object. Call this the landed UI. And on this one, let's first of all focus it and zoom out. On this one, let's make it stretch to occupy the entire screen. So over there on the rect transform options, let's make it stretch. And for all of these, put it at 0. Or actually, here's a quick tip. If you want to stretch and set all of those at 0 so that it expands to occupy everything, then over here you can hold down Alt and now click, and if there you go, those at 0, and now it occupies the entire window. Okay, so like this. Now let's add nice background. So inside add a nice UI image for the banner background. And over here in the project files, there's a really nice banner background right here. So let's assign that one. Then over here, this sprite, I also set it up with 9 slices. So let's make sure to use 9 slices. And for the width, let's put 900, height 200. And the pixels per unit multiplier, in order to make this a little bit smaller, let's put it on something like 2. If there you go, nice banner right there. Now let's make inside another UI a text object. Let's call this the title text mesh. And on this one, some placeholder text. We're going to modify this through code. Let's say successful landing. Let's put it in bold. Let's use our nice custom font. Let's put it the width and height both on 0. Then let's put it centered down the middle with no wrapping. There it is. Let's increase the size a little bit like that and just lift it up a bit. Okay, great. Now let's also add some stats. So let's add another UI, another text mesh object. For the stats text mesh. Or actually, let's first do the label. So the label text mesh. And then here, let's write the various things. So we're going to have the landing speed, then the landing angle. Then we're going to have the score multiplier and the final score. So we have these. Let's use the proper font. Let's put width and height at 0 as always. Put it down the left, up top with no wrapping, with a nice font size, maybe something like that. And put it over there on the left side. And then let's duplicate it, put it on the right side. For this one, align it on the right. And we're going to put some placeholder things like that. Let's just visually center it a little bit. So something like that. Let's lift everything up a little bit like this. And in order to be able to easily read that, let's also add a nice UI image for a background. Let's put this one in solid black and make the scale kind of like that. And of course, put it behind the text. Let's drag it up there. Okay, that's pretty great. Let's just name this text mesh. This one is the stats text mesh. Okay, great. So this is our nice UI setup. Now let's make the C# script to handle it. So our land UI, let's go into our scripts folder. So there it is. Let's make a brand new MonoBehavior script for the landed UI. Let's wait for it to compile. And when that's done, let's go ahead, add it and open. Okay, so over here, let's begin by adding all of our references. So we've got a serialized field, private, text mesh pro UGUI. Again, we're working the UI for the title text mesh, and another one for the stats text mesh. Okay, let's save it. Here in the editor, let's drag those references. So we've got the label, so we've got the title, and we've got the stats. Okay, so we've got this. Now all we need to know is when the lander either lands or crashes. And as always, let's write good clean code. Let's keep the UI decoupled from the lander script. And we're going to do that by using some more nice events. Here we actually already have the onLand event. And on this one, we can actually just use this and add some extra data. For example, we can define the landing type in order to know did we land successfully or not. So let's do that just so we can learn about another very useful C# feature, learn about enums. I've got a lecture on enums in my C# course. This is great for whenever you want to define a type with a fixed amount of values, meaning they're great for defining some kind of state or that sort of thing. So over here, let's define an enum, make it public so other classes can access it. It's going to be an enum, just like this, and let's make it called landing type. So we've got the landing type, and here we can define all the possible landings. So we've got a successful landing, then we've got, for example, the wrong landing area. We can have a too steep angle, or we can have too fast landing. So yep, those are all of our possible landing types. So up here on our type, let's add the landing type just like this. And then on the land UI, we're going to need to add all of the other stats. So let's add them over here as well. So a float for the dot vector. This is the angle, then a float for the landing speed, and also a float for the score multiplier. Okay, yeah, we have all of those. Then let's just invoke this event at various points. So when you've got this one, let's assign all of them. So first of all, in this case, for the landing type, this means that it was a success, so that one. Then you've got the dot vector, so that is going to be the one from up here, the one that we calculated. Then you've got the landing speed, so that is going to be over here, the relative velocity magnitude, and that is going to be our landing speed. So let's put that one. And finally, the score multiplier, that is going to be the landing pad, get the score multiplier. So yep, just like this. That's the successful landing. Now let's do the crashes. So land on too steep of an angle. So over here, too steep angle, let's put that one. Let's include those, and the score is 0. And actually over here, I forgot the comma, like that. Okay, great. And next one, we've got the landed too hard. So this is the too fast landing. Here we don't have a dot vector, so let's just put 0f. And finally, we've got this one where we did not land on the terrain. So for the type is the wrong landing area, and 0, 0 on that one. The actual landing pad is going to be null here, so let's also put 0 on the score multiplier. Even on all of these, since these are crashed landings, so let's put that one. And over here, same thing, also crash, also 0. Okay, so that's great. Now we have all this data being passed in through our event. So over here on the land UI script, let's just listen to that. So private void. As always, let's make it on start since we're accessing an external reference. Let's go on the lander, the instance, the onLand event, and let's listen to this one. So the lander onLand event. And over here we can modify things. First of all, for either the successful landing or the crash. So let's check if e.landingType equals a successful landing. If so, then we have a success. So let's go on the title text mesh and write successful landing. And if not, then we have a crash. And actually over here is this one .text. Then the title text mesh.text. If we have a crash, let's say crash, and let's actually put it in red just to make it fun. So over here we can use a nice color tag, so red, green, blue, like this. Should look nice. Okay, so that's the title, and then for the stats, so stats text mesh.text. Let's set it to something. So the first one is the landing speed, so e.landing speed. Then a new line, Then we're going to print out the dot vector, then another new line. Then we're going to print out the score multiplier, and let's put it with an X. X was the score multiplier, another new line, and finally we've got the score. So e.score like that. Okay, that's great. Except we're going to have the same issue that we had previously on the stats UI, where we're going to have a lot of values that are floats with lots of decimals. That doesn't look good. So over here, let's do mathf.round. Let's round it out, the landing speed. Let's also round out the e.dot vector like this. Okay, we're almost done. So the only thing missing is just the visibility of this window. We don't want it to be visible all the time. We only want it to show when we land. So let's do that. First, let's make some simple show and hide functions. So private void show, another one, private void hide. And on these, really the simplest way is just go on the game object, set active into either true, and on this one, set active into false. So if we have that, and then over here on start, let's begin with the window hidden, so we hide it. And when we have the event, let's update the text and show it. By the way, here, importantly, make sure you hide over here at the end of the start. If you were to do a private void awake, and over here you call hide, if you do this, then it won't work, it won't break. The reason is because over here you are disabling the game object, and if you disable the game object during an awake, then the start will never run since the game object is disabled. So if you were to do this, this function would never run, it would never attach the listener to the event, and it would never actually show. So make sure you never do this mistake. You should be listening to events on external objects on start. And if you want to start off with a window hidden, if so, then you should do it on start, do not do it on awake. So always remember that if you disable a game object on awake, it will not run the start function. Okay, so that's great. This should do it. So let's save everything and let's test. And okay, so first of all, the window starts off closed. That's good. Let's try to do a nice soft landing. And there you go, successful landing, landing speed 1, landing angle 1. So we can probably play around those numbers. But yep, it worked. We got the multiplier, we got the score. And now the window isn't hiding because it should only show once. But yep, there you go. As I touch the environment, it showed a crash. So that worked right. Let me try to land there, even though I can't see too much. And there you go, another successful landing, landing speed of 3, landing angle of 1, and multiplier of 5, and you scored. Okay, great. So let's just play around these values. So the landing angle, since we are rounding it, it is always going to be pretty much 1, so we need to play around that value. And same thing for the landing speed. This is always going to be super tiny numbers, so let's offset them by a little bit. Over here on the landing speed, let's just multiply by something just to make it a bit bigger. So let's say like 2f, something like that. We can play around these values. And then for the dot vector, let's do it times 100f, just to see. So let's test. So here we are, let's try to do a near perfect landing. And there you go, landing speed of 4, landing angle of 100, that's good. Now if I move and I have a bit more of a rough landing, there you go, landing angle 95, landing speed 4, multiplier and so on. So yep, still works. And if I crash on the terrain, and yep, there you go, we've got a nice crash. All right, awesome. So yep, now we have a nice UI that tells whether we have a successful landing or a failure. Everything works really nicely. So we can fly around, we can land, and everything works great. Except of course, we have an issue. So once we land, we can still fly again. The game should really have a proper end when we fail or succeed, and we should also be able to retry. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to make a proper start, game over, and restart for our game. Okay, so the UI that we built is working great. As soon as I land, yep, there you go. I've got the image shows up, says successful landing and a bunch of stats, so that's nice. However, after either a land or a crash, we should be able to have a game over. We should not be able to right now keep moving and move again and then crash something. This should not happen. And we should also have some kind of restart button here. That way we can restart if we crash. And finally, at the start, we should also not just start falling instantly. So let's add all of those minor details. First, let's on the start. That one's actually pretty easy. So basically our lander, this one is being driven by physics. It's actually being driven mainly by gravity here. So in order for it to start stopped, we can simply just disable gravity. So over here, instead of this value, we can just set it to 0 and basically it will have no gravity. So let's do that. Over here on the lander script, let's go down. We've got our wake, we grab our rigid body. Okay, that's great. And when we do, let's just set the gravity scale, set it down to 0f. So disable gravity, great. And now to reset it, we just need to set it back into that value. But again, let's make sure to not use magic numbers. And since the gravity scale won't ever change, let's actually make it a constant. So let's go up here, make a private const to make it a constant, a float gravity normal. And the normal that we defined was 0.7f. Okay, we have it. And if you're wondering why I use this naming scheme, uppercase, snake case, you can go ahead and watch the naming rules lecture on my C# course. In there I talk about all kinds of rules for different types of objects, and for constants, usually use upper snake case. Okay, so yep, so now we have this nice constant. And now down here, whenever we touch any input, let's just set the gravity back to normal. So we could just do it directly. So for example, over here, we could do the same thing as this if. So if we press any input, we consume fuel, and over here we could set the lander rigid body, set the gravity scale equals the gravity normal. We could do this. This would work, but let's do it a more proper way. Let's use a proper, simple state machine. This is another super useful design pattern, state machines. They are really awesome. And over here for this particular case, since we are going to have a waiting to start state, a done state, and then a game over state, because that, a state machine makes perfect sense. So first of all, for a state machine, we need some kind of enum to define the states. So let's define a public enum, call it state. And inside for the various options, we've got waiting to start and we've got normal. So if we have this, and then let's define a field of type state for our current state. And we're going to default the state into waiting to start. And then over here on the fixed update, on this one, we can do a switch on that state variable. And then we can have all the various options. So let's do the default and the case.waiting to start. We do something, case.normal, we do something else. By the way, if you don't know about the switch, go ahead and watch that lecture on my C# course. So if we have those, and this that we wrote, this is basically the normal behavior. So let's cut all of this, put it all over there. Great. Except for the gravity scale, we're not going to do it here. Let's actually copy this code that is testing for all the inputs. So when we press any input, then we set the gravity. And after we set the gravity, we modify the state. So state.normal, just like this, which then runs this. And here the gravity, we no longer need to touch it. Okay, so yep, so that should do it. So we start off on the waiting to start state with gravity disabled. Then whilst on this state, if we press any of the keys, we're going to set the gravity to normal, go into the normal state. And then over here, everything runs as normal. So yep, let's save everything and let's test. And yep, here we are, the game is running, but the spaceship is not falling down. So now only when I press, and yep, there you go, when I press, the gravity does start to take action and it works. Okay, great. However, just one thing, over there, the timer, that one is constantly counting up even though we are frozen. That shouldn't happen. The timer should only start when the lander actually starts moving. So let's do that. And again, let's use some proper nice code practices. So let's do it by using an event. So let's make another event, call it onStateChanged. Let's make also a class for some event args, onStateChanged event args, and we have event args. So you have this, and it's going to be of this type right here. Then inside, public state for the state that we changed to. And then down here, whenever we change our state, so over here, invoke with this, and then a new event args like that, passing the state equals this state. Okay, so that's the event being fired. And now over here on the game manager script, on this one, let's listen to it. So lander.instance on state changed. Let's hook onto this event. So that's the lander on state changed. And when this happens, let's basically just define a boolean in order to set the timer as active or not. So private bool is timer active. And then over here, when state changes, that one becomes true if that one.state equals state.normal. So yep, if the state is normal, timer is active. And if the timer is active, that's when we actually count it up. Okay, great, let's test. And if there you go, timer's not counting up, everything seems frozen, even though it's not, just waiting for player input. And as soon as I start moving, and if there you go, timer goes up, gravity becomes normal, and everything works. All right, awesome. So we have the start working. Now let's handle the end. And this one is going to be interesting. When we have a crash or some kind of landing, we want to stop moving the lander. So like this right now, I should not be able to move again. So let's do that. First, over here on the lander, on the state machine, let's make another state. So let's make the game over state. And then down here, if we have either a lander or a crash, so on this one, here we have a crash on terrain. So let's change the state. And since we're going to change the state multiple times, and for each of those, we're going to have to fire off this event, let's make a nice helper function so we don't have to copy paste a ton of code. So just over here, a private void set state and receive a state for the new state. And just do this dot state equals this new state. And then on state changed, let's invoke this one with this, the new state containing the new state. Okay, great. So now up here, we can do that. So when we have our awake, over here, when you change that, change into state.normal. And then when we have a crash, so let's see, for example, here we have crash, let's go into game over. And this another crash, also game over, another crash, also game over. And finally, successful ending, this one also going to a game over. Okay, let's save and let's... And finally, if we're on that state, then we're really just not going to do anything. So over here, just add the case for the game over. And yep, we don't do anything. We're not going to consume fuel, listen to inputs. Nope, nothing. Just on this state, we do nothing. So yep, that's it. Let's save, let's test. Okay, here we are, not moving. Let's move. Okay, gravity is active. Now let me land. And land correctly. Now if I try to move, and if there you go, nothing works anymore. All right, awesome. See if it works on a successful landing. And if we try with a crash, let's crash over there. And if there you go, also works, I can no longer move it. All right, great. Now, in order to make this a little bit more interesting, let's also add some nice effects. So over here in the project files, I have this nice explosion VFX. So this one over here. So this one over here, if we drag just to see it, If we look inside, yep, there you go, just a nice little particle explosion. This one is made using the particle system, so yep, here you can inspect how exactly this whole thing works. So basically just the emission, then the shape in order to go out on a circle radius, then changes the color over a lifetime, size over a lifetime, and so on. So yep, let's spawn this when we crash. And since this is a visual, for that, let's go over here on the Lender visual script. And on this one, let's listen to that event. So private void, let's implement a start. Then Lender, in this case on, let's go for the onLend event. And on this one, now we can check the type for that one. So do a switch on the e.landing type. Do a switch on this one. In case we have any of the ones that are crashed, so either the too fast landing or the too steep angle, or we have the wrong landing area. On any of these, let's just spawn the crash. So these represent a crash. Let's call instantiate, and let's instantiate that one. So we need to add a reference to it. Let's add a game object, call it the Lander explosion VFX, and then down here, really just spawn it. So instantiate that one on this transform.position with no rotation, so quaternion.identity. Except this will still keep the Lander visible. So the easiest way to make it invisible, really just game object, set active into false to disable it, and it won't show up. Okay, great, so let's save it. Then here in the editor, let's make sure to drag that reference. So on the Lander, here we've got the visual script. Let's just drag the explosion particle system, there it is. Okay, let's save, let's test. So here we are, let's go straight towards the terrain like that, and yep, there you go, nice explosion. All right, awesome. So finally all that's left is just the restart button. So let's go on the canvas, inside the Lend UI. So here we have this one, and let's make a button. So right click, create a new UI, let's create a button. It's going to be the restart. This is going to be the next button. Next, because it will either be a continue or a restart, depending on whether we win or lose. But for now, we just have one level, so let's just make it restart. Let's, of course, change this quite a bit. So let's change the font onto the other font, say restart. Then on the button itself, for the visual, over here, there's actually a nice button visual, so let's drag that one. There it is. Let's also make it quite a bit bigger, so something kind of like this. Although that is way too big, so over here on the pixels per unit multiplier, let's put it something like this. I think that looks good. Then for the text, put it in white, put it quite a bit bigger, something like this, looks good. Center, overflow, yep, all that is nice. So yep, here we have our nice next button. Now let's go inside the Lend UI. Over here, let's add a reference. So reference of type button, which exists in this one using Unity Engine.ui. So make sure to add that statement. So this is the next button. Let's save it. Then over here, let's just drag that reference. So the next button, put it like that. Okay, great. And over here, we can add a listener to this button. Now, since this button is local to this object, let's implement a nice awake. So on that one, we can access the onClick function, and we can basically add a listener to it. Now, I should say, naturally, this is the through code method. Obviously, with Unity buttons, over here in the inspector, you can add some logic to them. So over here, you've got the button script. And over here, you can add the functions that you want to call on the onClick event. So you can do it over here through the editor. But personally, I prefer to do it through the code itself. I find that's easier, so I don't have to basically connect the logic over here in the editor. I can just do it all over here in the code. And over here, this add listener, this one takes a Unity action, so we can just implement that. We can either implement a separate function, since this one is really just a delegate, or we can use a simple lambda. Now, if you don't know what is a delegate, then go watch that lecture on my C# course. They seem quite confusing, but in reality, it's relatively simple. And once you understand, you have a great new tool in your toolbox. So over here, let's use a lambda. So we use the nice little arrow syntax. So that's the arrow. So that's the lambda syntax. And over here, when we click, we basically just want to restart the game. And the easiest way to restart the game is really to just reload the same scene. So let's use the scene manager inside this namespace using Unity Engine.scene management. And over there, we've got a load scene function. And this one takes in the scene build index. Since we just have one scene, that's on index 0 like this. And yep, by the way, you might notice, yep, over here we have a magic number. We should never use this. And the only reason why I'm okay with doing it like this is because we're going to make a proper loader script later on. We are going to end up refactoring this, so we're not going to have a magic number here for too long. So just keep that in mind, but for now, this simple code is going to work fine. Okay, so when we click that button, we'll load the same scene, which is going to reload the same game. So let's go ahead and save this. And then here in the editor, it's probably time for us to rename our scene. So instead of being sample scene, let's name it the game scene. Okay, we have this one. And in order to be able to load it correctly, let's go into File, then Build Profiles. And over here, let's open up the scene list and just make sure the scene is added over there, and it is on index 0. So if you can click on Add Open Scenes, but yep, it's already here. Okay, so yep, like this, let's save, let's test. So here we are, and if I start moving, if I go ahead and I crash, there you go, crashed. Now I can do anything, and if I go into restart and I click, and if there you go, reload the same scene, I can play again. I can do a proper landing now. There you go, restart, and there it is again, so I can just play whenever I want. All right, awesome. So yep, here we have created 3 nice states for our game. We have the waiting to start state, so this one is waiting for us to do any input. Then it's normal, same as always, and then we've got a nice game over state. And then on that game over state, we can restart the level and keep playing. Great! So now that we have a continue button, let's make some more levels. So let's do that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to create multiple levels. Okay, so our game is already pre-mechanically complete. We can move around everywhere, we can pick up some fuel, pick up some coins, we can land all over the place, restart the level, and so on. So we already have quite a lot of things. Now we really just need a bunch more levels to play with. So let's do some. How we're going to handle multiple levels is actually quite easy. There are multiple ways we can do it. So one way would be to have multiple scenes and have each level in its own scene. Then you could additively load the UI and all the various components on another scene on top. That works, that method can work. But personally, my preferred method is simply to use some basic prefabs. So you basically build the entire level and put it inside a single prefab, and then dynamically pick the right prefab to spawn for the current level. So let's do that approach. First of all, we already have our level right here, so we can zoom out and see. So the level is really just the terrain, all the various landing pads, the various pickups, and so on. So let's first make a container game object. So an empty one, call it level_1. Let's reset the transform. This is important. Keep it on 0, 0, 0. Okay, now let's drag everything onto it. So we're going to drag the terrain. We're going to drag the landing pad, the fuel pickups, and the coin pickups. And actually, the coin pickup, this one should be a prefab. So let's first make that one a prefab. Yep, now let's select all of these, plus the terrain, and I think that's it. Let's drag it onto the level like that. So yep, that's the level data. All of that is inside it. Now let's make this one a prefab. So just drag it on there. So we've got the level 1 prefab. Okay, great. And now for different levels, we're just going to have different things inside of this. So different terrains, different landing pads, and so on. Each level is going to have some different data. So let's make a script to store the per level data. So on these scripts, let's create a new model behavior script. Call it the game level. And let's open up the prefab itself. So importantly, the prefab object over here, not the one on the scene. We don't want an override. Let's set onto this one the game level. Yep, there it is. Let's open. Okay, so here first let's make a field for the level number. So make a serialized field, private, make an int level number. And then another important thing for each level is going to be the player's starting point, because the player itself, the lander object, this one is outside the level. So when we spawn this one, we need to know where should we spawn the player. So let's make that one as well. So over here, let's make a field of type transform, call it the lander start position transform. So yep, like this. And over here, the way we're going to do that is basically by using an empty game object. So let's go inside this level prefab. Let's create a new empty game object, call it the lander start position. And over here, let's place it where we want the lander to start. Let's say right up here. So right up there for the coin, let's put it over there on the left side. So kind of like this. And now on the level, let's say this is level 1. And drag the lander start position. Okay, so that's great. Let's go ahead, save the prefab, go outside. All right. And over here, we're going to need this data. So let's make some functions to expose these. So a public int, get the level number, and we're going to just return the level number. And another one for the public, for the transform, or rather, we actually don't need the transform. We just need the vector 3 to get the lander start position. And here, just return, go in the lander start position transform, and grab the position. Okay, yep, so we have the data from the level. Now let's just dynamically set it up. So let's go over here on our game manager script. So here's where we're going to spawn all of our levels. First, let's define a field for the current level number. So let's make a serialized field, private int level number. And we're also going to need to keep track of all of our levels. So let's define a list of game level. And by the way, the list over here is not this one, not the one from NUnit. No, instead it is this one right here, system collections.generic. Okay. So this is the game level list. Yep, like this. Let's save it. And over here, let's go on the game manager. For the level number, let's default to level number 1. And for the game level list, let's drag our level 1. So yep, that's it. Now here on start, let's basically load the current level. So let's say load current level. And let's make this function. So let's make it. So up here, private void, load the current level. And first, let's cycle through our list in order to find the matching level number. Now, I should say, technically, we could use the level number as basically just an index, so starting on 0 and then find and spawn the index on this list. That could work, and that would be a perfectly valid method. But here, let's use the level number, just to make things a bit more different. So we cycle through the list to find the one that matches the current level. So for each game level in the game level list, cycle through all of them. if this game level dot, let's get the level number, matches the level number that we're trying to load. If so, then it's this one that we want to load. So here, let's instantiate this game level on transform.position on vector3.0 and with quaternity.identity for no rotation. Okay, so yep, so that's really it. That won't spawn it. But of course, we still have to actually position the player character. So let's grab the game level for the spawn game level. So we grab this one, and then from that one, we can get the lander start position. So we really just need to position the lander. So we can go on the lander, let's access the static instance, grab the transform, set the position onto that position. Okay, so yep, that should do it. And this should be working exactly the same as previously. So let's exit. Then here in the editor, let's just delete the level over here from our scene. Okay, so it's all nice and empty. And as soon as we spawn, since the game manager, that one's going to load level 1, which is going to be this one. Just make sure over here level number is set to 1, and we do have the start position assigned. So let's test. And if there it is, everything worked fine. It loaded the correct level, we spawn on the correct position, and I can move around and everything works. Okay, so that's great. Now let's make another level. So for starters, we can just duplicate this one to have a nice starting point. So this will be on level 2. Let's drag it over here just so we can play with it. So let's open it. Just make sure to position it on 0, 0, 0, and let's open it. Okay. Now let's make a slightly different shape. So over here on the terrain, let's modify this. Let's edit the spline. Let's say we're actually going to start off somewhere high, and then we're going to jump somewhere low. So let's say we want to spawn with a lander up here. Then we've got an easy landing over there, and perhaps we've got something kind of like that. We've got another one. Then we've got a steep drop. Then here, let's say we've got the hard landing, and then we've got another mountain that goes somewhere around here, and finally the whole thing ends over there. Okay, so kind of like this. Then let's grab the hard landing pad, put this one roughly over there. That's pretty rough. And then for the fuel pickup, let's spawn a few. So let's put maybe one over here, then one over here on this side. And for the coin, let's put another coin, let's say down here to force the player to go down there. And duplicate it, put another coin roughly, let's say over there, and maybe even over there if the player is really confident having enough fuel to go there, land, and so on. And finally, for the lander start position, let's actually start all the way up there. Okay, great, so that does it. Let's save this level 2 prefab, and over there on the level number, make this level 2. All right, great. We can exit, save the scene. Now here we can get rid of this one. All right. Then on the game manager, let's make sure to add it onto the list. So yep, we have 2 of our levels. And now in order to go from one level to the next, let's use over here this restart button. Let's change that. So let's go inside the canvas. So that is the landed UI. So we've got the next button. And we're basically going to need to modify the text over there. If we lose, we want to say restart or retry. But if we win, we want it to say continue. So let's open up the land UI. And over here on this one, so for the next button on click, let's actually store the click function. So store it on an action, so private action. This one exists inside the system namespace, okay? So next button click action. Let's define this, and over here, we're just going to call that action. And the reason why we're doing this is so that over here, when we have the on landed, if it's a successful landing, then the on action becomes a next level action. And for the next level, let's make that the responsibility of over here, the game manager. So let's go down here and make some functions. So public void, let's say go to next level, and we're going to have another one, public void, retry this level. So if it's a retry, let's go scene manager and load the scene, load scene 0. And for to go to the next level, we're also going to load scene 0, but we're going to increase the level number. So level number plus plus, and a retry level, basically just keep it. Okay, so that should do it. And then basically over here on the click, let's go inside the game manager, access the static instance, and on this one, in this case, if we have a successful landing, then go to the next level. And if not, if we have a crash, then we should retry this current level. Okay, yep, just like this. Let's just update the text as well. So let's define another text mesh pro GUI for the next button text mesh. So we have this one. And if we succeed, then let's set that one .text equals to continue. And if not, let's set it to retry. Okay, yep, so let's save. And over here, let's drag that one. So inside the next button, we've got the text. Let's drag that. Okay. So now we can test this, although I should say this will not work. And if you want, try to guess why this won't work. In reality, this is always going to load the first level. It's always going to load the same level. Like I said, if you want a mini challenge, try to pause the video right now and try to guess why this will not work. But let's give it a try and see. Okay, here we are on level 1, so everything seems fine. Okay, so let's win and see if we end up on level 2. There we go, landed. Let's continue. And nope, look at that. We are still on level 1, so it did not work. Even if I crash and I retry, still the same thing. So it is not actually loading the second level. And the reason for that is actually quite simple. It has to do with memory and class data. So over here for the level number, we made this just a normal field. meaning that this field exists on this object, and by default we set it on the game manager script to set to 1. So then on the next level function, this one we're going to increase it, so we're going to increase that one to 2, that's correct. However, then when we reload the scene, basically this object that exists on the previous scene, this object with all its data is deleted. So the memory that is storing this number, which is now set to 2, that one is destroyed. And then when it loads the brand new scene, it is going to load another instance of this object that again is going to load the default data, which will still have the level number as 1. So basically the old object with the 2 in the level number, that one is destroyed and a new object is created. So it does not keep the old data. If we do want that, then we have a real easy way to do it. So for this one, instead of being a member field, instead of that, just make a static int field. By being static, basically this means that it belongs to the class itself and not any instance of that class. So as the object instance is destroyed and new one is spawned, this field does not get reset because again, does not belong to any specific object. So objects being destroyed or spawned does not matter. This being static means that it's data from the class itself. I have an entire lecture on static in my C# course if you want to learn more. And since this one is going to default to 0, but the first level is 1, let's default it to 1 like this. Okay, so just like this, let's test. So here we are, okay, spawn on level 1, let's try to land nicely and see. Okay, successful landing, let's continue. And if there it is, it did spawn the second level. So I can go, I can move around, and I can verify this is indeed the second level. So yep, we can go down, and there's one right there. There's a fuel over there, so let's pick up the fuel, avoid that one, get some more fuel, almost crashed, and see if I can land down there on the hard landing, like this. And if there you go, it does work. Alright, awesome. Like this, we can already have as many levels as we want. We really just have to create more prefabs, make sure to add those prefabs over here on the game manager, and to really just keep loading more levels. Finally, let's just add over here the level number directly on the stats UI. So over here on the label text mesh, let's just add another one. So first for the level, and on the stats text mesh, we're going to have another placeholder for the level. Let's just make sure to move down the fuel bar and all the speed arrows. So all these, move them all down by that much, and for the background, increase it by that much. Okay, so that's great. And then on the stats UI script, on this one, let's update, so let's get the score, and let's actually get the level as well. So public int get level number. So you have this one, return the level number like this, and then here, game manager instance, get the level number, plus a new line, plus the rest. Okay, yep, so this should now show in the UI, but let's also add another final thing. So here we are on level 1. Yep, let's go ahead. Let's try to beat level 1 like that. Great. Let's continue. And now onto level 2. And if there you go, everything works nicely. All right, awesome. So yep, here we have implemented multiple levels in our game. Each level can have any shape, any visual, any landers, really anything we want. It's all dynamic. Now for the player, it actually would be nice to see the entire level at a glance from the start. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to add a nice beginning zoom mechanic. That way the player can see the whole map and decide what path to take. Okay, so we already have multiple levels, and since we have some fuel pickups, technically we can make some very large complex levels if we want. But of course there's a problem. If we have a really big level, like for example level 2 over here, the player can really only see a tiny bit of the map. Ideally, the player should be able to see the whole map so they can decide how much of a challenge they want. Do they want to go for the easy landing zone right at the start, or go further, risk running out of fuel and land on a tiny spot? In order for the player to be able to make that interesting decision, they need to know the map. So before we start the game, whilst we're waiting for input, here let's basically just show the entire map. Then when the player starts moving, we zoom back into the normal zoom amount. Okay, so let's do that, and for that we need two things. We need to move the camera, and we need to zoom out or in. So first of all, for moving the camera, right now we're using Cinemachine, so we have a Cinemachine camera, and the camera automatically moves towards the tracking target, which currently is the lander. So if we just give it a different tracking target, then it will look at a different place. And since each level is different, let's define the tracking target inside the level itself. So let's go inside level 1, and over here let's create a new empty game object, call it the camera start target. In this case, for this one, it is going pretty much to be on 0, 0. Yep, so we put it roughly at the middle of the map, something like that, makes sense. Now let's add a reference to it, so over here on the game level script, let's make another one, another serialized field transform for the camera start target transform. And over here, let's drag it, so the camera start target transform. And let's go on level 2, save this one, and over here, same thing, so another one for the camera start target. And for this one, since we've got a pretty big level, let's put it roughly something like this. Obviously, we can play around with these values later. But yep, let's drag reference like that. Okay, we have the references. Now let's go here onto the game manager script. And on this one, let's see where we are loading the current level. So here it is. When we do that, let's just change the camera target to that one, which means we're going to need a reference to the Cinemachine camera. So up here, let's do that. Another reference is going to be of type Cinemachine camera inside the unity.cinemachine. So that's the Cinemachine camera. So we have this one. Let's save everything. Then here in the editor, let's first exit the prefab, save it, and on the game manager, let's drag the Cinemachine camera. Okay, so now here using this camera, we can go inside when we load it. Let's go and set this one .target.tracking target. Set this one to that one, which means we need to expose it. So over here, make a public, return a transform for the get camera start target transform. And let's return the camera start target transform. And then over here, spawn game level, get the camera start target transform. Okay, great. And of course, when we start moving, we want to reset it. So let's listen to when the state changes. So over here on this one. So if e.state equals state.normal, meaning we start playing. If so, set the camera start target, set it to the lender. So lender.instance.transform. Okay, yep, so that should do it. We're going to handle the zoom out in a little bit, but for now, it should be able to see everything. Let's just default the zoom to being quite a bit more zoomed out. So over there, instead of 10, let's put it something like 25. Okay, so now let's test. And okay, there it is. So we start off right here. So we can't see the whole level, makes sense. And I can move around, I can play around, and let's land and try to see the next level, which is quite a bit bigger. Okay, continue. And if there it is, the camera's right here down the middle. So the player's starting over there. We just need to move the camera a little bit more, but yep, makes sense. And as soon as we start moving, yep, there you go, it does change the target to down. Okay, great. So now all that's left is just handling basically the zoom. And for this one, sadly, Cinemachine doesn't have an automatic zoom component. That's actually a little bit strange. There's a few components that handle zoom on a 3D camera, but not on a 2D camera. So for this effect, we sort of need to handle it ourselves, but thankfully it's also going to be pretty easy. Let's make a script to automatically zoom the camera. So let's make a brand new model behavior script called the Cinemachine camera zoom in 2D. Let's make a game object to run this with the same name. So a new empty game object with that name. Let's reset it, attach the script, and open. And over here, let's basically start off by defining a field for the target orthographic size. So private float, target orthographic size. And let's expose a function to set it. Public void, set the target orthographic size, and we're really just going to receive this and set it. So this dot target equals that target. Okay, great. Let's also default this one to 10f, even though we're going to set it on start. Then let's do a private void update, and on update, we basically just want to set the orthographic size to this. So let's make a reference to the Cinemachine camera. So serialized field private of type Cinemachine camera, this one, for the Cinemachine camera. So we have this one, and on update, we go inside the camera's lens, and here we have the orthographic size. So let's set it directly to the target orthographic size. Okay, yep, so just like this. Now we can go over here on the game level, and let's define the zoomed out amount. So a float for the zoomed out orthographic size. Okay, you have this one, then a function to get it, so public float in order to get our zoomed out orthographic size, and we just return the zoomed out like that, okay? And now if we go here on the game manager script, over here, let's go down to where we're setting things up, and we're going to need a reference to the Cinemachine camera zoom 2D. So we could add a serialized field, or really, let's just implement the super useful Singleton pattern. So public static of type Cinemachine camera zoom 2D. Call it the instance with a public get and a private set. So you have this, then on private void awake. On this one, just set the instance equals this. Okay, so that's great. So now back on the game manager, Cinemachine camera zoom 2D, access the instance, set the target orthographic size to this one. So go inside of that one and then get the zoomed out orthographic size. So if that sets it, and then when the player starts moving, let's just reset it. So over here, let's reset it. And for resetting, let's handle it directly over here. So let's define a private const float for the normal orthographic size, and it's going to be 10f like that. And then just make a function, public void. Let's do set the normal orthographic size. And over here, we'll just set the target and set the target to the normal orthographic size. So then on the other side, when we start playing, when the player starts moving, just set it to the normal. Okay, yep, so that should do it. Let's save and let's test. But before that, let's set it over here on the level. So for level 1, we could actually see everything. So let's put it on something like 12. And then for level 2, this one we're going to need to play around with that value. But let's put it on something like 30. And finally on the Cinemachine camera zoom 2D, over here, let's just drag the Cinemachine camera. Okay, so let's see if this works. Alright, so yep, this one starts off zoomed out, okay, fine, and then it zooms in as soon as you start playing, okay, exactly as intended, great. Let's go, let's continue, and if there it is, nice and zoomed out, and as soon as I start moving, yep, there you go, it zooms into the camera. Alright, awesome, that's great, that's exactly what we want. Except obviously like this, it is way too jarring. Let's make it nice and smooth, and thankfully this is also pretty easy. So over here on the camera zoom 2D, on this one on the update code, instead of setting it directly to the orthographic target, instead of this, we can use lerp to interpolate between a nice value. So we can use mathf.lerp, and this one basically interpolates a value between a and b by t. So if t is 0, then it's going to return exactly a. If t is 1, it's going to return exactly b. If t is 0.5, it is going to return exactly the middle point between a and b, and so on. So to make this nice and smooth, we can either keep track of the start and end points and increase the t over time, or there's actually an easier method that I prefer. We can just use the current orthographic target as the a, and the target one as the b, and just delta time for the t. So over here, let's do that. So Cinemachine camera, grab the lens, grab the current orthographic target, then the target one, and then time.delta time, multiplied by some sort of zoom speed. So zoom speed, let's say something like 2f. So we have this one multiplied by that one. And here the orthographic, it's actually the orthographic size. So basically like this, we have a nice ease out interpolation. Since a over here, since this one is constantly getting closer to b, and because t is always super small, it is just going to get closer and closer over time. This will be really nice and smooth. So let's save it and let's test. Okay, so here we are. And as soon as I start moving, yep, there you go. It smoothly zooms in to the camera. Great. Let's continue. And there it is, nice and zoomed out. And as soon as I start moving, yep, there you go. It smoothly zooms in onto that one. All right, awesome. So now we really just need to apply the correct zoom values, correct positions to all of our levels. So we can do that here. So let's start playing. Now let's pause. And over here, let's position the camera exactly as we want it. So we go inside the level clone for the camera start target. Let's find this one and let's move it around. So actually let's unpause. And over here, let's put the Cinemachine camera disable dead zone so that it follows it perfectly. Let's see where would be the perfect position. I think like this for this level makes sense. So we can copy this transform data, copy the world transform, and let's also remember the camera zoom. And this one should be correct, 12. So let's stop playing. Let's go inside level 1 for the camera start target. Let's paste the component values. And if there you go, it moved it. Great. Now let's do the same thing on level 2. Okay, here we're on level 2. Let's exit the maximizer. And now let's move that one, go inside the level, the camera start target, and let's position it somewhere. So we need to go on the Cinemachine camera, disable the dead zone. Yep, like this. Let's not disable the camera zoom 2D so this one doesn't mess up with over here the interpolation. So for the orthographic size, let's say something like this sort of makes sense, except the UI over there is blocking the start. So let's move it kind of like this, then zoom out a little bit more. And if there it is, I think like this is fine so we can see the whole map. So we need to remember the orthographic size, let's say 28. So 28, and for the camera start target, let's copy this position. So copy the world transform, let's exit. Then go inside level 2, and first of all, for that one is going to be 28. And the camera start target, let's paste the position like that. Okay, great. So both of our levels should be perfect. Let's test. And yep, here we are, nice and zoomed out. Okay, let's go ahead, start moving, and everything looks pretty nice. Okay, good. Let's continue. And here we are on level number 2. And this one, we can see the whole map. So here, as a player, now I can make the decision. Okay, do I go for this nice and easy landing, or do I go for that tough one? So I can make my plan, make my decision, and as soon as I start moving, yep, there you go. It smoothly zooms in, so now I can control the lander. And I can decide, do I want to go for the hard one or not? Let's try doing that one. Catch some fuel. And let's see if I can land right down there. Nice and soft. And yep, there you go. We made it. All right. Awesome. So yep, here we have implemented a nice zoom out mechanic. This way the player can make a plan and decide on difficulty for themselves. Hello and welcome. I'm your CodeMonkey. In this lecture, we're going to learn how to refactor our code to use proper input system actions. And by doing that, we're also going to easily enable Gamepad support for our game. Okay, so far we've been playing the game normally just with the keyboard. So we have inputs, we can move up, down, left, right. So yep, everything works really nice. But over here in the code, in the Lander script, over here for testing for inputs, yep, we are doing this. We are literally checking for the up arrow key on the keyboard, left arrow, and so on. So this is a great way to quickly get a prototype up and running, just listen to some very specific keys and make the actions. But at a certain point, like right now, we should refactor this code to use some proper actions. This adds a really nice layer of abstraction, which makes the game much more adaptable and easily lets us add things like, for example, controller support. So to do this, first we need to have an input actions asset. And actually, by default on the project files, we can see we start with one by default. We can either take this one and modify it, or really just make one from scratch. So let's do it from scratch just so we can see the whole process. So let's right click somewhere here on our project, and let's create, and over here we can find a new input actions. So there it is, let's call it input actions. And over here in the inspector, you can already see this nice little warning. Now, don't worry about this for now. We're not going to use this feature, the project-wide input actions. We're not going to use it, so it doesn't matter. The reason why we're not going to be using this method is because this method is based on strings, which, like I mentioned, I really hate. So we're going to do the more proper way using a proper C# class. But for now, let's leave it like this. Let's just click on Edit Asset. And if there it is, here we have the nice window. We can see we have action maps, actions, and properties. Now, the way this works is actually very simple. If you want to learn about the input system in detail, I have a really nice tutorial covering all about it. But like I said, in general, this one is pretty easy to use. So here we've got the action maps, so we can have multiple action maps. For example, if you have a game kind of like GTA, you would have one action map for the player walking, another action map for driving, another one for piloting a plane, and so on. In this case, for this game, we really just have one action map, so let's click on the plus icon, and let's just call it just player. That's it, okay? And now within each action map, we've got all kinds of actions. In this game, we have 3 actions. We're going to have the lender up, lender left, and lender right. So let's make those. So over here, we already have an action. Let's just rename this lender up. Then let's create another one. So right click, add action, lender right, and another one for the lender left. Okay, yep, we have all of these actions. And if we select any of them, then over here on the action properties, we can see how they behave. So we can see specifically the action type. This allows each action to function in a different way. Although in this case, leaving them as buttons should work fine. And finally, on each action here, we can see these nice little arrows. If we expand them, then yep, here we can see all kinds of bindings. And bindings is basically how we bind a physical action onto this actual action. And here on the binding properties, we can see the path. We can manually select from all kinds of things here. So like keyboard, go inside, choose any key, choose a character map to a key, and so on. We can do all that in order to find manually. Or, quite simply, just go here, press and listen. And now let's press a button. So in this case, for the lender up, let's choose the up arrow. And if there you go, pick that one. And yep, that's it. So when I press the up arrow key, it is going to trigger the lender up action. So let's do the same thing on this one. So listen on the right arrow key. And on the left one, let's listen on the left arrow key. And yep, that is it. We've got our action map, our actions, and each action has a nice binding. Okay, that's great. Now let's make sure to save this asset. And now we can close this window. And back here on the inspector for our input actions, over here, let's do something really nice. Let's toggle this one to generate a C# class. So this will generate a C# class with exactly the actions that we defined. This is how we're going to be able to use this without having to use any strings. So just enable that, click on apply, and now it is going to basically generate and compile that class. So let's wait a little bit for it to compile. Okay, it's done. And if you want, you can actually inspect the generated class. So here it is, the input actions. Here we see the class that was generated automatically. And you can browse around to see all the code that was generated. As you can see, it does a whole bunch of stuff. And the important thing is all the way down here at the bottom. Here we can see the player, so that's the player action map that we defined. We can see generate this player action struct. And within this one, yep, here we've got our actions. So lender up, lender right, lender left. This is what we're going to be able to use, again, without having to use any strings. So let's go ahead and use this class. And for that, let's make another custom class just for ourselves, just to basically act as a nice wrapper between our code and this code. So over here on our scripts, let's create a new model behavior script for the game input. Let's wait for it to compile. Let's make a game object for the game input. Let's reset the transform, attach the game input, and open. Okay, so now here let's do something. Let's begin by making a private void awake. And on awake, let's first construct our input actions object. So do new input actions, literally just like this. So this is the input actions. Okay, we have this one, and now inside this one, we can find the player map. And inside, like I said, we can find all the various actions. So the up, right, left. Now there's multiple ways we can handle these actions. So if these were press buttons, meaning things like shooting, jumping, and so on, if so, then on each action, we could access the performed event. This event gets fired whenever the action happens. So for a jump action, we would hook onto this event in order to know when the player should jump. However, in this case, our actions, our inputs are actually all going to be constant. So the lender up, right, left, down, that is all going to be constant. So we really just need to know if the button is pressed or not. So instead of using that performed event, instead, let's just go in this one. And then here we have the isPressed function. So let's basically just expose this. So here, make a public void is up action pressed. And we go inside the input action. So here, let's actually store it. So make a private field for the input actions. Over here, let's construct it. And then over here, let's return this one. Go inside the player action map, inside the up action. and check is pressed like this. And this is actually going to return a ball. Okay, so yep, so this is what we're going to do. Let's do the same thing for the other actions. So the left action, so that's the lender left. And then for the right action, that's the lender right. Okay, so that's great. Now we can go into our lender script, and over here, let's use those actions. And in order to access the game input class, as always, let's use the super useful Singleton pattern. So public static game input for our instance with a public get and a private set. And then on awake instance equals this, okay? So now here on the lender script, for testing the up arrow, instead of this, let us do game input, access the instance, and just check, is the up arrow pressed? If so, then yep, great. Then let's check for the left action and the right action. So right and the left action. And let's do the same thing over here on these ones. So we can copy and paste it over here. And then for these, for the is up arrow pressed, let's go, that's the up action. Then we've got the left action and finally the right action. So let's just change this. So the right and the left like this. Okay, great. So we have refactored all this code. Let's save everything and let's test. In reality, this won't actually work, but still, let's test. So here we are waiting for input, and as I press the up arrow key, and nope, nothing is happening. Now, this is actually intentional. This is how the input system actually works. So over here on the game input class, here when we create the input actions, here we need to also enable it. So let's go inside this one, call enable just like this. And yep, now it will work. So this is very important. We always need to enable the input actions, otherwise it won't work, it won't listen to anything. And in order to keep this nice and clean, let's also implement the onDestroy function to clean it up. So over here, implement the private void onDestroy. So this is the normal model behavior function. And on this one, let's just go on the input actions and call disable. Okay, great. So like this, let's save and let's test. And okay, here we are. Let's try moving up. And if there you go, now everything does work nicely. Okay, great. Let's try going on to the next level. Let's continue. And move, and yep, there you go, everything works great. All right, awesome. So yep, here we have refactored our code to use some really nice actions. So instead of using just keyboard inputs, we are now using a proper abstraction layer for our actions. Like I said, because of that, we can use multiple bindings for each action, and doing so, we can allow it to be playable with multiple different bindings. So here, let's open up the input actions asset. And now on each of these, let's go ahead, add another binding. And for this one, let's bind, for example, on the W key. That way we can play with WASD, so let's add another binding. For this one, this is the right, so let's go with D. And this one is the left, so let's go with A. Yep, that's it, nothing else we need to do. Let's save the asset, which in turn is going to regenerate the C# class, that's great. But again, we don't need to modify the code at all. Let's just hit on play. And now I try playing just with my WASD, and if there you go, everything still works fine. All right, awesome. So yep, we can now play either with our arrow keys or WASD and everything works fine. And importantly, we didn't have to touch any of our code to support this. And now since this is so easy to add more bindings, that means it's also super easy to add something like Gamepad support. So I have just connected an Xbox controller so I can move around. Yep, it is nice and connected. Now here, let's go ahead, open the input actions. And on each of these, let's go ahead and add. So for the lender up, let's go with the A button. So let's add a binding. Let's listen, and I'm going to press the A button. And yep, we can either do the A, so it only works on the Xbox controller, or we can go with button south, and that will work on any gamepad. So let's go with this. Then for the lender right, on this one, let's add a binding for the path. Now let me move the left stick to the right side, so let's go with that one. And over here, let's add another one. Let's bind for left, like that. Okay, great. Let's save the asset, wait for it to compile, close, and let's test. So here we are, and if I press on A, yep, there you go, moves up, move the stick, and there you go, just like that. So yep, look at this, now the game is fully playable. Here I am playing with a gamepad without touching the keyboard. And again, we implement this whole thing really nicely without having to use and modify any of the code. All right, awesome. So yep, this is the power of the input system. We don't need to change any code at all. We just added some new bindings, and just like that, our game is now completely playable with a completely new input scheme. That's awesome. Now the other important input you might want to know about is the touch input. That one has a few quirks, so let's implement that in the next lecture. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to add touch input to our game. Since we're already using the input system, this will actually be pretty easy to do, but we also have two methods we can choose from. Okay, so we already have the input system working, so our game is already playable with either a keyboard or a gamepad. Right now I'm using the gamepad, and yep, everything works really nice. Great. Now let's add the ability to play with touch as if we are on some kind of mobile device. So first, let's see the easy method with just some buttons. Then we're going to see the more slightly complex method with an on-screen joystick. So for the easy method, let's go inside our canvas. And over here, let's create an empty game object called the touch UI. Let's press F in order to zoom in on that. Okay. Let's make it stretch to occupy everything. So hold down Alt and stretch. Okay, it's over there. Now inside, let's make an image. So new UI image, call this the up button. And for this one, let's use just a circle sprite. Here you can press on this button in order to showcase the default visuals from inside Unity. And on this one, we can search for circle. And yep, we can find all kinds of pre-built circles. So let's use it. So if there it is, a nice simple circle. Let's do it just like this. No text, nothing. Let's make it just a little bit transparent. So maybe something like that. So this is going to be our upwards input. So over here, let's put it somewhere right down the center. Okay. Then let's duplicate it, put it over here on the left side. This is going to be the left button. And duplicate this again, put it over down the right side. This one is going to be the right button. Okay, so yep, so just like this. And now to control our inputs, over here on each of these, let's add a component. Let's add this component, the on-screen button. So yep, there it is, and this one gives us a control path. This basically emulates an input whenever we click on it. So let's emulate the up arrow just like this, and same thing on the other. So on the left button, let's add that same component. And this one, let's simulate the left arrow. And on the right one, let's go ahead, add that component, and let's simulate the right arrow. Okay, yep, so just like this. Honestly, with this, we're already done. We can test and see. So here we are, we've got the 3 buttons, and if I use my mouse, basically I'm going to click in order to simulate touch input. So click there, yep, there you go, goes up, click there, moves right, like that, and yep, like that. Obviously, it's a little bit more tricky to control this with a mouse as opposed to some thumbs. But yep, there you go, everything works fine. So our ship is being fully controllable using these nice 3 buttons. Okay, great. So like this, everything's already working. We've got 3 nice buttons. If we made an Android build, we could test the game directly on the device and everything would work. Also, by the way, Unity actually has a device simulator feature. So over here on the game view, we can see this button saying game, and we can swap from game into simulator. And over here on this one, you can basically simulate all kinds of interesting devices. It will simulate the actual playable area with the correct resolution, aspect ratio, and so on. For example, right now, we're simulating an Apple iPad mini 4, and if we hit on play, and if there it is, this is as if we are playing on an Apple iPad mini, and if there you go, everything works fine. So if we were using touch, this would work perfectly fine. Okay, so that's great. The simple method over here using 3 buttons, this one is working fine, but actually a lot of games use a joystick, so let's learn how to do that. Thankfully, it's also going to be pretty easy. First, we're going to need a joystick action. If we go inside the input actions, over here we define all of these over here on the action type as a button. Now for a joystick, we need one that works as a joystick rather than just as a button. So let's create another action. For this one, since we're going to have a joystick that moves in any direction, let's call it just movement. And we're going to have both horizontal and vertical movement. And for the type, instead of being a button, this one is going to be a value. Then for the control type, so this is basically the value type, we're going to want X and Y input, so let's go ahead and choose a vector2. Okay, so you have just like this, and now on the binding, first of all, we can actually add the gamepad joystick input just for testing, and then we're going to add the touch joystick. So for the gamepad, let's just add, listen, I'm going to move the left joystick, there it is, left stick on the gamepad. And yep, just like this, the joystick binding is already working. Now let's save the asset. Let's wait for the CSharp class to recompile. And now let's go to our game input class. And over here on this one, let's basically just expose that action. So public vector2 get the movement input vector. Save this one and we'll just return, go inside the input actions into the actual asset. Then let's access the player action map. And we're going to access the movement action. And for this one, let's read the value of type vector2. So yep, this is how we read one of those vector2 types. And now we can go on the Lender script, and over here, first of all, for checking if we are moving at all, if we have any inputs, let's just check if that one is different. So game input, access the instance, and let's get the movement input vector. If that one is not equals to vector2.0, meaning if we have any movement, then we're having movement, then let's do the same thing over here. And for these, for the up action, here we can just add something simple. So if we press the up action or the movement input vector.y, if that one is above some kind of dead zone amount. So let's say 0.4f, we can actually define the gamepad dead zone equals 0.4f. So if it's above that one, then we have vertical movement. If not, then over here we've got the horizontal. So that's the x. In this case, this is left. So let's go under and x above that one. And for dead zone, let's actually put it a bit small, like maybe like 2. Okay, so yep, like this. Let's save and let's test. So here I'm going to move using just the joystick and not any buttons. And as I move, yep, there you go. I'm moving up, down, left, right, and everything does work nicely. Actually, the dead zone seems to be a bit too much because it's actually rotating uncontrollably. So over here, let's put dead zone something like 0.4. Or actually, my mistake was over here. Basically, if the x is under the minus of that or above the plus of that, let's test again. So here I'm going to use the joystick, move up, and if there you go, moves, move right, move left, And yep, everything works quite nicely. Okay, great. So we have that joystick action. That one is working with the joystick. Now let's make it work with a touch joystick. So over here, let's disable these buttons. We're not going to use these. Like I said, you've got the two methods, either use buttons or joysticks. You wouldn't use both. So let's make another image. So another UI image called the joystick. Let's make this 200 by 200. And for the sprite, let's choose one of those circles. So that one, okay. We have this one. Let's make this one pretty transparent. So something like this. This is actually going to be the outline. And now inside it, let's make another image. So this is going to be the joystick center. On this one, same thing. Let's add the circle image. Let's make it just a little bit more transparent, like that. Great. And on this one, let's add this component, the on-screen stick. So up here, again, the control path. So we can emulate something. So let's listen to the gamepad stick. And if there you go, let's emulate that one. And over here on joystick, let's just push it a little bit down. So kind of like that. And yep, like this. Now if we test. So here we are, and as I click and drag in order to simulate touch, so click and drag this joystick, there you go, moving up, moving right, moving the other right, and yep, there you go, like this. Now I can indeed control it. So yep, here we have a nice, fully working gamepad joystick directly on the screen. So yep, now our game is fully controllable with touch. All right, awesome. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to learn how to make a nice main menu. That means we're also going to refactor our loading system, and also implement a pause menu, and finally make it all full playable with the gamepad. Okay, so our game already has tons of mechanics. We've got the spaceship we can control, we've got pickups, fuel, coins, we've got landing pads, we've got multiple levels, we've got terrains, we've got really all kinds of stuff already. Now let's add all the bits and pieces outside the game itself. So first, let's handle the main menu. So for that, let's create a scene. Let's go in our scenes folder. Create a brand new scene. There it is, a brand new scene. Let's make an empty scene. Call it the main menu scene. And let's open it. Okay, so here it is, completely empty. Now inside here, let's create a simple canvas. And let's set it up the exact same way as the other one. So scale with screen size with 1920 by 1080 and match with the height. Okay, great. Now inside the canvas, let's make an empty game object for the main menu UI. Let's stretch this one to occupy everything. So hold down Alt and make it stretch. There it is. Okay. Now inside it, let's create a new UI image. This is going to be the background. Let's also stretch to occupy the whole thing. And for the background texture, here it is, the logo background. Let's assign that one. Great. Let's also make sure to preserve the aspect ratio just so things look good. Then let's make another image. So UI image for the logo. Let's drag our logo image. Yep, there it is. And for the size, let's put it something like 1000 by 600. Yep, there it is. Lift it up a little bit, just like that. Looks pretty good. Okay, now let's make a button. So we can make it over here and we can create it, or we can just go back into our game scene. Since over here we already have the restart button, we want it to look exactly like this. So let's Control C to copy this one. Go inside the main menu scene, inside the main menu, select the logo, click, and yep, there you go. Here we've got the button. So we're going to have the play button, and then we're going to have the quit button. So for the play button, make this one a little bit smaller. So for the play button, make this one a little bit smaller and make it say play. So play, put it on something like 400 by 140. So just a little bit smaller, and the quit button, make it even smaller. So like 380 by 120, put it a bit lower. And for this one, let's make it say quit like this. Okay, great. So we have our two buttons. Now let's make the script that is going to run this. So in our script folder, let's go ahead, right click, create a new mono behavior script for the main menu. Let's wait for it to compile. And when it's done, let's attach our script on there. Also, by the way, at this point, if you want, you can start to organize the scripts folder into multiple subfolders. Personally, I think this game is still pretty small, that it doesn't really need that. Just one folder works fine. But if you prefer, you can definitely make some separate folders. For example, usually in my complex projects, I like to have a folder just for UI stuff. So for example, the Lend UI, the main menu, the Stats UI, all of these put over there on the UI folder. Yep, there it is. Then if you want, you can make another folder for pickups and drag the coin and fuel pickup, put it over there. And then if you want, you can keep adding it to subfolders. Like I said, this game is still pretty simple, so we don't necessarily need a very complex structure. Just like this works fine. Okay, so on the main menu UI, let's open this one. So first, let's add references to our buttons. So as usual, a serialized field. Private of type button, which exists inside Unity Engine.ui for the play button, and then another one for the quit button. So we have these two, let's save. And here in the editor, let's drag the reference. So the play button and the quit button, great. So now over here on private void awake, let's assign our listeners. So on play button, on click, add a listener, add a nice lambda function, and then same thing for the quit button. So quit button like that. Now for the quit, this one's actually super simple. We just do application.quit, and yep, this will automatically quit our game, so that's great. By the way, if you test this in the editor, over here, if I click the button, it doesn't really do anything. That's okay, that's intended. Basically, that function that only works in the final game build. Over here in the editor, it doesn't work, but that's intentional. So then over here for the play button, on this one, we want to load the game scene. So now it's time to refactor our loading code. So we're no longer using magic numbers. Over here on the game manager for this one, we are using this load scene 0. Like I mentioned when we first wrote this is not good. We're using magic numbers, we shouldn't be using that. So let's make a proper script to handle our loading. Back in the code, let's make another script, call it the scene loader. And we don't need a game object for this one. Let's open it. So on this one, this is going to be an interesting one. Here, this one is actually going to be a static class, meaning all the elements will be static. Again, if you want to learn more about static, check out that lecture in my C# course. So we're going to make it static, and it is not going to extend mono behavior, because again, we're not going to attach this one directly to a game object. So we have this, and then let's make a public static void, a function to load our scene. And on this one, you go inside the scene manager, and we call load scene, and we load our scene. So now here for loading scenes, we have two options. We can use the int for the scene index, or use a string for the scene name. Now, honestly, neither of these are really good approaches. Strings have all the issues that I've already mentioned multiple times in this course. And an index, that one is also bad, because the index isn't really defined here, but rather on a completely separate place, the bin list. So this is the case where the Unity official API doesn't really have a method that I personally like. So we're going to do something a bit different to try to make it a little bit better. We're actually going to be using this string method, but we are not going to be using strings ourselves. Instead, we're going to define an enum. So up here, let's define a public enum, call it our scene. And now here we are going to define all the scene names. Now the only important thing is that over here we define exactly like the string name. So we have the main menu scene and we have the game scene. Again, make sure the names that we write over here, make sure they 100% match the names of the actual scenes. This is really important, otherwise it's not going to work. Basically like this, on the load function, we can receive a scene, and then we call scene.toString. So technically, we are using the string method, but our code is never going to use strings directly. In our code, we're only going to use this enum, and as long as you make sure that the enum values perfectly match, as long as you do that, then we can technically avoid strings, even though in the end, we are still using the string method. So this is pretty much the best solution of all. Like for example, if we are on the main menu, over here, if we go into the scene loader, and we call our load scene, here we have to use the enum value. So for example, if I mistype game scene, so if I write it just like that, yep, we have a compiler error because this is not the correct name. I have to write it perfectly, and only like this it works. So sadly, we can't completely 100% avoid using strings, but by using this, by using a nice enum, we can mostly avoid it by using this specific enum that only has a limited set of values. Okay, so yep, so this is what we need. So basically when we click, we'll load the game scene, and then on the scene loader, it's just going to load that scene. Now let's just refactor our code. So let's go on the game manager, and over here for retrying the level, let's go onto the scene loader, and we're going to load the scene, and the scene we're going to load in this case is the game scene, and on this one, same thing, also the game scene. Okay, yep, so that should do it. Let's save all of our files. And over here, we just need to make sure one thing. So first, let's go into File, into the build profiles, and over here, open up the scene list, and make sure to add our open scene, so add the main menu scene. And we do want the game to start on the main menu, so let's drag it up there, and if there you go. That way we start in the main menu, and then we can also load the game scene. Okay, so like this, let's test. And here we are on the main menu, and if we go and click on the play button, and if there you go, we are now playing. All right, awesome. So scene loading is working. Now let's make the nice pause menu. So over here, I want to be able to press a key and basically pause the game. So let's first go back into the game scene. Let's save it. Now over here on this one, let's make another window. So let's go inside the canvas, create a new empty game object for the paused UI. Let's go ahead, stretch it to occupy the whole thing. Then inside, let's make a UI image for the background. Make the background in some kind of black with sort of alpha kind of like that. Let's also make this one stretch to occupy everything. Okay, great. Then let's just make some text. So a new UI text. This one we're just going to say paused. Let's put it in bold with our custom font. Let's make it quite a bit bigger. Let's put the size, width, and height both at 0. Put it down center, down the middle with no wrapping. Okay, let's increase it so kind of like this, just to say that the game is paused. Actually put it in some like a yellow, maybe red, something like that. Okay, great. Then let's also make a button. So let's go inside the Lend UI. Let's duplicate our next button and put it over there. So in this case, it's going to be the resume button like this. And for text, let's say resume. So yep, just like this. Now let's make the script to run this. So inside the UI folder, let's create a new mono behavior script for the paused UI. Let's select it, attach it, and open. Okay, so here, first let's grab the reference to our button. So a serialized field, private of type button, inside the UnityEngine.ui for the resume button. Okay, like this. Then here in the editor, let's drag the reference, so the resume button, like that. And now on private void awake, on awake, let's go resume button, on click, add a listener, and the listener, let's add a delegate. And this is where we need to add the pause and resume button. So let's do the logic for handling that on the general game manager class. So over here on this one, this is where we are going to handle actually pausing the game. So let's go down and make some nice functions. So a public void, call it pause game. And here we're going to want to pause the game. And to do that, it's actually super simple. We can just set the time.timescale, set this one to 0f. So basically this is the multiplier that is applied to every single delta time calculation. And if we set it to 0, then it's going to be multiplied by 0, so it will have 0. This will basically impact all the physics and literally anything that use delta time. So if it is 0, basically none of those objects are going to move. So you have the pause game, and then we have the resume game, or let's actually call it unpause game. I think that makes a bit more sense. And for unpausing, we just set it back to 1. And back in the pause UI, just go game manager, the instance, and unpause the game. Okay, so now all we need is to call this pause game. So let's see where we're going to do this. Basically, we want to make it by a button. So let's go ahead and set up another action. So let's open up our input actions asset. And over here, let's add another action. Call it the menu action. And this one is going to be a button. Yep. And for the binding over here, let's go ahead and let's say press on escape. Which actually the escape doesn't work with the listen because it just cancels it. So let's type escape. There you go, escape keyboard like that. Okay, we have it. Let's save it, wait for it to compile and so on. Then let's go here on the game input class. And now on this one, since that one is a button that we want to basically see only when the button is pressed, because that, let's go on the input actions. And on this one, let's access the player action map and then the menu. And now here we're going to use the performed event. So let's attach a listener to this one, the menu on performed. And when we do, let's just fire off an event. So up here, public event handler, let's call it on menu button pressed. So yep, we have this one. Then over here, let's just invoke this one, this event args.empty. Okay, so when we press that, we're going to fire off this event. And now we can basically attach a listener to this event. So let's go back into the game manager and up here at top on the start, let's go on the game input, access the static instance, and then on the on menu button pressed. And here I just forgot to add the event keyword, so event handler. Okay, great. So here plus equals attach a listener to this event for the game input on menu button pressed. And when this happens, here we want to either pause or unpause the game. So let's make a function for that. So pause, unpause game like this. And here at the end, let's do it public void pause, unpause game. And we're basically going to check if time.timescale, if this one is set to 1f. If so, then the game is currently unpaused. So let's pause it. And if not, let's unpause it. Okay, like this. So finally, all that's left is over here the pause UI. On this one, let's make sure to show it when the game is paused. So for that, let's make some events to fire off from the game manager. So up here, let's make some nice events. So public event handler, on game paused and on game unpaused. So yep, we have these two events, and then over here, let's just fire them. So on game paused, let's invoke with this event args.empty, okay, and on game unpaused, like that. So now on this one, let's implement the private void start, since we are accessing an external reference. So the game manager, the instance, on game paused. When the game is paused, then we want to show this. So game manager on game pause. So let's make some nice show and hide functions. Show ho and private void hide. And here just game object, set active in this case into false. And over here, set it to true. And then when the game is paused, let's show. And when the game is unpaused, so let's actually make the other functions over here on game unpaused. On this one, let's attach another listener for the game manager. And this one, let's hide it. And of course, by default, let's also start off it. Okay, that should do it. Let's save everything and let's test. So right away, it starts off unpaused, makes sense. Okay, now I'm moving the spaceship, it's moving around, press escape. And if there you go, the game is paused, look at that, nothing is moving, that's awesome. Press escape again, and if there you go, starts moving, press escape, it's paused. Now the resume button, and there you go, unpaused, so yep, everything works. All right, so that's awesome, nice. Finally, let's just implement a nice game over scene. So let's go ahead, create another scene. So create a new scene, an empty scene for the game over scene. Let's go inside it. And over here on this one, same thing. Let's set up a canvas, set it up with constant screen size, 1920 by 1080, match fully with the height. All right. Then over here, let's set up a new empty game object for the game over UI. Let's stretch to occupy the whole thing. Let's attach a new UI image. Let's make it stretch as well. And for this one, let's use the nice stars background. Yep, there it is. That's good. We can actually set this to tiled like that. Okay, great. this is the background. And here we really just want to show the game over. So let's say just a text. Here just say game over. Just put it on pretty big. So let's put it in bold. Increase the font size. Center down the middle. No wrapping. A little bit more. Put our nice pixelated font. Move it up a little bit like that. Okay, great. Now we just want to show the final score and also a button to go back to the main menu. So for the button, let's grab it from, let's say, the main menu scene. So over here, let's grab the play button. So go inside that one, copy the play button, go into the game over scene, go inside that one and paste it. So this is going to be the main menu button. Inside, say, main menu. Okay, we have the button. Let's make it a little bit bigger, kind of like that. All right. And finally, for the score, so let's say a new UI text for the score text mesh. And here we're going to have final score and then say whatever is the final score. So let's put it in bold with our custom nice font. Let's put it down center, down the middle, no wrapping, size of 00. Put it somewhere over there and maybe a little bit bigger like that. Okay, that's great. So let's make our script the game over UI. On the UI, let's create a new model behavior for that one. Then over here, go into that one, put there. And now here, as usual, let's begin by adding our references. So serialized field of type button for the main menu button. Then another one of type text mesh pro GUI for the score text mesh. Okay, we have these two. Over here, let's drag the references. So the main menu button like that and the score text mesh like that. Then here on private void awake, let's go onto the main menu button. And on the on click, let's add a listener. And on this listener, just go into the scene loader and load the scene, in this case the main menu. Okay, great. And finally for the score text mesh, let's go private void start. And here for the score, let's grab the score from the game manager. However, the score that we have over here, this one is a score for this level. It is not the total score, so we need to keep track of that. So private int total score. We have this one, basically let's increase it whenever we go onto the next level. So go on to the next level, total score plus equals our current score. And then a function to get it, so public int get total score. And let's return the total score. And of course, the total score like this won't work because it's a member field, so we need to make this static so that it persists. Yep, just like that, default to 0. And then over here on this one, game manager, let's exit the instance, get the total score. So we have it and just set the score text mesh.text into this one .toString. And let's actually say also final score and plus down. Okay, so that's it. Now, of course, the question is how exactly do we get to this game over scene? Basically, the logic is going to be here on the game manager where we are loading the next scene. And we basically want to go to that one if we no longer have a next scene. So over here, basically we're loading the current level, meaning we're looking for a level with a valid level number. And if we don't find any, then let's basically go into the game over. So let's actually refactor this code to grab a game level. So private game level, get game level. And over here, basically going to do all of this logic in order to find the one that matches and then return this game level, okay? And now on this one, load current level, we get the game level. That's the game level, game level. We get that one, and then based on that one, we do all of the usual setup as previously. And over here, if we don't find it, return null. Okay, yep, so that's great. So now using this function to get the game level, we can go down here and we can check if get game level equals null, and basically no more levels. So let's go scene loader in order to load a scene. And the scene we're going to load is the game over scene. So let's actually add it over here onto the enum. So the game over scene, just add it. Then over here, the game over scene. And if not, if we do have more levels, so we still have more levels. If so, then just load the game scene. Okay, great. So that should do it. Let's go ahead, save everything. Then of course, make sure to add this scene onto the build list. So build profiles, open the scene list, add this one. Okay, let's go back into, let's say the main menu. Okay, let's save. And over here, let's test. So here we are, let's hit on play. And let's go ahead, let's try to win this one. So we are on level 1, try to win. There you go, we won. Okay, great. Let's go level 2. Try to win this one as well. Let's go on down like this, land, continue. And if there you go, game over. And yep, we do have our nice final score. And we can check here in the console. Yep, on the first level, we got a score 277, then 359. So put them both together. And yep, this is indeed the final score. All right, awesome. So it does seem to be working. Except we actually have one issue. So what happens if we want to play the game again? Let's try that. So go back to the main menu. Then over here, let's play again. And then look at that, we have an error. What is the error? We can go ahead and see what is the error here. And if the error is that the game level is null, because it is no longer finding a game level because the level number is currently set to 2 and there is no game level on number 2. So essentially the issue that we have here is that these fields over here, these are not resetting. We need to make sure to reset these whenever we start a brand new game. We need to make sure to reset this data. By making it static, we made it so that it does persist through scenes, but that also means that it does not get automatically reset. So let's make a function to reset it. So public static void reset static data. So you have this one here. Let's set the level number equals 1 and the total score equals 0. So if we have this, we just need to call this whenever we start a brand new game. So let's go on the main menu. So over here, before we load the game scene, let's just go game manager and call reset static data, and then load, and now it should work. So let's test. Okay, main menu, let's play level 1. All right, great. Let's land on this one. Okay, landed. We are now on level 2. And actually, let's go into escape, paused. And this one, actually, we should add a main menu button. So let's do that. So on the game scene, let's go inside the canvas, inside the pause UI, duplicate the resume button, and make another one over here for the main menu button. Let's make this one main menu. And on this one, let's make this one a little bit smaller. So on the menu itself, increase the height, but then over here on the scale, let's put it on something like 0.7, maybe 0.6. Just make it a little bit smaller, and the resume button is still the main button. Okay, then on the pause UI, over here, let's just add another one. So another button for the main menu button. And on this one, we have the on click, add a listener. And when we do, let's go into the scene loader and load the scene. In this case, we want to load the main menu scene. Okay, back on the main menu, let's hit on play. All right, let's go ahead and beat this level. So let's go into level 2. All right, so we've got a score of 349. That's great. Over here, let's start playing. Let's pause. Let's go back to the main menu. Okay, now hit on play. And if there it is, here we are back on level 1. Except we do have another issue. The game is currently paused, so we need to pause and unpause it in order to go back to being playable. So that issue with levels data has been solved. Let's just solve this one. So it's very simple. Over here on the main menu UI, let's just reset the time.timescale all the time. So set this one back into 1F, and yep, that should solve it. So here we are. Let's hit on play. Okay, let's move around. Let's go ahead, land. Great. Level 2. Let's move around. Pause. Quit. Play again. And if there you go, everything works. We're back on main menu. All right. Awesome. There's just one final thing that we need. So the laser itself is already controllable with the gamepad. But over here, now using the gamepad, I'm basically stuck on this menu. I cannot use the gamepad in order to click on this continue button. That's not right. The game should be playable just with the gamepad. So let's go back into the main menu scene. And over here, let's make these buttons clickable with the gamepad. And thankfully, that is quite easy. So over here on the main menu, let's go inside the play button. And first of all, let's make it visible as to when this one is actually selected. Because technically, things are already working with the gamepad, but we can't quite see it. So over here, let's put the select color on something like a green. And same thing on the other one. So let's copy this color on the quit button on the selected also like that. Okay, so let's see how it's already technically working. So like this, if I move the gamepad, nope, doesn't work. Press the button, nope, nothing works. However, using the mouse, I'm going to click down on the play button, move outside of it and let go out here, so it's not actually going to click. And if there you go, look at that one, how it's now green. And now if I use the gamepad and I move down, yep, there you go, now I can select the buttons. Now press on A, and yep, now I am indeed playing. So that really is the only issue, we just need to pre-select some button. So that's thankfully very easy over here on the main menu. So over here on the main menu, let's just implement a private void start. And on start, let's just go onto the play button and call the select function to select it. Yep, that should do it, so let's save. And now as soon as I hit on playing, and if there it is, the button is selected, so I can now move up and down. And yep, I can control it with my gamepad. Click on A, and if there you go, now I am playing and everything works fine. So that's it. All we need to do is implement that on every single one of these. So basically when this window shows up, we have to show the continue button. So first, let's actually copy the color over here and apply this to every single button, just so we can easily see when they are selected. So let's go on the game scene and find all of our buttons. So we've got the land UI, that one has this next button. So on the select color, let's paste it. Then we've got the resume and main menu. Let's also paste the color on that one. And I believe those are all the Ys. Yep, that's it. Also on the game over scene, let's go ahead inside this canvas on this button and let's attach that one, right? Then on this script, game over UI, on this one on start, main menu button, call it with it selected, great. Then over here on the land UI, on this one on start, let's start with that one selected, so next button dot select. And finally over here on the pause UI, same thing, let's do resume button dot select. Okay, let's save all our files. And let's make the menu also usable from the gamepad. So over here for the menu, let's add another binding. And the binding, let's listen, let's use the menu button on the gamepad, so the start, just like that. Okay, let's save, and now we can test. So over here, let's move around, let's use the menu, and if there it is, now I can move around, I can go back to the main menu, and now I can go back to playing again, and yep, everything is working with the gamepad. So let's go, resume, let's try to win and see, so land, there it is. And actually here we have the issue, which is how we technically need to select the buttons when we show the windows, not just on start. So over here, let's actually refactor this. So instead of calling it over there, it's over here on the show. Let's select that button. Same thing on the land UI. Instead of here, it's actually when this one is shown. So yep, like this, now it should be working. Okay, here we are. Let's actually go back to the main menu. Let's play again. Let's go, pause, and yep, okay, that works. Let's go ahead, land, and if that works, now here we are on the second one. And yep, we can do everything, and everything works nicely. So let's go ahead, let's land and see the game over scene. Continue, and there it is. Here we are, back to the main menu, and yep, everything works. All right, awesome. So yep, here we have implemented a really nice main menu. We implement the pause menu, the game over scene. We refactored our loading, and we also made sure that everything is playable with a gamepad. So now our game feels much more like a proper game, although we do have one big thing missing. Right now it's all way too quiet, so let's add some nice sounds and music in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn how to add sounds and music to our game. Okay, so our game is already looking quite nice, quite a lot of mechanics, we've got pickups, landing, and so on, so everything looks quite nice, almost like a proper game, except of course, it is missing one massive thing. Right now it is no sound, so let's add that. Here in the project files, I included some nice sounds, so under the sounds folder, yep, there you go. We've got a coin pickup, we've got a crash, a fuel pickup, landing success, music, and thruster. So let's implement all of these, and as always, let's do it properly. So let's make a script to handle our sounds, so a new monitor behavior, for the sound manager. Let's make this one, make a game object with the exact same name, wait for it to compile, let's attach, reset, transform, and open. Okay, so here let's begin with the simplest one of all, those pickups. And again, first, as always, let's make sure our code is nice and decoupled. That is why we are making the sound manager. Over here, the lander, this is the one that listens to when some pickups are picked up, like over here, the on coin pickup. So we could over here directly spawn an object, but again, that is not the job of the lander. The lander just manages the lander. Sound is very much related to visual, so it should be separate. Spawning sound objects is going to be the responsibility over here of the sound manager, so we're going to keep our code nice and decoupled from the lander. And to keep it decoupled, we're going to do like we've already done, we're going to use some nice events. So over here on the lander, let's make some events. We already have one for the coin pickup. Let's just do another one for the fuel pickup. So another one on fuel pickup. So we have that one, and then we just do literally the same thing, just over here. So on fuel pickup like that. Okay, so it's this simple. Now we can go over here on the sound manager and let's listen to it. As always, since it's an external reference, let's do it on start. So lander, we've got the static instance, and on fuel pickup, let's attach a listener to it. So the lander on fuel pickup, as well as the other one. So the on coin pickup, let's attach that one over there, lander on coin pickup. So we've got both these, and when any of these happen, we just want to play a sound. And the easiest way to play sound is to call the static function audio source dot play clip at point. This one plays an audio clip automatically at a given position in world space. So this one takes in a parameter of type audio clip, which means we need that reference, so let's add it. So up here, make a serialized field, a private audio clip, call the fuel pickup audio clip, and also the coin pickup audio clip. So yep, we've got both these, let's save. And this one compiled because this one has an error, so let's actually comment it out, save, wait for it to compile, and we've got the fields, let's drag them. So the coin pickup, that is that one, and the fuel pickup, that is that one. Okay, so now we can play them. So on coin pickup, let's just play the coin pickup sound like that. And for the position, since this is a 2D game, let's just spawn directly on top of the camera. So camera.main.position, spawn it right there. Okay, like this, and this one, the fuel pickup, play it like this. Okay, yep, that's it. Let's save, let's test. So here we are, let's move and try to pick up the fuel. So as I approach it, yep, there you go, we've got a nice sound effect. And on the coins, yep, there you go, it also played a nice sound effect. All right, awesome. So yep, we've got our two very simple sounds. Let's do two more simple ones. We've got the landing success and the crash. So for these, we already have events. So lander instance, let's hook onto those events the on landed event. So that's the lander on landed. And on this one, on the event args, we already have the landing type. So we can do a switch on that one. Switch on the landing type. In case we have landing type.success, then we're going to want to play the success. So let's go up there and we just need to add both of those. So that's the crash audio clip and the landing success audio clip. So we got both these, and over here we're going to play the landing success on this one. And for every other landing type, which is always going to be a crash, for all of those, let's play that one. So we play the crash landing. Yep, that should do it. Let's save. Back in the editor, let's drag those references. So the crash right there and landing success right there. Okay, let's see. So here we are, and let's go ahead and land nice and slow, landing. Yep, there you go. We've got a nice landing sound effect. Let's continue. And now let's crash. So let's go ahead, touch this. Boom, there it is. All right, awesome. So now let's do the more complex one. Over here, the thruster sound effect. This one is a continuous sound effect. So as long as the thrusters are active, this one is meant to be constantly playing. So for this one, instead of playing it directly through code, instead of that, let's actually go inside our Lander object. Instead of this, let's create a new empty game object for the thruster audio. So we have this, and let's add a component, and we're going to add an audio source component. So if we have that, and for the audio itself, it is going to be this thruster. Let's not make it play on awake. Let's make it loop, yep. And over here for the spatial blend, this is a 2D game, so let's put it all the way to the left, nice and 2D. Okay, yep, that's a nice setting. Now we need a script to run this. So let's make that script, new modern behavior script for the Lander audio. And let's add it to the parent game object, just like we did for the visual script. So the Lander audio edit, let's open. And over here, we're going to need one nice reference. Let's add a reference to the thruster. So serialized field of type, private audio source, like we added for the thruster audio source, like this. Then here in the editor, let's drag that reference. So we've got the child object, let's drag it, yep. And over here, first of all, let's start off with it disabled. So on private void start, for the thruster audio source, put enable equals false. And then we just listen to that event where the player is using inputs. So let's exit the Lander, which is actually on the same object as this one. So we can just do a simple private Lander like this. And then we can do a nice private void awake. On awake, Lander equals get component of type Lander. So we grab this one, and then on this Lander, we can listen to those events. So the on before force, let's attach a listener to this one. And then we've got the other ones, the on right force, up force, and so on. So on any of these, we're going to add a new listener. So on right force, let's attach that one. And this one on left force, attach the listener like that. Okay, so we've got all of our nice events. So on the before force, let's just disable it. And then for any of these, we're going to enable it. So just set it to true. So true on that one, and true on that one. And actually over here, it is not enabled because this one will basically stop and start playing from the very start. We want something to resume. So here, let's take pause. And on these, let's actually call play. So play on those. And like this, it should work nicely and should sound good. So let's test. Okay, there's no sound because I'm not touching the inputs. And as soon as I start moving, yep, there you go. We've got our nice sound. So we can go stops and starts, left, right. Yep, there you go. We've got our nice. Although like this, it still leads to some audio bugs if we try to move up and right. Yep, there you go. It gets all messed up. So let's solve that. Basically, the issue is we can't call play once it's already playing. Otherwise, again, same thing is going to happen that I just mentioned. It is going to replay. So let's check if thruster audio source dot is playing. If it is not already playing, then we do play. And if it is already playing, then we don't do anything. So let's apply to all of these and let's test. So here we are, and go up, works, go right. And if there you go, does work, no more annoying sound. All right, awesome. So in terms of sound effects, it's all working. The final thing missing is just over here, the music. So this is another interesting one. Music is meant to loop. So for music, let's make a separate game object. Instead of handling it on the sound manager, let's make another one for the music manager. And on this one, let's reset the transform, add the same audio source component, drag the music, make it play on awake, make it loop, yep. And for the volume, let's put it a little bit lower. Okay, so just like this, if we hit on play, if there it is, the music is already playing, so that's nice. But we have an issue if we now try to win. So let's go win and go on to the next level. And if there you go, that's the issue. Basically, the music restarts from scratch. So that's a bit annoying. It would be better if the music just kept going. So let's do that. Let's make a script to handle the music manager. So a new modern behavior just like that. Let's wait for it to compile and attach it. Then over here, since the music is constantly playing, first of all, let's grab the private audio source for the music audio source. And on private void awake, music audio source equals get component of audio source. Okay, we have it. And then since the music is constantly playing, let's implement a private void update. And on update, we go inside the music audio source. And over here, we basically got the time. This gives you the current playback in seconds, so let's grab that. So private for music time, this is a float. So we grab this one and set this one to that one. So basically constantly updating it on every single update. And then of course, we want this to persist through scene loads. So let's make this a static field. And over here on the wake, we just set it. So set the music audio source dot time equals this amount. So there you go, we're constantly updating this. And whenever we change levels, this one is going to run and it should keep the music on the same time that it was previously. Let's save it. And now we can actually put this on multiple places. So let's make the music manager a prefab. And then let's go on the main menu scene. Let's save it and drag the music manager. And on the game over scene, save it, drag the music manager like that. So if we go back on the main menu scene, and now we hit on play, and the music is currently playing, okay? So let's hit on play and see if it resumes playing. And there you go, it basically continued just the same. So if we get a nice landing, and now we continue, there you go, the music continues nice and awesome. Okay, great! So the only thing missing right now is just the volume. So let's do that on the pause menu. Over here, let's go inside the canvas, inside the pause UI, and over here, let's basically make some buttons. So let's take the resume button, double it up, let's put it up there. This one, call it sound volume button, and inside put sound, and then we're going to have some kind of number. And for this one, let's make this button quite a bit smaller. So over there on the scale, put it something like 0.4, just a nice small button. Then let's duplicate it, put it down here. This one is going to be the music volume button. And inside, say music and then 5. Okay, you've got the two buttons. Let's go inside the pause UI and open it. Here, let's set references to those two buttons. So the sound volume button and the music volume button. So both these. Then here, let's drag those references, the sound volume right there and the music volume right there. Okay. And now here, let's add some clicks. So the sound volume button on click, add a listener, and let's do something. And same thing on the music. So music volume button like that. And for the sound, let's tell the sound manager to change the sound. So let's go inside the sound manager and over here, make a nice function. So public void, change sound volume. And we're basically just going to increase it and then loop back. So up here, let's actually keep track of the sound. Let's put it in a static field so it persists through scenes. So private int for the sound volume. And let's default it to, let's say, somewhere in the middle. So let's say 6. We're going to do it from 0 to 10. So on the sound volume, this one is actually going to be static. Okay, so we have this. And then over here, just do this equals this plus 1, remainder of 10. So this will basically make it loop back once the volume reaches 10. So we can define an int sound volume max equals 10. So we don't use some nice magic numbers. So yep, we do it like this. And this one is basically going to update that. Then let's make a public int get sound volume. So you have this, we return the sound volume like that. That way the UI can actually show it. And up here on the play clip at point, we just need to use our sound. So let's make another one. Public float get sound volume normalized, because that value is an int. Whereas over here, we want a normalized value. That's simple, just the sound volume divided by the sound volume max. And since we're going to use the sound volume max on multiple places, let's actually define it as a constant. So private const int sound volume max, set it to 10 like this. Then down here, let's use that one and let's divide that one by that one and return it. And since both these are ints, we need to make sure to convert one of these into a float in order to make this math work. So convert this one to a float and then divide it by the sound volume max. Okay, so that's great. So now we can finally use this one over here. So it is going to update the sound on every single one of these items that are spawned. So on that one, and that one. Okay, that's great. And finally, let's just update the UI. So over here on this one, let's access that. So sound manager, which means we actually need to implement the Singleton pattern. So let's do it just like we did, super simple. Public static sound manager, the instance with a public get and a private set. We have this, and on private void awake, over here set the instance equals this. So now on the UI, access the static instance, get the sound volume. This is how we're going to update the sound volume button, which means we're going to need to have the text. So up here, let's set another field of type text mesh pro u GUI for the sound volume text mesh, and same thing for the music volume text mesh. So we have both of those. And first, let's enable the sound. So over here, since we're going to access an external reference, let's do it here on start. So that one dot text equals sound, and then the sound manager dot instance dot get the sound volume, and then we update the sound after we change it. So over here, sound manager instance, and just change the sound volume. Okay, that should do it. That should be changing the sound volume. It should be updating text mesh, and it should be using the new volume over here when something happens. There's only one thing missing, which is how we made the thrusters differently. So over here on the Blender audio, we also need to update this one. And the trick is just, when do we update it? So do we update it all the time? Nope, that would not be good. So as always, let's use some nice events. So over here, let's make a nice event. So public event, event handler, and the event's going to be on sound volume changed. So yep, we have this one. And now on this event, we can just, whenever we change the sound, so over here, change that one. Let's invoke this event with this and event args.empty. Okay, great. So now over here on the Blender audio, we can just listen to that one. So on the sound manager instance, the on sound volume change, let's attach a listener to this one. And on this one, when that happens, just go into the thruster audio source, modify the volume, go in the sound manager, the instance, get the volume, in this case the volume normalized, like that. All right, awesome. So let's save everything and see if everything is working. We just need to drag the references, so the sound volume text mesh, that one, and the music volume text mesh, that one. Okay, let's test. So here we are, and the music is playing. Yep, that makes sense. Let's pause the game. Let's update the sound, and by default start off at 6, so that's correct. Let's put it super loud, so put it on 9. Let's resume. Now I'm going to pick up something. Now I'm going to use the thrusters and pick up something. And there you go, that's pretty loud. Now let's go back. Put it down to 0, now it should be muted. So now as I move, yep, there you go, the sound is muted. Alright, awesome. Now let's handle the music. So the music is going to be very much the same thing. So let's implement the maximum just like we did over there. So over here on the music manager, we're going to have a private static int for the music volume. And the music should be a bit lower by default, so let's say 4. Then we're also going to need the maximum by itself. So the music volume max, let's also make that one, the music volume max. And then we're going to have basically the same functions. So let's do these. Let's go there, except it's changed the music volume, then get the music volume and get the music volume normalized. Yep, like this. And now for the variable, it's music volume instead of sound volume. So let's update all of these. For the sound volume max, it is the music volume max like that. And finally for the event, this one is going to be very much the same thing, except it's going to be different. On music volume changed. And over here, let's spawn on music volume changed. Okay, that should do it. Except of course, we need to update this one since this one is constant. So over here, let's do that one, dot volume equals get music volume normalized like that. All right, so now all we need is just on the UI itself. So over here, let's do the same thing. So first of all, let's update the sound, the actual text. So that one says music, then go in the music manager instance, which means we need to implement that. So up here, public static music manager instance, with a public get and a private set. So we have that one. And over here on awake, instance equals this. So now over here, we can access the instance and get the music volume, just like that. And then over here, we're going to do basically the same thing, but on the music manager. So that one like that. Change the music volume. And then we update it saying music. This is the music volume text mesh. And get the music volume like that. And finally, we just need to update the volume on start. So private void start, and on start, let's just update it like this. All right, that should do it. Let's save and let's test. Okay, the music is playing. Press on escape and let's go there. Put it a bit higher, and it is quite a bit higher. Now again, and there you go. Now it's nice and muted, and now it's real low. So yep, here we implemented some nice sound effects and music to our game. We've got thrusters, we've got pickups, success, crash, and so on, as well as some nice music. All right, awesome. Hello and welcome, I'm your code monkey. Alright, so we've already fully built the game according to the classic design. We have our lander that we can control, it moves around using physics. We have the various landing pads with different difficulties and score multipliers. We can move around, pick up fuel, pick up coins, and land somewhere. If we land too rough, we fail, so we can retry. And if we land softly, yep, we have a success and we win some score. We do that, and then we get on to the next level. So yep, that's awesome. But since these classic games usually have very simple designs, that means that makes them perfect for expanding upon. So in the next few lectures, we're going to add some bonus mechanics to make the game a little bit more interesting. We're going to add a nice cargo transport mechanic. We need to pick up from a certain point and drop it off elsewhere. Then based on that mechanic, we're going to implement a key door system. If we drop the key on the right place, it opens the door and we can move through it. This will also be a great opportunity for us to learn about a very important Unity feature, scriptable objects. So this will be a fun mechanic to make and a very educational lecture. After that, we implement a fun wind zone. This is a simple area that applies an automatic force to the player. This can make for some really nice fun levels. Next, we implement some nice moving obstacles. These are pretty simple, just some asteroids moving around that the player has to dodge. And finally, we're going to implement some turrets. These look at the player and shoot. The player needs to dodge the bullets and keep on moving. So yep, we're going to implement all these fun bonus features to expand upon the original game. So let's start doing that in the next lecture. Okay, so these bonus mechanics, these are exclusive to the premium version of the course. If you can't afford it, then that's fine. Using the knowledge you already gained in this course and looking at the footage from this lecture, you can try challenging yourself to build these bonus mechanics. But if you can't afford it, you can get the premium version right now with the link in the description, and you can follow along with these bonus mechanics. Along, of course, with all the other bonuses of the premium version, like the FAQ and quizzes for each lecture in the course. So if you pick up the premium version right now, make sure you go through all the content in the companion project in order to validate that you did gain all this knowledge. Alright, so go ahead and pick up the premium version with the link in the description. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to look at a bunch of things that I did to polish the game. This is always a super important stage in the development of any game. You cannot ignore polish. Polish is what separates good games from great games. Polish are basically all the tiny details that really make a huge difference in the end. So in your own projects, make sure you always take some time to polish your games. It really is extremely important. And this lecture over here, this one is more of an overview lecture rather than a step-by-step like all the other ones. I basically added a bunch of tiny things, so here I'll talk about the various things I changed to get the final polished game. Okay, so let's see what I added. Now, first of all, for this part, I used some nice third-party tools to help me polish the game. First of all, I used the asset Feel. This is a really awesome asset. I highly recommend this one. I have a video review on this asset. I also use the all-in-one sprite shader, so this is another absolutely excellent asset for pretty much any 2D game. I also have a dedicated review on this one. Then I use the text animator. This is another great tool for easily polishing your text. I also use hot reload in order to help me iterate upon the game a little bit faster. And I use my own CodeMonkey Toolkit asset. This is basically a collection of tools and elements helping make games better and faster. So all of these tools, all of these really help me polish the game quite a lot and do it much faster than without them. So great tools are really invaluable and I can highly recommend all of these tools. However, these are obviously optional. You don't need these tools. Personally, I do recommend them because they are insanely useful, but you don't need them. You can manually do everything that we're going to see. And also because these are third-party tools, that means I cannot include them in the project files. I do not have the rights to be able to distribute them. So the final project files you can download are just before the polish lecture. But here I won't talk about everything that I did. So if you want, if you have all these tools, you can replicate everything that I've done. First of all is actually over here on the cargo area. I added a nice little animation over there on the background. For this, I use the all-in-one sprite shader. So over there on the background, I added the add all-in-one shader component. And using this, I can add all kinds of effects to this shader. So in this particular example, I add the hologram effect, the round wave effect, distortion, and twist. So in the game, this is what it looks like. So over here, I've got the nice cargo transport. And there you go. Instead of having just a solid blue color, now it is nicely animated, so it looks a little bit better. Next up were the pickups, so you can already see they are moving slightly. So over there on the fuel pickup and the coins, you can see they are flashing and they are animated. First, for the slight animation, as you can see over there, it is wiggling around. That one is once again the all-in-one sprite shader. So over here for the animation, I just added over here the shake animation. That one basically just shakes the sprite. And then I also added over here the hit effect. But this one, I did not make it active by default. Instead of that, I just made a simple animation, and on this animation, I basically just recorded a keyframe over there, making that one flash. So every once in a while, this pickup flashes, and very much the same thing over here on the coin pickup. So that one also has a shake, also has a flash, and on this one I also added an extra thing. So over here, I added the MMF player, so this is the Feel asset. This one helps you add all kinds of interesting effects. In this particular case, I had the squash and stretch, so as you can see over there on the coins, every once in a while they squash and stretch just like that. And I can also see how they are not all playing at the exact same time. So to do that, over here on the coin pickup script, on this one I use the function periodic. So this is one of the tools in my CodeMonkey Toolkit. This one basically triggers a function every certain amount of time. So basically it's going to play the feedbacks, so those effects by that Feel asset, and it's basically going to play them on a random interval. So that is why some of them will play at some time and others at different times. Next up, I use the text animator in order to animate the text. So over here, as I do a successful landing, yep, there you go, over there for the successful landing, instead of that one being fixed. Yep, now it has a nice animation. And that animation is easily handled through the text animator. So if I go inside the canvas, inside the Land UI, and I'll look inside the title text mesh, and over here, I can see it's using the text animator. And for the effects, it's over here on the behaviors. I just added two effects, the increase effect and the wave effect. And yep, there you go, it makes the text a little bit animated, which looks quite nice. The other thing is this window is also polished, so as it showed up, you might have noticed that it both flashed and did a little squash and stretch. So that is, once again, the MMF player. So over here, I can play this and see, yep, there you go, there's a nice flash, and there's a nice little squash and stretch. So it looks really nice when it shows up. For the flash, I basically just made a separate texture that basically takes in this shape and it's in white, and basically that one just animates over here the alpha. Another thing I added was also a crash, so over here, if I do a crash, I can see a nice screen shake. Yep, there you go, the camera shakes. So the way that is handled is also pretty easy. I've got a crash impulse, so this one has a Cinemachine impulse source, and then on the Cinemachine camera, this one has a Cinemachine impulse listener. So then this impulse over here, this one fires off, so I can manually invoke the event over here, and basically that one triggers a shake. And the way that shake is triggered is over here through the Game Manager visual script. This one has a reference to the crash impulse. And over here, I just hooked onto the lander on land event. And when that happens, over here I check, is it a crash? If it is a type crash, just generate that impulse. The next effect that I added is a subtle one. So as I'm moving around, note how the background is actually moving slightly less than the foreground. That always makes it look really nice. So anytime you have some kind of 2D game, this effect is really nice. That's just some simple parallax background. So as you can see, the stars move less than the actual foreground. So it gives the scene a little bit more of a 3D feel. That's nice. The way that is handled is basically over here on the background. On this one, I had this script, the parallax background. And over here, just a super basic script. So basically just keeps track of the last camera position. So runs this on late update. Keeps track of the last camera position and grabs the new camera position in order to calculate the position delta. And then basically just moves it alongside a certain multiplier. So by doing this, as the camera moves around, the background moves slightly less. Then I also had the ability to grab the pickups from the crate. So over there, as the crate touches the fuel, yep, picks it up and picks up all the coins. So yep, the crate also picks up things. That was another super easy thing to add, just over here on the cargo rope crate script. This one that exists on the crate. On this one, I just did the on-trigger enter and look for those. And then I refactored over here the lander code. Since the code for grabbing the fuel and grabbing the coins was previously written directly over here, since I wanted to call it from somewhere else, instead of copy-pasting the code all the time, instead of just made these functions, then they are called over here by the lander and by the cargo. Next things that I improved was over there on the turrets. Yep, look at that. So the bullets, first of all, they've got a nice trail, so they move around. And then as you can see, there's also a nice animation. There's an animation both on the turrets themselves as they shoot. They've got a nice squash and stretch animation. There's also a particle VFX, some kind of smoke that comes out. And then, like I said, the bullets have a nice trail. So for that, over here on the turret bullet, for the trail, it's very simple. Literally just add a trail render. This one goes down over time, so that is how it thins out. Then for the light 2D, just add a light to make it glow a little bit more. And then on the turret itself, on this one over here, really just add the nice animation. And the animation is very simple. Really just does a squash and stretch on the head. And that's it, just plays this animation whenever we shoot a bullet. So over here on the script for the turret visual, this one over here, it grabs the animator when the turret shoots, so I basically made this event. When it shoots, basically just go on the animator, fire that animation, and then fire off the VFX. Then on the background, you might also have noticed these simple, sort of falling stars, that is what they're meant to be. Really just a visual effect, just to make the game look a little bit more interesting as opposed to being very static. So these are really just physics objects being thrown to the left by a random velocity. I've got a script, the Falling Star Manager. I've got a reference to various falling star spawns, so I basically just manually position all of these game objects, and basically these are all positioned relative to the camera. So there you go, over there, these are all the positions where it's going to spawn, and then the stars are going to spawn on these positions, then move left and fall down with gravity. So for the Falling Star Manager over here, this one just has that list, has a prefab, and basically just spawns it alongside a random chains. So again, I'm using tools over here from my toolkit, the random data and the function periodic. So it is going to call this function every 0.1 seconds, so 10 times per second. But for each time, it is going to randomly test a chance, and there's only a 10% chance that it actually spawns, and 90% chance that it doesn't spawn. Then the lander itself also looks visually different. I've basically added some lights over there, as you can see, both the blue light and the yellow lights. So that is really very simple, just over here on the lander. I just added a bunch of lights, so here I've got a blue light and a yellow light, and really just made a simple animation. So as the lights move, the blue light, that one just moves up and then teleports down. And the yellow light, that one basically just teleports randomly all over the place in order to light up one of those buttons. And the final result is the lander looks a little bit more interesting, a little bit more alive. Next up, I polished picking up the visual effects. So as I go ahead and I pick it up, there you go, there's a nice particle system that spawns. Just a nice little mini explosion, so that's cool. And there's also that second part, the little pop-up that shows both the score or the plus fuel. So those are two nice simple elements, some visual effect and a new effect. For that little element, it is very simple, just over here, the score pop-up. And this one, really, again, just a basic setup. So I've got a background, I've got some text and a white part, and then really just an animation, so the white part becomes lower than the alpha, and then really just nice squash and stretch. Then on the text itself, this one over here just calls the set text, and the way this one is spawned is over here by the Game Manager visual script. So this one has a reference to the score pop-up prefab, and when the lander picks up fuel or coin, then basically just spawns that one, and then tells it to set the text, and either set the text to either fuel or the score amount per coin. Another simple visual thing is over there on the landing area. So as you can see, we've got some nice simple lights, super basic. Again, literally just two lights position, and it's got a manual animation. So really they just change color and they play around the intensity. Yep, there you go, nice and simple. The other thing we can already see right now, which is the fuel low effect. So basically whenever the fuel goes under a 30 amount, if I spend a bunch of fuel, if I go under 30%, yep, there you go, that one spawns. We can see nice chromatic aberration on the corners, and we can see this little UI effect. and when you pick up, it basically disappears. So that one is handled over here on the canvas. So I basically just made another window, so the low fuel UI. This one, there it is. So just set up kind of like that with low fuel. And it's got a simple animation, so the animation again, really just flashing nice and red. And for the animation over here, I'm also modifying the low fuel volume, so basically that's a second volume component. This one is also marked as global, but has higher priority. And then over here on the animation, basically just plays around with the weight like that. So that is basically how it's going to increase and decrease both the vignette effect and the chromatic aberration. So that is why that one flashes kind of like that. And then for showing it, it's a very simple script. So over here for the low fuel UI, this one really just asks the lender for the fuel amount normalized, and if it's on this amount it shows, if not it hides. And finally I really just added multiple levels. So I just did basically the same thing, so basically just duplicated the prefabs and made a bunch of them. So here I've got level 1, just built it up like that, placed all of our elements. Then on level 2, placed a bunch more elements just like that. On level 3, yep. I also changed the color of the background, just make it look a little bit more interesting. So I'll literally just recolor the texture. So level 3, then level 4, this one has a bunch of turrets, a bunch of coins, and level 5, this one has a bunch of wind zones, a bunch more coins, fuel, cargo, and so on. Alright, so yep, so those are all the tasks that I did to polish this game. As you can see, it's a ton of stuff, but those are all tiny things. But if you compare the before and after, you can see how all those tiny things put together, how they all make a massive difference on the final game. So that is why I say you should never ever neglect not polishing your games. That should always be something you always do whenever you're about to publish your game or show it to someone. So whenever you're going to either go into the full release or go into a demo release, whenever you do any of those things or make a trailer, whenever you do that, always make sure you polish it before. Because again, in just a few minutes, in just a few hours, you can take the exact same game and take it from looking relatively boring to looking really awesome. So absolutely do not neglect polish. As you can see in this lecture, it makes a big difference. Hello and welcome, I'm your Cinemachine. In this lecture, we're going to take a look at our final polished game. Okay, so let's take a look at our final game, starting off over here with the main menu. Very simple, really just a functional main menu. So we can go ahead and just play. And then here we are on the first level. So right away we can see how the level is set up. So we can get a nice overview of the entire level. That way the player can make a decision. So do we go for the easy landing over here with a multiplier of 1? Or do we go for the hard one over there with a multiplier of 5? We can also see where all the coins are, all the fuel and everything. We can see everything looks really nice, really polished. And as soon as I press a key, it is going to start moving. So as soon as I press, yep, there you go. Now I'm controlling my lander. It is falling down with physics and I need to control it perfectly. So I need to move left, right, and so on. Now if I want, I can go for the easy one, but nope, let's go for the hard one. So let's pick up some fuel, pick up a bunch more coins for some extra score. And over here for the landing, we need to make sure to land nice and softly. Just like that. Yep, there you go. We've got a nice successful landing. Now we can continue and go on to the next level. So here we are, and again, we can see the whole level. We can decide upon our plan over where we're going to go. So let's go ahead, start moving. And on this level, we also have a new interesting mechanic. So here we've got the cargo transport. So you basically need to hover over this area in order to pick up some cargo. And there you go, the cargo spawns, and it is being controlled using physics. So we need to be careful. If the cargo hits the terrain, we'll lose. So let's make sure to pick up all of these things, grab some fuel, and over here we can pick up some more coins. So grab all of them, and here's the drop-off area. So we need to hover over there in order to drop it off. And there we go, we've dropped it off, we got some bonus score, and now we can go back and try to achieve our landing. Our landing is down at the bottom of this hole, and we currently got low fuel, so we need to make sure to land nice and soft and quickly. Yep, there you go, just like that. Alright, so here we are on the next level. So this one is nice and different. We can already see a bunch more mechanics. And of course, we can also lose. So if I move ahead, on this level we've got some nice moving asteroids. And if one of them touches me, yep, there you go, I've got a nice crash. So on this level, let's go ahead and let's pick up a bunch of coins. So all of them really nice like this. Then over here, let's pick up a key. So we've got a nice key door system. And using this key, we can now move around, make sure to dodge those, and currently got low fuel. So let's bypass that asteroid, pick up some more fuel. And now try to deliver this key. Make sure that the crate does not hit the sides. Yep, there you go, I've got it. Now let's see if I can actually make it through. So I'm almost out of fuel. Let's see if I can land. And yep, there you go, nice successful landing. Then here we are on a very complex level. We can see we've got some keys, we've got some doors, we even have some turrets. So this one I can start moving around, and I have to go through this area over here. First, gotta bypass all of these, pick up a bunch of coins. Now over here, if I want easy mode, I could just go ahead and land there, but I don't want. I want to go for the hard mode. So let's go ahead, pick up the green key. And now over here, I've got to go nice and easy. Land over there, get some fuel, put up the green key, open up the green door, pick up the blue key so that I can go onto the blue door down there, pick up some more stuff, and got some more fuel. And now let's go open up this nice horizontal door. And yep, now push through it, and now we've got some nice turrets. So I've got to make sure to dodge those turrets, Make sure those bullets don't hit me. And yep, there you go. I've managed to get through. And now just another nice soft landing. So gotta make sure to get it easily. So like this. And yep, there you go. Another nice landing. And now here we are on the level with another mechanic, the wind zones. So over here, as I go inside, basically these zones push me into one direction. So I've got to keep forcefully getting myself and try to dodge the sides. So here I go again. Let's try going left over here, then going right over here on this one. Then this one pushes me down into the left. Let's see if I've got enough fuel. Then this one pushes me up way too much. And yep, there you go. Let's go ahead, pick up some cargo. And now with this cargo, let's move out. Make sure I can reach the other side. Pick up some coins, get some nice score right here. Get all of them. I've got low fuel, so let's pick up some more fuel. And now go pick up all of those and continue going. And down here, there's the cargo area. So let's pick up some fuel, drop off the cargo, get a bunch more score. And afterwards, now I can go here and I've got a nice, easy, soft landing just like that. Okay, great. And if there it is, we've got a game over and we have our final score. All right, so yep, so here we built a ton of stuff. We really made a really nice 2D game. We have physics, we have inputs, we have sprites. We learned how to implement all kinds of mechanics. We learned how to handle collision detection, how to set up the logic for the landing detection, how to manage physics, and a bunch more. We also learned how to make the terrain using SpriteShape, how to work with 2D sorting, how to set up the UI, how to handle music and sound effects. We also learned how to make our game playable with a gamepad or touch, and then we implemented some more mechanics that built upon the classic game. So yep, here is a really nice, simple Unity 2D game. I really hope you enjoyed following this course and managed to understand how you can make your own Unity 2D games. I also hope you really went through the companion project and did all the quizzes and FAQs. If not, then I recommend you go do them now. Going through those will help you truly learn the concepts of this course. And if you get something wrong, you can just go ahead and rewatch that lecture, or feel free to post a question in the comments and I'll do my best to help. Again, remember how you only learn by doing, so take some time to actively test your knowledge to ensure you have really learned all the contents in this course. Hello and welcome, I'm your Cinemachine, and congratulations on going through this entire course. I really hope you learned a lot. I hope you now feel capable of taking the knowledge that you gain here and apply it to make some really awesome 2D games. Using the core concepts that you learned here, you can definitely expand upon them to make pretty much any game in any genre you can imagine. And not just 2D games, since 2D and 3D are very similar. If you fully learn everything in this course, you should be able to make 2D games, 3D games, pretty much anything. This was a fun course to make, I definitely enjoyed making it, so I really hope you learned a lot. As always, feel free to post any questions or comments in the comments on this YouTube video. I check those every single day and I do my best to answer. If you found this free course helpful, then consider picking up the premium version. That one has a bunch of really nice bonuses. If just a tiny percentage of people pick up the premium version, I can continue making awesome free courses. And if you do pick up the premium version, then now take the time to go through all the quizzes and FAQs. Do that, go through the entire companion project to really test out your knowledge. You should be able to go through all of those and get all of those 100% right. If you don't, then just rewatch that lecture to relearn that thing. But again, it's really important that you apply what you're learning. It is only by doing that you actually gain that knowledge. And of course, also go through the bonus mechanic lectures on the premium version. I really enjoyed making those. Those were some fun mechanics to make. So if you can afford the premium version, that's awesome. You get some bonus content, and I really hope it helps you learn a lot. But if you can't afford it, that's fine. I surely hope you'll learn a ton from this free course. I really hope all this knowledge helps you on your learning journey. Just go ahead and hit the like button if you haven't already. It's a tiny thing, but it really does help. Then if you want to continue learning, check out my other courses. So my free Kitchen Chaos course, this is a great beginner course on making a game kind of like Overcooked. That's another great beginner/intermediate course. My C# course, this one is really great for developers of pretty much any skill set. It covers everything from the absolute basics, like what is a function, what is a variable, and also covers some very advanced topics, things like multi-threading and asynchronous programming. I've also got another free course, this one on making the simplest multiplayer game using Unity's netcode for game objects. Or for more game-based courses, for those, check out my turn-based strategy course. That is an excellent intermediate course on making a really cool game. Or my dots course, this one is quite a bit more advanced, only for advanced users. But if you are an advanced user, this one is really awesome. Dots basically helps you write code that runs literally 200 times faster. That's insane. Or in general, check out my Ultimate Unity Overview course. This one covers basically all the tools and features that Unity has. So if you use Unity in any way, then I really recommend this course. So yep, if you want to continue learning, check those out. Alright, thanks for watching. I really hope you learned a ton, and I'll see you next time.